research institutions continue to be developed through active participation as member of various organizations and international forums. BRIN organizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of various research and innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and revitalizing 4 areas of science and technology, or KST. An integrated area consisting of research laboratory facilities, testing laboratories, and industrial facilities for both startups and SMEs. Tenant office rooms, co-working space, meeting rooms, gallery rooms, and other supporting facilities. BRIN is here to manifest the future of a golden Indonesia 2045 by consolidating science and technology resources and creating a resource ecosystem and research-based economical foundation. Transforming Indonesia as a global reference in the development and application of science and technology, practices, and the good of humankind. Nature is the source of inspiration. Knowledge is the foundation, and to be put in praxis for the sake of the nation.
Making accurate antenna measurements in large chambers and outdoor antenna test ranges, or making long-distance measurements such as testing long cable runs on aircrafts or ships, are not easy tasks. The traditional measurement solution uses a 2-port benchtop vector network analyzer, a VNA, where the user must attach 2 very long test port cables. The problem with this solution is that long cables introduce signal loss, reducing dynamic range. To overcome this challenge, a high-end VNA is required, and components such as low-noise amplifiers are introduced to improve dynamic range. As the frequency of interest goes higher, however, small movements in the test port cables have an adverse effect on signal phase. Introducing the solution to long-distance S-parameter measurement problems, the Inritsu Shockline ME7869A. This modular 2-port distributed VNA can make vector-corrected S-parameter measurements over distances as long as 100 meters. Complicated test setups and lossy cables are eliminated, since the instruments are powered by Inritsu's patented phase-link technology. This technology allows synchronization between the 2 VNA test ports using optical cables. No matter how much the user moves the cables, there's no phase deviation, while system dynamic range is fully preserved no matter the distance between test ports. Now you can confidently test long cable runs from aircraft's nose to tail and wingtip to wingtip, from ship's antennas to underdeck control rooms and antennas on outdoor test ranges, or in large anechoic chambers, all to full performance with a compact and easy-to-use solution. Inritsu, providing excellence in MM wave measurements, covering the distance with our patented phase-link technology, integrated into the Shockline ME7869A modular vector network analyzer. Inritsu, advancing beyond.
Our product is called XDEC, which consists of hardware and software that we created in-house. We integrate our device with the semiconductor chip industry to help them reduce their cost for testing and get more reliable and also high yield of their product. The current problem in the semiconductor industry testing for the chip is because the current equipment is bulky, expensive, and also not integrated. Our solution provides technology that's 20 times smaller, 3 times cheaper, all integrated with easy-to-use software. Our device analyzes the reliability of the chip. This reduces the amount of defective chips and also puts out high yield in the manufacturing. It is important for the semiconductor chip manufacturers. So we have shipped our product to over 15 countries. Now also being used to different applications such as the AI, quantum, and also in data centers. NASA used for the space, US Army for defense, and the NVIDIA for the AI. For those companies, they use our equipment to be integrated with their chip to make it function properly in different applications. One of the best functions of our product is provide the voltage and current. Our equipment helps guide light so it can work properly into different applications.
United, South Korea, Professor Dr. Nasrullah Armi from National Research and Innovation Agency or BRIN Indonesia. We are also delighted to welcome our distinguished speakers from our patrons, Mr. Liu Hunyen from Andritsu and PT Unitronic Jaya, Mr. Taufan Pega from Rohde and Swartz Indonesia, and Dr. Andi Mahendra from Next Lab Indonesia. We also welcome our esteemed patrons, representatives that also come with us today from Andritsu and PT Unitronic Jaya, Rohde and Swartz, PT Mars Sistem Integrasi or MSI, PT Next Lab Global Industri, PT WAP Andalan Indonesia, PT Serviam Abadi Murni, PT Radar Telekomunikasi Indonesia, PT Mitra Sistematika Global, PT Sapta Cakra Manunggal, also PT Merck Chemicals and Life Sciences, PT Dreamtech Lab Science Indonesia, and PT Bank Rakyat Indonesia or BRI. I also would like to extend our warm welcome to our distinguished guests, presenters, speakers, and participants both on site and also through the Zoom platform. For the rundown for the first day of ICRAMET 2025, we will start with the opening ceremony. First, we will have the opening remark from our chair, ICRAMET 2025, Dr. Widya Budiawan. And second, we will have the opening remark from IEEE Indonesia section, Associate Professor Dr. Kurniang Ningsi. And third, to officially welcome we will have the speech from Dr. Budi Prawara as the Chairman of Research Organization for Electronics and Informatics from National Research and Innovation Agency or BRIN Indonesia. And the opening ceremony will end by photo session that will be conducted both virtually and also on site. After the opening ceremony, we will have the first patron talk from Andritsu and PT Unitronic Jaya by Mr. Lee Yun-yen. After that, we will have our first keynote talk from Associate Professor Dr. Satria Zulkarnain Bisri. And then we will have a morning break. Then afterwards, we will have the parallel sessions of 1, 2, and 3, and then followed by the lunch break. After the lunch break, we will begin the parallel session 4 and 5. And then it will be followed by the afternoon break. Then, as the last agenda of our first day, is the second keynote talk by Mr. Adi Bramantyo. Also, I would like to remind all of you, for presenters, speakers, distinguished guests, and also participants, please fill in the attendance form that you can find at the on the wall nearby, if you can see. So you can fill in the attendance forms only once a day. And for the attendance that attending through Zoom platform, that our organizer will send you the link through the chat box. And now we are commencing the opening ceremony. And we will begin with Dr. Widya Budiawan as the chair of ICRAMET 2025. Please come forward, Widya. Dr. Widya.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asrofil anbiya mursalin sayyidina Muhammadin wa ala alihi washabihi ajmain. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluhu la nabiyya ba'da. Amma ba'd. Good morning, ladies and gentlemen. Distinguished Head of the Research Center for Electronics, Professor Dr. Yusuf Nurwijayanto. Distinguished Head of the Research Center for Telecommunication, distinguished Marsma TNI Insinyur Teguh Darmawan MT, Head of the Research and Development Department of the Indonesian Air Force, distinguished representative of the IEEE Indonesia, keynote speaker, experts and presenters, participants, and ladies and gentlemen. On behalf of the organizing committee, I'm delighted to welcome to all participants to the 14th International Conference on Radar, Antenna, Microwave, and Telecommunication, or ICRAMET 2025. This year, the conference is held hybrid, host from a beautiful city, Bandung, by the Research Center for Electronics, National Research and Innovation Agency BRIN, and co-sponsored by IEEE Indonesia section. The theme of ICRAMET 2025 is the next generation electronics and telecommunication for advanced connectivity and sustainability solutions. This reflects our commitment to fostering global connectivity and contributing to sustainable development through innovative and efficient technological approach for better future. In line with this spirit, we are honored to several distinguished experts as keynote speakers who will share their insight on recent development in electronic and telecommunication. They are Professor Dr. Satria Zulkarnain Bisri, an expert in quantum dot semiconductor materials. Professor Dr. Katia Galuh, an expert in nonlinear quantum photonics. Professor Dr. Nasrullah Armi, an expert in telecommunication. Dr. Hai Won Kim, an expert in RF and MRI. And the last is Mr. Adi Bramayantio, an expert in AI infrastructure. The organizing committee extends its sincere appreciation to all keynote speakers for their valuable contribution and willingness to share their expertise in this conference. ICRAMET 2025 accepted more than 50 papers for presentation, organized into 7 tracks with an accepted rate of 63.4% after carefully single blind review process. So congratulations to all presenters. We are proud to have participants from various countries, including India, Iraq, Canada, China, Philippines, and of course, Indonesia. I would like to express my gratitude to all members, the organizing committee, for their dedication and hard work in preparing this conference. Our appreciation also goes to IEEE Indonesian section as co-sponsor, our patrons, Rohde and Swart, Anritsu Unitronic Jaya, Mars System Integrasi, and PT Nixlab Global Industry. I also thanks to PT WAP Andalan Indonesia, PT Serviam Abadi Murni, MSG KSET, and RTI Group, and PT Sapta Cakra Manunggal. Also, thanks for the support to the DreamTech Lab Science Indonesia, BRI, and MARC. My heartfelt thanks also go to advisory panel, scientific board members, reviewers, and all individual and organization who have contributed to the success of ICRAMET 2025. I hope this conference will be serve as platform for exchanging knowledge, idea, and research outcome, fostering collaboration and innovation in the field of the electronics and telecommunication. That's all of my welcoming speech, and thank you for your attention. Happy conferencing and good day. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Widya Budiawan. And moving forward, from our technical co-sponsor, we will hear an opening remark from the 2025 IEEE Indonesia Section Chair, Associate Professor Dr. Kurnianingsih.
The Honorable the Head of Research Center for Electronics BRIN Indonesia, distinguished speakers, respected participants, and esteemed colleagues. Good morning. My name is Kurnianingsih. I'm currently serving as the IEEE Indonesia Section Chair and the Vice Chair of Professional Activity in the IEEE Region 10. and the Committee of the IEEE MGA IT Coordinations and Oversight, and the Committee of the IEEE MGA Ad hoc on New Audience. On behalf of the IEEE Indonesia sections, it is my great pleasure to welcome all of you to the 2025 International Conference on Radar, Antenna, Microwave Electronics and Telecommunications, ICRAMET, hosted as a hybrid in Bandung. This year, IEEE Indonesia sections is proud to serve as the financial co-sponsor for this conference in collaboration with our valued partner, Research Center for Electronics, BRIN Indonesia. This sponsorship underscores our strong commitments to strengthening the quality of conferences organized in Indonesia. I would like to extend my heartfelt congratulations to the organizing committee under the leadership of the General Chair, Dr. Widya Budiawan, and sponsors and supporters. Your dedications and hard work have brought this important platform for knowledge sharing, collaboration, and innovation to life. I would also like to express my sincere appreciation to all speakers for your willingness to share your expertise and cutting-edge insight. And of course, I would like to extend my warmest thanks to all participants for joining us today. For those who may be new to the IEEE, the Institute of Electrical and Electronics Engineers is the world's largest technical professional organization with over 500,000 members in more than 190 countries, including more than 189,000 student members. Our mission is advancing technology for the benefit of humanity, and IEEE leads in standards, publications, and conferences. Here in Indonesia, the IEEE Indonesia section was officially established on 16 February 1988. So this year's IEEE Indonesia section marks as a 37th anniversary of empowering local innovations and global engagement. As of 11 November 2025, our member reached 2,972 members, almost 3,000 members, and our members keep growing year by year. I'm truly privileged to lead the IEEE Indonesia sections this year, supported by passionate and committed executive committee. Our strategic directions is strengthened and shaped by the advisory committee, who were the past IEEE Indonesia section chairs, whose visionary leadership continues to guide our growth and development. Currently, IEEE Indonesia section has 16 chapters and 6 joint chapters. We also have 44 active student branches and 8 student branches under chapters and 7 student branches under affiliated group. Our theme this year is Unity in Diversity, Bridging Cultures, Empowering Innovations. So we focus on 7 strategic programs. So first, integrating diversity, equity, and inclusion across all activities and partnership. We strengthen collaboration between academia, industry, government, associations, and wider community. We advance humanitarian technologies and promote impactful community service programs. We also improve the quality of IEEE conferences and publications in Indonesia. We support the professional development of students, ensuring a smooth transitions into a global workforce. We also focus on reaching new audiences by identifying underserved communities across geographic, professional, and demographic lines. We promote cross-organizational unit collaboration to expand our reach and impact. This year, ICRAMET 2025 explores 7 topics in the area of remote sensing and radar system, antenna devices and technique, radio frequency and microwave, wireless and wired communications, electronics material, signal and image techniques, and mechatronics. All of these topics embody IEEE's mission to advance technology for humanity by emphasizing practical solutions in critical sectors, transforming industries, enhancing quality of life, and fueling innovations. The work you present and discuss here will have far-reaching impacts across many sectors. As the chair of the IEEE intersections, I'm truly excited to witness the exchange of ideas and the formations of new partnerships and the collective of innovation during this conference. Let us continue to collaborate, inspire, and lead as we advance technology for humanity together. Thank you for giving me the opportunity to address you today. I wish you a successful, productive, and memorable experience at the 2025 ICRAMET. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Associate Professor Dr. Kurnianingsi. And now we will hear the welcome speech from Dr. Budi Prawara as the Chairman of Research Organization for Electronics and Informatics, National Research and Innovation Agency or BRIN Indonesia.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, distinguished Head of the Research Center for Electronics and Head of Research Center for Telecommunications, distinguished Laksda TNI Dr. Arif Harnanto, distinguished Marsma TNI Insinyur Teguh Darmawan, esteemed keynote speakers, distinguished expert, invited guests, participants, ladies and gentlemen. Let us begin by expressing our gratitude to the Almighty God for His blessing and guidance, which have enabled us to gather here today in good health and high spirits. It is my pleasure to welcome you all to the 14th International Conference on Radar, Antenna, Microwave, Electronics and Telecommunications 2025, organized by the Research Center for Electronics and co-sponsored by IEEE Indonesia sections. This conference serves as a valuable platform for researchers, professionals, and practitioners to exchange knowledge and share insight in advancing science and technology. Today, we focus on smart electronics, advanced telecommunications, energy sustainability, and their impact on modern lifestyles. By fostering innovation, interdisciplinary collaborations, and the exchange of knowledge, we can broaden participation in the developing solutions that address present challenges and pave the way for sustainable future. This event provides a unique opportunity to share ideas, learn from one another, and explore how technology can be harnessed responsibly to create a better world. It is also allow us to present innovations that bring real benefits to industry and communities. Through collaborations, we can develop creative and enduring solutions for the challenges that lie ahead. True innovation arises from research that is not only groundbreaking, but also aligned with the needs and aspirations of society. I would like to express my sincere appreciation to Research Center for Electronics, the IEEE Indonesia section, sponsors, and all committee's members for their dedication and efforts in making this conference possible. I also encourage all participants to actively engage in the discussions, take advantage of the knowledge shared through our sessions, both in person and digitally, and build meaningful collaborations. May ICRAMET 2025 be a source of inspirations, productive dialogue, and lasting partnerships. I wish you all a successful and rewarding conference experience. Finally, with Bismillahirrahmanirrahim, it is my great pleasure to officially open the 14th International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications, ICRAMET 2025. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Budi Prawara. And to commemorate this event, I would like to invite all the distinguished guests, speakers, presenters, and also participants to join the photo session. And for the online presenters, please turn on the video while kindly wait for the on-site participants to gather to the front. And then I will signal for both on-site and virtual photos. So please come forward for all participants, speakers, and distinguished guests. Okay, for the online participants, and now we will have the photo sessions, and also, okay, in 3, 2, 1. Also, both on site and the from Zoom platform. Mbak Christine, okay? In 3, 2, 1. Okay, and for the final pose, I think that yeah, we can use that the BRIN. Okay, in 3, 2, 1. Another one, okay. Another one in 3, 2, 1. Another one. Okay, another pose. 3, 2, 1. Okay, thank you everyone. Udah. Okay, everyone, thank you for participating in our photo sessions. And that concludes our opening ceremony. And now we are moving to the first agenda for today's talk. And we will have the patron session from Andritsu and Unitronic Jaya. The talk will be delivered by Mr. Liu Funyan. And the session will be moderated by Dr. Asif Aminullah Fatnan, M.Eng. Before we start the patron sessions, I would like first to introduce to you the moderator for today, Dr. Asif. Currently, he works at the Research Center for Telecommunication, National Research and Innovation Agency, or BRIN Indonesia. He received his PhD in electrical engineering from the University of New South Wales, Australia. And before joining BRIN or LIPI, he worked as an integration engineer at TSMC Taiwan. And upon completing his PhD, he joined Nagoya Institute of Technology, Japan as an international research fellow at Electromagnetics Library. His research interests including metamaterials, metasurfaces, electromagnetics, wireless communications, antennas, and propagations. And please welcome Mr. Liu Funyan from Andritsu and Unitronic Jaya and Dr. Ashif Aminullah Fatnan.
Okay, thank you very much. Good morning for everyone. Welcome to the patron speaker session of the ICRAMET 2025. My name is Ashif and I'm pleased to serve as your moderator for this session. And we are here with our speaker, so it's my great pleasure to introduce you to our gold patron speaker presented by Andritsu, PT Unitronic Jaya. So our speaker today is Mr. Liu Funyan. He's a field marketing manager at Andritsu Private Limited, Singapore. So Mr. Liu Funyan has more than 20 years of experience in wireless industry and spanning RF chipsets and devices with extensive expertise from R&D to manufacturing and field deployment. With his deep understanding in test requirements and challenges, he has helped clients implement cutting-edge test solution for technologies such as beyond 5G, Wi-Fi 7, and silicon photonics. And today he will deliver a presentation titled Precision Testing and Reconfigurable Intelligence Surfaces, or RAS. And so this talk will highlight the testing challenges of reconfigurable intelligence surfaces, addressing some of the challenges including over-the-air measurements, channel characterization, and beamforming validations. So without further ado, please welcome Mr. Liu Funyan.
Terima kasih. Thank you, Dr. Ashif. Yeah. Selamat pagi. It's an honor for me to participate in ICRAMET 2025. Yes. Just hold on a second while we load the presentation slide. Yeah.
Recording in progress.
Okay. So Enricher, yeah, I'm Bunyan from Enricher Singapore, and then it's an honor together with our partner in Indonesia, Unitronic Jaya, to participate in this ICRAMET 2025. So here today, my first sharing is about precision testing of risk. So yeah, please. Or do you mind if I control? Okay, the pointer is this one. Yeah. Okay. Oh, okay. Next, please. Yeah, sorry. Yeah. Next slide, please. Okay, so my agenda will cover basically what is risk, the use case, and in terms of characterizing the risk, and some of the equipment used for the characterization, which is like with the VNA, and then with a signal generator, spectrum analyzer, or even a communication tester, and do a quick summary. Next, please. So before we start on this, just do a quick introduction of Enricher. So Enricher company is a test and measurement company, and it has been first founded as a Sekisan Shah in 1895. So until now, it's already 130 years birthday. Yeah. So we rename it to Enricher in 1931. So the headquarter is in Japan, very close to the Tokyo in Kanagawa prefecture. And we have two main R&D center as well as the manufacturing plant. One is in Japan, of course. The other one is in the US. And for regional wise, Enricher Singapore is the regional office to cover the ASEAN. And yeah, we serve all the ASEAN country. Yeah, next please. And Enricher test and measurement solution, basically it cover from wireless to wired communications. So, and the technology we offered include like the 6G, 5G, radio access network, wireless connectivity, IoT, automotive, installation and maintenance. And the bottom one are something is more hot recently due to the AI booming, the high-speed digital system, optical devices, photonics, and also the data center. Yeah. Okay. Next, please. Yeah. So now let's go straight into what is risk. Next, please. So basically, risk is a short for reconfigurable intelligence surfaces. So it consists of basically it has the meta materials or meta surfaces, and that is used for manipulation of the EM wave. And it can be manipulated in either in a reflection mode where you have a signal illuminate towards the surface and it get reflected. So this is quite similar to what you have from a metallic but surface, but the difference is that yeah, we'll cover more on that, but this one we will have a more controllable environment. Yeah. The other mode is like a refraction, which is a transmission mode where the signals beam towards the surface, it gets through it, but it will be refracted at certain angle and come out on the other side. Yeah. Then of course we have focusing, where you have the incident beams go to the surfaces and then come out focusing to a focal point, or collimation, where you have multiple point of sources come into it and make it to a more parallel. And also we can do like absorption mode, where you absorb certain EM signals. Then some of the components that is usually used are like basically electronically tunable, like pin diodes, varactors, diodes, liquid crystal, and so on. There are basically three main types of risk, be it passive, active, or hybrid. So for the passive is basically, whatever the surface has been designed, then it will manipulate the EM wave according to the specified angle. And for active, it may have to add on some amplification to boost up the power level of the reflected signals. And some hybrid will incorporate some of the other electronic mechanism, for instance, modulated and so on. So basically, the risk, the key advantage on the future adoption is basically it has a lower implementation cost compared to getting a actual repeater, and it has a lower energy consumption because there is not much active components, and it is quite versatile for deployment because it can be coated onto a lot of surfaces like building faces, ceilings, on walls, and basically it also have a relatively low impact on the EM fields. Yeah. Okay, next please. So in terms of the use case wise, so as we understand from the 5G, we have also have a millimeter wave range, and there has been some blockage in terms of the deployment and adoption. One of the key obstacle is because the beam form in the millimeter range, it has easily being blocked by some obstacle object. Yeah. So one of the intuitive use of the risk is a solution to the blockage. So we can kind of like implement it to the wall, and then to do a more controlled kind of like angle reflection of the beaming towards the targeted UE. Yeah. So basically that will help to extend the coverage to reach out to some of the blind spot. Yeah, especially for very high frequency in the millimeter wave range. Next, please. So this is an example of how to do it for the indoor coverage. So of course you have the base station here, and because of the beamforming nature, so it would be blocked by some of the partition in the indoor structure. And in order to reach out to the blind spot, so we can kind of like put up some of the wrist, and then to guide the signals towards to reach out to the blind spot. Yeah. Or we can also do a kind of like cascading to link up, even that the structure of the indoor building could be a bit complicated. Yeah, you can still do the cascading to reach out. Yeah, next please. And even for the outdoor, there is a application for the risk. So, and imagine on a very tall building, so the line of sight may be blocked by the building itself and couldn't reach out to the floor, ground floor. Yeah. So the risk, it can be kind of like implemented on the building structure, the window itself, and do the reflection, and then so that will help to serve the so-called street canyon with such a large panel. And also in the events of, for instance, in a disastrous, something bad, catastrophic happen, and you have the base station that have been serving a different area has been kind of like lost contact and so on, you may consider to deploy a UAV, the drone, to carry the risk panel And then from the base station, from the adjacent base station to kind of like broadcast the signal through the UAV and then reach out the catastrophic area. So this is some of the outdoor kind of like coverage environments. Yeah. Next, please. And also from outdoor to indoor. So I believe a lot of us could face some of the issues, especially when it comes to some indoor area where you totally don't have the connection to the cellular network. So take this partition, indoor partition, for example. So while we do have the source coming through from the windows, but this partition here could be a blind spot. And this is the kind of the profile, power profile that surely show that this particular partition corner here are all very low power being received. But by implementing a risk, so we can kind of like reflect the signals from the outdoor, and then you can see that there is easily a 20 dB kind of like increment on this particular area. Yeah. And so also for some of the underground, yeah, during the car park, you may use some risk structure to guide the outdoor base station signals into it and then get cascaded, reflected, and then to reach out to the car park. That would definitely be a savings compared to keep on building more repeater inside the building. Yeah. Besides extending the coverage, actually the risk can be used for some of the establishing the secure zone. Yeah. So how it does it? Because we can kind of like design it to only beam towards the so-called the area that is designated as a secure. So there could be some eavesdropping so nearby. So if we have been using non-beam forming technique, where we could be kind of like isotropic, then the eavesdropper could easily kind of like tap to the network. But by using beamforming and also together with risk, we can kind of like direct it to the designated area and then isolate the non-secure zone to prevent the eavesdropper to kind of like tap to the network. Yeah. So this is also one of the interesting application. So besides that, there is also a spectral efficiency kind of like improvement. While MIMO has been used in the telecommunication, but imagine from the base station, so you will still have I mean from the all the antenna going to the line of sight to the UE, but implementing a risk provide an additional path. So that will give an additional degree of freedom on how do you want to kind of like manipulate the channel. So in case something is blocking on the line of sight, we still have an alternative path from the risk to reach out to the UE. And also on the in terms of the access to the network, usually the UE will be kind of like registered and then attached to the nearest base station. But if you have the risk, there is a possibility to kind of like to use your neighboring base station to reach out to the subscriber. So sometimes certain location the subscription has been too heavy, then we can kind of like make use of the base station from the adjacent to offload the BC network. So there is also an interesting application for localization and sensing for the 5G advanced and also the 6G. Yeah. So basically, what it needs is that you will basically have a signal and then get an echo and then do the tracking of the object. Yeah. So it requires a kind of like line of sight for the efficient tracking. So again, if it is being blocked, so on the outdoor scenario where we can kind of like make use of the risk and then to reach out to the to sense and then localize it. And even for the industrial 4.0 or some of the automated industrial, you have a lot of robotic arm and that you need the sensing and so on. So besides the direct line of sight, so we can also have the risk to provide a cascaded line of sight, virtual or virtual line of sight, to provide more flexibility and then to get the better performance of the robotic. Okay, next we come to the characterization of the risk. So typically, by default, all the measurements are done over the air, and you would have a kind of like the signal feed, and then beam illuminate towards the risk surface, and then reflected, and then we do the analysis of it. So yeah, usually we will measure what are the maximum EIRP of it, and the key study are covered like the risk gain over the angle, because there is a relationship in terms of the angle between the incident and the reflection. Then probably the 3 dB bandwidth or half power bandwidth, and also some of the channel sounding aspect of it. Yeah. So this this slide show the incidence angle versus the half power bandwidth effective reflection areas. So why it's important is because of how much we could utilize the risk surface to do the reflection of the beam. So in this if you have a direct angle beaming towards the risk surface, usually this will capture provided this let's say a 30-degree kind of like half power bandwidth. So you may have a possibility to capture and then utilize the full risk surface for the manipulations. Yeah. So as we kind of like tilted it a little bit, then we will have some energy getting lost. And if it is shallow, then yeah, much of it could be lost. However, in terms of the deployment, there would be, of course, while it is tried to ideally to be direct beaming towards, sometimes the physical environment may not allow it. So yeah, then the a moderate kind of like angle would be kind of like a compromise between the for the practical deployment between the keeping the effective reflection area versus the installation. And usually we will be using a kind of like monostatic or bistatic kind of like measurements. So I believe for the antenna kind of like industry, this is kind of a common. So by monostatic, basically you have a signal source and then go into the antenna and then beam towards the object and then measure the reflection. So this is also usually make use of the VNA S11. While the bistatic will be, you have a transmitter and receiver at 2 different locations. And depends on the structure and the actual study. So the cable connecting from the instrument to the antenna could be very long, and this will cause some test and measurements issues. I will come to that in the later part. Yeah. So here is an example of characterization of the risk angle over the angle. So you could use a SIGGEN with a spectrum analyzer that will give you a magnitude and some signal analysis. Or easier will be a VNA that we can measure the magnitude, phase, and even some time domain. So we can take a look. So here you can see that there is a particular angle that will give you the most optimum the power reflection, the gain compared to other angles. And if there is a reflector that can be controlled, you will also notice that yeah, by controlling the surface profile, you will get a different angle desired. Yeah. And you will notice that at the wider angle, the power will kind of start to drop. So that also due to the in the slide we shared just now, half power bandwidth, the effectiveness is getting lesser and lesser. Yeah. So when we use VNA and when should we use the SIGGEN or analyzer. So basically, the VNA would be good, especially when we want to investigate the some related to the phase change, and you get the S parameter, yeah, and also to some of the amplitude adjustment ability. So the phase information would be critical, and then you can get the information from the VNA. The disadvantage of the VNA is that, yeah, because of the sensitiveness towards the cable length, so it could be at the short, it could be only maybe a relatively short distance, and it also couldn't measure the modulated signals because VNA is just CW signals, and usually this is done in a more fixed environment using the conventional benchtop VNA. But today I will share with you how ENRICH comes to, even for a field deployment, we can use a VNA to do that. Yeah. For SIGGEN and signal analyzer, it will be relatively easier because you have a two different instruments. So you can put one at the transmit side, the SIGGEN to the transmit side, the analyzer at the receive side. So you can configure various signal conditions, the modulation, the bandwidth, and then you can also analyze the variation over time. Yeah. However, it will be difficult to measure the phase information, and it may be subjected to noise and interference as well. So now let's go through some of the characterization using the VNA. So this is kind of like normal when you do inside a small chamber. Yeah, so we have the directional antenna beam towards the surface, and then you could do a characterization. And in terms of the field environments, so you will involve a larger environment because the physical location could be more complicated. And ENRICH do bring a lot revolutionary VNA. You see, it's a very small, and then it will be easy to deploy on for field measurement as well. So this is ENRICH distributed VNA. I will come more detailed later. So the limitation of the field testing with the conventional benchtop VNA is that you may need to allow very long RF coaxial cable. So the coaxial cable movement itself will introduce some of the measurement instability. Next, please. Yeah. So this is a video showing. So here, this is a coaxial cable, the dark color one. As you see that when one lifted up the coaxial cable and put down, you could see that the phase change quite drastically. I believe for those who have been dealing with the VNA and actually with the working with the coaxial cable, you do often see the sensitive of the movement of the cable towards the measurement. Yeah. Next, please. So for ENRICH, we introduced a breakthrough technology, distributed VNA. So you could see that, so instead of using a RF coaxial cable, we use a different type of, we call it phase link cable, which is basically a fiber optic cable. And we bring the RF port directly to the antenna. So instead of using the coaxial cable, we can connect the antenna directly into the VNA port. So here would be a port 1 here and another port 2. Next, please. So now showing you is the video. Now you see the yellow cable is the phase link cable. As we do the movement, although there would be some changes on the phase, but you will see that it is relatively small compared to just now when we move the RF coaxial cable. So in this sense, even because in the chamber when you do make a lot of movement, we can kind of like compensate all the changes on the movement of the cable and still maintain the accurate measurements. So this is basically the conventional VNA, benchtop VNA. So you have a port 1, you have the long RF cable, And now what we are trying to do is that we cut off the VNA to two different chases. So the conventional VNA has the synchronization done inside the chases. We cut it off, and then we do the synchronization using a fiber optic cable. We call it phase link technology. And we can bring the RF portion, the port, directly to the DUT end, and it can be go up to very, very long distance, and then without much disruption on the measurements. Yeah. Next, please. So this is the our ME7869A phase link enabled two-port VNA. So of course you will have the PC to run the software, and if you have a USB connection, connect to a controller unit. The controller unit will be AC powered, and from the controller unit we can connect all the phase link cable, the yellow color one, and also some of the data cable, and then you have the VNA RF port 1 and RF port 2. So all this you can deploy at the very far distance. Imagine, let's say I can deploy my RF port 1 cases on here, and then RF port 2 at the end of the room. Yeah, and by having a different length of the cable, be it 20 meter, 50 meter, or 100 meter. So yeah, for any usage of beyond 100 meter, yes, we can customize. Welcome to reach out to us for the customization. Yeah. So now let's take a look on how the distributed VNA used for some study on the FR3 industrial use cases, and then for potential deployment of the risk. Yeah. So yeah, usually in the industrial area, you have a lot of object and so on. So if we will have the first port 1 on the end, on this end, and then we connect to the antenna, and the other part that we mounted to a kind of movable trolley, and then we put it on the other end and then move around and then study the profile. Yeah. Next, please. So this is I will show you a brief video on the how when we move around the port 2 and how does the the profile changes in terms of FR3. So yeah, just for information, FR3 is a new spectrum that is a candidate for the 6G that is between 7 gig to about 16 gigahertz kind of like frequency range, and it is getting a lot of interest for the future telecommunication development. Next, please. So you see that when we move the port 2 VNA around, then you see the profile of the power is dropping. As it just get into this corner, you will see that the peak all of a sudden drop by and then definitely over here you do not get the line of sight, and you will have limitation of it, and it will be natural to deploy some of the risk at the corner to direct the signals to it. Yeah. How about some channel sounding study for outdoor or even outdoor to indoor kind of scenarios? Similarly, we can make use of the distributed VNA. We have one end as the transmit, the other end as the receive. And you see a lot of dot over here. They are indexed some numbers. So yeah, and then we will have the designated location for receive, and then each of it will be the transmit. Yeah. Next, please. So this is will be a fixed location for the receive measurements. Next, please. So here will be a two array of the location for the transmit. One for the line of sight kind of like study, another will be the non-line of sight or study, and we will look at the results. Yeah. Next, please. So first, this is a power delay profile using the VNA for the line of sight study and non-line of sight across FR1, FR3, and FR2. So the FR1 is between 2.5 to 4.5 gigahertz. The FR2, 28 to 30 gigahertz. FR3, over here, we concentrate on the 12 to 14 gigahertz here. So if you remember the location index, so what does this chart show us? Let's take a look on the line of sight area first. So over here, you see some of the light blue dot. So this corresponds to the distance from the transmit to the receive side. So the index, yeah, below 30 is the furthest. So that's why there is a longer delay for the signal to reach to my receiver end. But on the index location 40 something here, so actually, yeah, you will see that it kind of like cross over to my receiver, and then later there is some wall over there. You will see some spreading of the signals. And as you look at the FR2, you could, after certain distance, you could barely receive the signals. That is the limitation of the FR2. We couldn't travel too far. But the FR3, we will still receive some signals even that's far. Yeah. So yeah, here you see the FR1 energy spreading. Yeah. Then next, please. Yeah, I see the limitation of FR2. So FR3 is a good compromise for line of sight, even for a long distance. Yeah. Meanwhile, on the non-line of sight area here, so you see that there are a lot of multi-path and extensive delay for the FR1, whereas for non-line of sight, although it is less scattering, but it is being blocked, so you couldn't reach the designated area. So FR3 is a good compromise between the two. Yeah. Okay, next we go for the characterization of SIGGEN and analyzer. So
3 more minutes.
okay, sure, thanks. We will be good. So yeah, we can use a SIGGEN to generate a modulated signal, and usually SIGGEN may be even for a low frequency, we can use a up converter to up convert to the designated frequency spectrum, and then we can use a beamformer, analog beamformer towards the wrist, and then on the horn antenna side, we receive it and go to the spectrum analyzer. So this can do a constellation diagram, EVM measurements, which is it can't be measured using the DNA. Yeah. So this is an example of comparing wrist versus a metallic. Yeah, great. So yeah, we have the transmitter side hidden in this picture. We beam towards the wrist, and then we receive on the other end of the antenna, then analyze using the spectrum analyzer. Yeah, next please. So from the comparison, we could see that at the center frequency, actually, when using the receive power generally is better than just simply using the metallic plate. So you will have some gain enhancement, and there are certain frequency that the gain is more significant than the other of the frequency. Yeah. We can also test using a comp tester. So let's say this is we have the connecting to the base station emulator, then transmit, and then through the wrist, and then to the receive antenna, we feed it back. But you can imagine, next please. You can imagine this as the UE, and we want to evaluate the transmit power, the modulation, quality, EVM, throughput on high frequency. Yeah. So here is a FR3 kind of like evaluation. Sorry for being a little bit blur. Yeah. So there is a good constellation with the wrist. Yeah. No matter 7 gigahertz or up to 12 gigahertz, you can see some of all the dots are clearly demodulated. But without the wrist, so basically you can probably only go up to 7 gigahertz. Beyond that, all the modulation, the EVM constellation becomes smear out. Yeah. Now, interesting one is a real case of how to enhance the coverage across the floor and the indoor partition. So this one, we want to kind of like direct the signal from the 3rd floor, go up to 5th floor, and then to extend coverage in the indoor. Yeah. Let's try to play the video. I'm not sure whether I can play the audio. We try to play.
This commercial building, we need to transmit signals from the lower floors to the upper ones. First, we locate the cable shafts requiring signal extension in the office building. Next, we strategically install X-rifle reflectors in the cable shafts on both levels. We use TMY-TAC B-Box for testing, which can transmit and receive signals bidirectionally. We adjust the signal path between the reflector and horn antenna to keep them aligned. Next, we configure the settings and measure the signal results. To enhance received signal strength, we add an amplifier, ensuring reliable and robust signal reception. While adjusting the reflector angles, we monitor the power sensor readings. Now, the signal at the receiving level achieves full coverage. Let's explore indoor applications. Signal space limitations indoors, changing directions and encountering obstacles, resulting in reduced coverage and dead zones. In this real-life indoor scenario, we're using TMY-TAC B-Box and UD-Box as signal sources. Above, we can see the constellation diagram showing the current signal status. We've set up a reflector with an incident angle of 0 degrees and a reflection angle of 30 degrees to enhance signal coverage in the corners, received through a horn antenna. You can see the signal is strong and fast at the moment. Moving the reflector away proves just how crucial its role is. As we expected, the signal goes back to the blind spot.
Yeah, so you can see that the effect of putting up a wrist and then the corner, then you will get a much better reception. So now let's go to the summary. So basically the wrist is able to transform the wireless environment from a passive, uncontrollable medium to a more intelligent and programmable space. Yeah. So we can optimize the signal strength and also the interference reduction. Yeah. So the potential use case cover indoor, outdoor, O2I, outdoor to indoor, or secure zone, improves spectral efficiency, localization, and sensing. And characterization of the risk typically involve a VNA, SIGGEN, analyzer, also COM tester. Yeah. So here is just a quick overview of the equipment that Enricher offer that could be used for the risk. So of course, the key highlight will be the distributed VNA, but the rest can be used for it. And also there is a very small, handy microwave frequency synthesizer that could go up to 20 gigahertz. Yeah. And with that, yeah, that's I have. Thank you.
Thank you. Thank you so much, and give applause for our speaker today. And now is the, thank you very much for very great presentation. Now time for question and answer. Anyone from the audience here have a question? Or from the online audience also, we can have some questions. Anyone? Okay, if not, I have one question. So we know that the RIS is currently still under research, and we don't have any standard from either from ITU or 3GPP. I don't think we have standard. So how do you you say that you propose or you have a solution for measurement of RIS, but you don't know the standard yet. So how do you do your testing?
That's a great question. Yeah. Instead, ETSI has formed some study group on the risk, and they cover quite a lot of aspect of it, from the characterization, the requirement, and even the node deployment. You can search the ETSI website. There is a study group on this for the risk deployment. Well, yeah, probably it may not the reflection version of it is the simplest to implement, but it may take some form of variation to make it more mature and then to be more easily being adopted. Yeah. So I would say, yeah, 3GPP wise haven't really adopted it, but the European standard ETSI. They have been working on it, and I saw the last updated document is around June or July this year.
Okay, very interesting. Okay, any other questions from audience? Okay, Mr. Iman, Dr. Iman.
Okay, thank you very much. That was nice, insightful presentation. So, if I'm not mistaken, as I'm so far that the use of meta surface or risk can eliminate the need of analog front end. So, could you please explain to me how large the bandwidth can be reflected by the risk or meta surface in communication? Okay, thank you very much.
Thank you for the question. Unfortunately, I'm not the expert in terms of the risk technology fabrication and so on. Yeah, so of course we do have some partners to work on the risk. So we can kind of like link you to the for instance the TMY Tech is one of our partners to that work on the risk technology. We can refer you to the on the design aspect of it and the research aspect of it. Yeah. And research is more on the testing aspect of it.
Okay, yeah, one more question, please.
I have one quick question.
And please introduce yourself. Right?
Yeah, I'm Dr. Yashwant from India. So I represent Manipal Institute of Technology. So that's my university. Yeah, do you have distributors in India as well? Like how to proceed with this?
Okay. For the enricher equipment, yeah, instead we do have a enricher India office. They are located both in Bangalore as well as in New Delhi. Yeah.
Yeah. Thank you.
Thank you so much. And we still have 1 minute questions. Any other question?
Maybe I request, could you just one slide up?
Oh, wait, okay.
One slide.
Well, before, one slide before.
Yeah. So yeah, I welcome you to kind of like subscribe and then follow our LinkedIn page or our Facebook page, so you could get some of the latest update, because we are not only covering the RF, we cover also the wire, quite a wide aspect of the test and measurement. Yeah, you may follow our webpage. Yeah, and then to get the some of the latest update on the test and measurement. Yeah, thank you.
Thank you so much. Thank you. Give applause again to our speaker. And we thank you very much for Anritsu for being the gold patron for our conference. And before closing, we, on behalf of organizing committee, I'd like to present the token of appreciation for Mr. Liu. Thank you very much. And we will move to the next session. Thank you.
Thank you, Dr. Ashif, and also thank you, Mr. Liu Funyan from Anritsu. And also I would like to thank Anritsu and PT Unitronic Jaya for having brought to us the first patron session. And also we would like to give out the token of appreciation for, to Anritsu and PT Unitronic Jaya. So the representative from Anritsu, please come forward to the stage. And I also would like to welcome Professor Yusuf Nurwijayanto, PhD, to handing in the token. Okay, thank you to Andritsu and Unitronik Jaya for having continuous support to ICRAMET along these years. And also, I hope you found this session informative and brought valuable insights to you. And now let us turn to the next item on our agenda with a keynote talk by Associate Professor Dr. Satria Zulkarnain Bisri from Tokyo University of Agriculture and Technology, Japan. The session will be moderated by Dr. Eri Dwi Kurniawan. And first, I would like to introduce Dr. Eri Dwi Kurniawan as the moderator. Currently, he works as a research fellow at the Research Center for Electronics, National Research and Innovation Agency, or BRIN Indonesia. He received his doctoral degree in the Engineering and System Science Department at National Tsinghua University, Taiwan. His research interest covers micro and nanoelectronics devices, particularly nanoscale transistors, including design, simulation, and fabrication, micro or nano electromechanical system, and or MEMS, sensor technology, and embedded system, such as microcontroller, programming, system on chip, etc. He also has been appointed as the focal point Indonesia for ASEAN Subcommittee for Microelectronics and Information Technology, or as CMIT, since 2022 to the present. Please welcome Dr. Eri Dwi Kurniawan and also Associate Professor Dr. Satria Zulkarnain Bisri.
Good morning, distinguished keynote speaker, chairman of ICRAMET, and also head of Research Center for Electronic BRIN, also all speaker and all participant of ICRAMET 2025. In this session, we will have a keynote talk from Associate Professor Satria Zulkarnain Bisri from Tokyo University of Agriculture and Technology, Japan. He is an associate professor and also principal investigator of the Sustainable Quantum Nanomaterial and Devices Semantic Laboratory at the Department of Applied Physics and Chemical Engineering. He completed his master and PhD from Tohoku University in 2011. Then he worked also as a postdoctoral researcher at the University of Groningen, Netherlands, before he joined RIKEN CEMS in 2040. And prior to this current appointment in 2022, he was a senior scientist of RIKEN CEMS, and his research focus on the material physics, particularly on colloidal nanocrystal, quantum dot, organic semiconductor, and carbon nanotube to develop and exploit the design material for energy converting, energy storage, and also for low energy consumption of the electronic device. In this session, he will talk the title about the his title is Material Discovery in Colloidal Quantum Dot Solid for Adaptive Sensing Application. Please, Dr. Satria Zulkarnain Bisri, you will have a 30-minute presentation.
Okay, so yeah, thank you very much for the introductions. It is a pleasure for me to be here in the conference of radar, antenna, microwave electronics, and telecommunications. Okay, so basically I come from Tokyo University of Agriculture and Technology, from the Department of Applied Physics and Chemical Engineering. And also, actually, my chair is on the Advanced Electronic and Electronic Engineering. So before we start, to manage your expectations, so I'm a physicist. More precisely, is material physicist. So I will try to guide you about my research field, which is on the colloidal quantum dot solids. And then I will try to show you that there are prospects to somehow approach the problems that you face in your field through material science. Okay? So before we start, I'd like to introduce you first about my university. So Tokyo University of Agriculture and Technology is actually a national university, so funded by the government. So different from the big university like University of Tokyo, Osaka University, or Tohoku University. So Japanese government also have the specialized university, like maybe you know like Tokyo Institute of Technology. So TU80 is one of them that specialize on agriculture and specific engineering. But maybe something related closer to this field is the University of Electrocommunications. So actually, our university is quite small. So consists only of 2 faculties, agriculture and engineering. But if you are considering the performance by, for example, the productivity, we are actually among the highest in Japan. In terms also related with the student staff ratio, and then the number of our student that goes through graduate school. So almost like 80 to 90% of our bachelor student goes to masters, and then some of them go to PhD. So in principle, in terms of the productivity from the industrial income, as well as the number of papers per faculty, we are, yeah, if not number 2, we are number 3 in Japan. And we are really close to the city center. So if you have chance to come to Tokyo and then you play around in Shinjuku, yeah, our campus is only like 30 minutes by train from Shinjuku itself, okay? So our university is quite old. So the history goes back to 150 years ago, especially for our faculty of engineering. It starts from the silk. So when the major restorations comes, so Japan opened itself to the world. So then they need to sell, okay, what are the best product of Japan, which is silk. And then there are many diseases, then we need to improve also the production methods. That's the reason why Japan built the silk disease experimental research center at that time. And then now it become the faculty of engineering of our universities. So now, ever since our reorganizations, we have 6 departments in our universities, in the Graduate School of Engineering. Maybe some of the research field are relevant to this community is that like sensing, biosensing, like this is from developing new kind of USG technique, and then superconducting material for MRI applications, some environmental robots. And also in our department, there are one specific research group that their research is related only how to make electron microscope. So we have a really good relationship with GEO, which is one of the biggest electron microscope company, where basically we do research together. And then also we have this next generation supercapacitor research center, which is also the big research direction in our universities. And then also we have the Smart Mobility Research Center, by which we also collaborate with many different kind of car companies in Japan. So we try to make the boundaries between department as minimum as possible, so then we can do all these research collaboratively. And one of them is actually my laboratory, so which is the Sustainable Quantum Nanomaterial and Devices. So we work in the Department of Applied Physics and Chemical Engineering. The reason is simple, because for some of these research topics, we really need very strong chemistry, and also we really need strong physics, especially the solid state and electronic properties physics, because device, any electronic device, be it for microelectronics, for radars, the device are actually the interface. It's not about the material per se, but it is the interface. And the capability to make a good interface, not only between materials, but also between fields, are things that determine the success. And this is something that we want to achieve. How to master the creations of nanomaterials, how to introduce some kind of new technique, not again, simply electronics, but also iontronics, to realize many different kind of functional optoelectronics and energy devices, so they can be implementable in scale applications. Okay, because nowadays, okay, it's not future anymore, it's nowadays we work in the trillion sensor universe. And also the trend is that how to power this trillion sensor universe, then sometime we also need to go to the microenergy harvestings. So sensors are everywhere, right? Starting from around your bodies, to monitor environments, or to drive your mobility, and many different kind of things. Like even like in the single Airbus 380 alone, there are 30,000 sensors. So imagine the number of sensors itself. Okay, and also there's another second trend. There is a convergence between mobility and electronics. So it's getting more difficult to distinguish which company works for automobile, which company works for electronics, right? Even Sony make a car. Even Sharp also make a car, right? And also like Toyota, even they do really big research on electronics, right? Because there are a lot of sensors there. It's not only about the EV, but also we are going to the directions of self-driving mobility, right? Where, again, sensor is everywhere. And also, like, people want to fly as well. Again, it's sensor, actuators, and radars, right? So it's getting convergence. So we cannot work again anymore in silos. Okay, this field for this field for this kind of fields. And also, this is engineering, this is basic science. We cannot work on that part anymore. Everything's converged nowadays. And also, some of the sensors can be also remote deployed, right? So just for imaginations, like in Suramadu Bridge, at least there are 400 sensors, right? Installed in the entire span of the bridge for temperature measurement, winds, traffic, many things. So this is old bridge, right? When I was still undergraduate here, Megawati opened this bridge, right? 400 sensors already. So more modern bridges need better monitoring as well, right? And also smart agriculture need deployment of sensors anywhere, everywhere. The problem is how we will power them, right? So it's difficult to imagine that all these sensors need to be connected to electric grid by cables, right? Cable is expensive. And also cable requires copper. And okay, electric car requires copper, then that's the reason why copper price increase even more dramatically than gold, right? So then we need to think how, if possible, that these sensors need to be able to power themselves independently, right? So that's the reason why IoT terms comes in. And then also that's the reason why trillion sensor universe comes in. And this has become the national platform of Japan as itself. So now to 2025, we are already well above trillion sensor universe. So in order to understand the challenges, to understand what things will come, let's try to dissect this IoT devices. At least if you want to have this IoT device, you need to have these all four components, right? You need to have the sensor itself, and then you need something to power the sensor, like some micro energy harvesters. And then, okay, for the energy stability, then maybe we need to stabilize them, maybe by trying to utilize like supercapacitor or some energy storage device. And then also something that able to transmit all the measured data to some places where we can see, we can analyze them. So the question is, at least for the energy its part, do we need large solar cells, or do we need several hundred watt or not? So basically, we need to start to think from that. Okay, what kind of devices that we need to design, looking into that. So at least we need to find out, okay, probably at least something that more than 40 millivolt generated, right? So thermoelectric start become possibilities. And then obviously solar cell become possibilities. Or even sometimes winds and vibration itself can become the energy source, right? And then also, obviously, we need to use sensor that consume energy as low as possible, but as sensitive as possible, right? And then also some transmitting technology that also very low power, but nice in fidelity, and then it can transmit the data much more clear. So basically, these are the dissected IoT device, and then we may be able to try to address them one by one. Because what you want to do is that you want to deploy trillion sensors, but you want to use resource as small as possible, right? So that's the reason why we need to find out alternative for materials to create those devices. And sometimes you want something that can be fast deployed. So maybe you want just, okay, print the sensor, print the IoT device and send it, for example. Or maybe just send the instruction how to print them and then let people in local place, they print them. So then why don't we start thinking material which are solution processables? Among them, the alternative are organic semiconductors, carbon nanotubes, or colloidal quantum dots, things that I will try to focus now. But obviously, before we can able to deploy them, we will make electronic devices. So it means that these materials that may be in solutions, maybe in form of ink, they need to become thin films. They need to assemble. And then the question is what kind of solid state material assemblies that we will obtain. Okay? So I will focus more on the colloidal quantum dots. The reason is simple. Because I'm a physicist and I like it. So colloidal quantum dot itself is actually a small single crystalline semiconductors materials. Usually the size will be like less than 20 nanometer in size. So you even here you can see the picture of the individual atoms inside the quantum dots. And because of it has a very small size, there is new kind of physical phenomena, so-called quantum confinement effect. So because of the quantum confinement effect, you can change the properties of the material without changing the materials, simply by playing around with the size. So then you can have different color, for example, changing the band gap of the materials. But another important thing is that if you remember again, for example, high school textbook, semiconductor has conduction band and valence band with some band gap. Once it becomes quantum dot, it will behave as if this big new material is a single new atoms because they have band gap and also some discrete energy levels. So it's fancy. We can change the properties of the materials, but it's even more fancier because the creations of discrete energy level, maybe there will be some important quantum application that comes out from there. And also compare with the other material that I showed you before. For me personally, colloidal quantum dots is inorganic materials. So it's really good to connect with the words of helirisasi mineral. So then it will be more sustainable. So we can recycle as well. So it depends. If you want to work with organic semiconductor, for example, you need to have really nice, fine chemical industries. in order to synthesize the individual molecules. On the other hand, here we work with the inorganic materials, which is our own mineral, right? So if we can master this, then you have much better opportunities. Okay, is this material new? No, this material is very, very old. So it just realized recently that even Cleopatra has quantum dots on her hair. Because apparently the reason like Egyptian people that you want to achieve, right? From this kind of technique alone, you can have very nice quantum dot, nanoparticle quantum dot, which is single crystalline. So because you can see how the atoms are aligned, and then the size of the quantum dots are relatively uniform. And by simply changing the size, you can change the absorption spectrum of the materials. In this case, it's lead sulfide. And then also because for this reaction process, you also involve some kind of organic molecules. So in this case, I show you oleic acid. And 50% of our palm oil are actually oleic acid, right? So basically, this is just only a small inorganic ball covered by our own palm oil, let's say. And then they are soluble in solution. So then you can create printable electronics. And by tuning different kind of properties, even you can make this kind of like core cell structures, or even sometimes you can get new kind of novel inorganic compounds. But we want to work with electronics, right? Electronics. So it means electron needs to be able to move from one quantum dots to another quantum dot. So then we can manipulate them. The problem is this palm oil molecule or the oleic acid molecule itself are insulator, right? So in order to manage this electron to be able to move from one quantum dot to another quantum dots, then we need to try to remove this big long molecule with some sort of molecules. So then you can have like quantum interference between quantum dots. Then the electron can move from one quantum dot to another quantum dots. Then you can create electronic devices. So that's the reason why chemistry is important as well. So we can design many different kind of molecules. Even in Indonesia, there's also different kind of the organic sources, and you can try to utilize them, right? And then everything can be done in solution phase. Essentially, you are creating ink, okay? And you can try to create your film with many different process, for example, like spin coating. So these are individual quantum dots and form together. And then before and after ligand exchange like this. And then we create the electronic devices. So which electronic devices then? Okay, let's try to start from this anatomy again. So let's start from sensors. So here I will focus on the light sensors using these quantum dots. So what is photodetectors? So photodetectors is a device that convert the particle of lights and then get synthesized on the semiconductors and then convert some energy of the lights into electrons. You generate electrons there. And then which color that can be measured by this photodetector, it depends on the band gap of our semiconductors, right? So some semiconductor only sensitive for some several limit. And actually for this normal camera, sometimes we need to cool them down because their sensitivity is so weak, because their process are not so efficient, right? Because sometimes they will lose some heat. For example, in the case of silicon, they will lose some heat. On the other hand, if we use quantum dots, we can have much broader span because we can tune the properties of the quantum dot simply already in your mobile phone. For the face recognitions, in agriculture, for example, to find stone within the coffee beans. And then also, this is Sony that also utilize the lead sulfide quantum dots for the infrared camera. You can see the difference, right? To prevent or to mitigate the forest fire by utilizing this SWIR range, you can see clearly where is actually the fire itself. You can see beyond the smoke. So these are the potential for lead sulfide quantum dot photodetectors. The problem is it's still done utilizing this device structures. So we still utilize this quantum dot only as sensitizer with the help of some organic semiconductor structures. So it means the device is still relatively slow, although they are sensitive. Or you can make a sandwich type structure like this, still also utilizing some organic semiconductors. Again, it is also still slow. Some researchers try to mitigate this by introducing two-dimensional material like graphene or molybdenum disulfide because they can conduct electricity very fast, right? So they make these complicated structures, and actually isolating two-dimensional material itself is not a trivial business, right? So then they can increase the responsivity, but with some trade-off of the response time itself, okay? But why we don't just rely on the quantum dots? Again, the problem is the electrical conductivity. To have a good photocurrent in photodetectors, you need a good electron mobilities, you need to have hole mobilities. And also for the gain itself, again, it's related with the charge carrier mobilities inside the semiconductor materials. So at least from 2013 until 2019, what we have done by modifying the silicons, we can improve the mobility in the span. The responsivity of the photodetector can be up to like 100 ampere per watt, which is actually 2 orders of magnitude higher than the normal silicon infrared camera. But the problem is that if we want to enhance further, then the current mobility needs to be enhanced further. So that's the challenge for us, because it will also relate it with by how small the energy that will be consumed by these photodetectors. Okay, talking about the energy, so the micro energy harvesting that can be made need to be also think about, right? So at least for quantum dots, either these two things can be one possible applications to use quantum dot for source cells or as a thermoelectric materials, because physically from the physics concepts, thermoelectric itself is a nice way to convert temperature different into electricity. And actually it was proposed that colloidal quantum dot array can become the most ideal material for thermoelectric because they can decouple so-called the convergence between the electrical conductivity and the thermal conductivities. In the case of quantum dots, you can try to suppress your thermal conductivity as small as possible. And then also you can have a Z-back coefficient, so how many fold you can generate by some temperature difference as high as possible, as long as you can manage how the electrical conductivity between the quantum dots. Again, that's the challenge. At least some of the researchers, they try to create thermoelectric based on these materials, but yeah, we haven't go that far yet. Different story happens in the case of solar cells. Quantum dot is actually one of the most promising material for efficient solar cells, right? Together with perovskite, together some with the organic semiconductor as well. But we are talking about the IoT, right? IoT devices for micro energy harvesting. So then we don't need to really care about, for example, how efficient is the solar cell module, because usually like if you have silicon solar cell, so silicon solar cell, actually they nowadays they reach efficiency of 30%, right? Research cell. But the solar cell module that you can buy in the market, maybe it's only like 10-15%, right? Because the larger the module that you have, actually the efficiency is actually the lower. On the other hand, we are talking for the IoT device. So it means that maybe it's only like 1 square centimeters, which is actually equivalent size of these solar cells. So then the question is that whether we can keep increasing this thing, so then we can have large energy generation from a very small module. And also for quantum dots, we can do spectral matching because we can change the wavelength of the absorptions so that to be equivalent to the sunlight that comes to the device. And obviously, from the quantum physics, there's still a promise, that possibility to obtain quantum efficiency more than 100%. It has already discovered in the single quantum dots, but it hasn't been manifested for the real solar cell device. Simply the reason is because the electrical conductivity is still very low, right? So that's the reason why people working in this field, they try to make more sophisticated solar cell structure, but actually, again, the bottleneck is still in the electrical transport. Because when people working with the colloidal quantum dot field, this is our dream. So we can create this quantum dot materials, have quantum confinement behavior, so discrete energy level, tunable properties, right? The idea is that when we make the thin film, make a device, we can make nicely well-ordered quantum dot like this. So then the electron can move very fast, but then this film will preserve the properties of this quantum dots, right? Because then we can realize high performance solar cell, photodetector, and many devices. In reality, in the 30 years of history of colloidal quantum dot devices, this is what we always have. This picture is, the picture comes from your quantum dot display, quantum dot solar cell. It is messy like this, right? So then electron is still difficult to move. That's the reason why electron mobility is still very low. And then there are a lot of surface, so it means there may be a lot of disorder on the surface of the quantum dots. For physicists, actually, this material are a big nightmare. So that's the reason why, in order to revolutionize the technology itself, basic science is necessary. How to establish the quantum dot orders, how to really go deep into the understanding how the electron move inside these quantum dots, and then reinvent again the device applications. Okay, so yeah, we start with this kind of work as well. So by utilizing the same quantum dots, same size, same ligands, simply changing different kind of assembly methods, like spin coating, dipping into a bucket like this, or this is something that maybe the ladies in the kitchen, they try to make, when they drop some oil on the soup, you can create some kind of very thin layer at the interface. And then we utilize this kind of primitive technique to obtain different kind of structures. So with deep coding, we can get this porous structure. With this interfacial assembly, we get a compact film like this. But another interesting happens if we really go into the basic chemistry, basic surface chemistry. So we all, at least until the previous slide, I always show you that quantum dot is spherical, but actually quantum dot material should inherit the crystalline characteristic of the compounds. So it means they will have different atomic facets on the surface. For example, in the case of lead sulfide, you have like 100 facet, 110 facet, 111 facets. So it means that the binding energy of each this oleic acid molecule on different facets are different. And then if you change, for example, the soup before you put this quantum dot ink, then you can selectively strip from which surface you want to take out the oleic acids. So for example, if you use methanol, then the quantum dot become naked. And again, the assembly become messy like this. But if you use, for example, DMSO, so only the ligand from 100 remove, then you can get this kind of square lattices. But then if you use acetonitrile, you only clean up the surface, then make the number of ligand more homogeneous, then you can get this honeycomb structure like this. This come from the same size of quantum dot, same type, same size. Okay, we can even do further. After performing this square lattice, we add some additional agent. Maybe you put some other oil there, and then that act as a fusing agent. And then what we obtain is something like this. So all these are the quantum dot connected together at specific facets. So then they are atomically connected, highly oriented. So it means they become a new semiconductor system, which is connected but quantum confined. So the luxury working with the quantum dot is that because we can work with same compound, but different size of the quantum dots with different optical properties, including those at the near infrared or shortwave infrared materials, then we can see they can form different kind of superlattice like this. And then in order to confirm, then we work in this synchrotron radiation facilities to make sure that indeed it is in really large scale, we can obtain this superlattice itself. And we also confirm that all the orientations of the atoms of the quantum dots for the large superlattice are facing on the same directions. So the reason why we really need to go as far as this, because we want to create electronic device. So we need to make sure what we see in our electron microscope are actually the same thing that exists on our device. And in order to do that, we really need to do this basic fundamental characterizations. Okay, now we have nice superlattices. So then what should we do? Then we build transistors. So, but not an ordinary transistors. So we have the quantum dots, and then usually if you want to make a transistor, you need to use, for example, high K oxide for the gate. But here, we use a molten salt. So by utilizing molten salt, so we drop salt on top of our quantum dots, and then after that, we apply some gate. And then by the gate applications, the ions on the molten salt will be attracted onto the interface. It will form a molecular capacitors. So it means that we can operate a transistor in order to obtain very large charge carrier density or very large electric field, even though we only apply a very small voltage. So in order to achieve, for example, this value, carrier density, using oxide gate, you need to apply 1000 volt. But utilizing these gate structures, you can achieve this value simple by utilizing 1 volt operations. So then you can play around with the properties of the materials. So we create the transistors. So this is the monolayer of the quantum dots. And then we put this ionic liquid gating. Then we have nice operations of transistors. And as you can see here, they are different. If you have this epitaxially connected quantum dots, the conductivity is much larger. And then it also means that the properties of transistor is sensitive to anything that attach to the quantum dot. So it means that if you want to utilize this transistor as a chemical sensor, it's possible. And also you can also see that from the capacitance behavior on the number of charge carrier accumulated on the quantum dots can also be modulated by what kind of things connected there. So this is interesting. So we can do basic research and applicational research at the same time, because here what we can see is that we can even unreveal some new physical concepts on how electrons move inside quantum materials. So the old ideas is that quantum dot behave like organic semiconductor materials, where the larger the quantum dot, the electron mobility will decreasing because the smaller quantum coupling between the quantum dots. On the other hand, since we have this epitextually connected quantum dot, we obtain constant mobility, which means the physics are completely different. And then that's the reason why we do the fundamental research by performing low temperature measurement on the system. And for the first time in the world, we realize a so-called phase transition from the insulating behavior of the materials into metallic behavior of material in the colloidal quantum dot systems. So what is the consequence? So the consequence is that if you have this quantum dot connected with the molecule ligands, the electron will simply be able to jump like this. While you have this kind of epitextually connected, the electron can move very fast. That means the charge carrier mobility increase, the physical properties completely change. But then obviously the question is, can we still realize this kind of thing? The multiple action generations or the discrete energy level still there? So at least this is what we did. So we have already in the last so during COVID, we did this experiments. We can enhance the charge carrier mobilities by 1 million times than before by having this epitextually connected quantum dots. So what is the implications on the sensors? Let's go back again to our photodetectors. So these two students, they utilize the same technique. They built the photo detector utilizing a single monolayer of PBS quantum dots. So single monolayer means the thickness of this film is only 8 nanometers. Only 8 nanometers. And then we perform the photodetector measurements. And then what we obtain is that it has very high responsivity, which is already over than the current world record. So basically, improving the charge carrier mobilities can improve the responsivity. And also what we found out is also improve the detectivity by many order of magnitude. So it means that how weak light that you can detect by these photodetectors. So application implications, either for many things that I've shown you before, or it can start open some other possible applications. And it's not only high performance, but also fast, because the response time for this photodetector can work in milliseconds. So then it means now our quantum dots only device can be around here. And with some signature of potential carrier multiplications. So it means that we can show that even from one particle of light, we can generate more than 2 electrons in the system at some specific wavelength. So it means it can become very, very sensitive photodetector, very, very sensitive camera as well. Okay? But obviously there are many beauties for the colloidal quantum dots, and stemming from the synthesis itself. Yeah, for now we rely mostly on this lead sulfide quantum dots, but obviously we want to create many different kind of quantum dots materials, because sometimes through this colloidal synthesis, we can discover new crystalline phase of materials, right? So one of them, things that surprisingly observe when we start exploring with tin, and there's a reason why we did tin, because the student also Indonesian, and Indonesia have like 40% of word thin,
Excuse
right?
me, maybe
Yeah.
3 minutes again.
Okay. So basically here we can realize this kind of things. New kind of thin sulfide quantum dots have never been discovered before, and we can realize nice photodetector device. But it's still in early stage. Performance-wise, it's still lower than lead sulfide, but it's also prospective. It's also the same case with this silver bismuth sulfide. We just recently ventured into these materials. We can realize this kind of nanocrystal of silver bismuth sulfide, more environmentally safe, and we can also realize these photodetectors. Okay, so the thing is, there are many things unknown with many different kind of new compounds. Okay, so maybe only 3 minutes. Okay, let's switch some gear. So I will go to storage and also transmitter. So for storage, even this kind of dipping methods of lead sulfide quantum dot leads to the creation of these pore structures, right? So what we can do with this? We can realize possibility to utilize this material as supercapacitor electrodes, and then we realize this supercapacitor electrode utilizing symmetrical arrangement of those lead sulfide quantum dots. Good performance here, and then by analyzing the power and the energy density of these supercapacitors, actually be the only material out there. And remember, the supercapacitor electrode is only less than 80 nanometer thick, and you can obtain this value. Okay, so the final part is the transmitter. So how can we do this utilizing colloidal quantum dots? The idea is, why don't we try to create this single quantum dot device? So that's the reason we collaborate with 2 different groups. The first one utilizing this technique, the other one utilizing another different kind of electrodes. What we can obtain is that we can realize for the first time single electron transistor operations utilizing colloidal quantum dots. So what is single electron transistor? So it means that the electron that goes into the quantum dot will move one by one. And this so-called Coulomb diamond signify that kind of things. So, and even we can obtain the properties at room temperature. And for communications, SET is actually related with the quantum transductions for quantum sensing and also for the quantum cryptography part as well. So, but then we try also to connect, for example, the quantum dot much more intimate with the electrode with some organic molecules. Then what we can realize is a resonant tunneling transistors. So with many different kind of NDR behavior like this. From one perspective, it is good for a new type of logic device, new type of transistors. But on the other hand, we should also realize that resonant tunneling device, or SAKI diodes, is the vital component for microwave communications. So it means that you can create such kind of thing utilizing single quantum dots device. Okay, so to conclude, yeah, we can consider the collective behavior and individual quantum confined properties of the quantum dots to design many different parts of electronic devices for sensor, energy storage, energy harvesting, and also transmitting as a nice alternative for creating trillion sensor universe devices. And it's even, I haven't talked about, for example, the potential this quantum dot for chemical sensing, also the luminescence properties of the quantum dot for single photon emissions and so on, and for cryptography. So at the end, I would like to acknowledge my students when I was in RICAN and also now in Tokyo TUAT, and also my collaborators in RICAN and also in several other places, as well as the funding agencies. So thank you very much for your kind attention.
Very interesting and informative presentation from Professor Bisri. I think we have some question from the audience. Maybe we open 3 questions, please. Any question? Yeah, please introduce yourself and institution, your institution.
Thank you. Thank you, Prof. Bisri, for a very interesting talk. So I have two questions. The first one, so actually I'm a beginner in quantum dot, but I know that lead sulfide is like the most popular materials for this case. And among the last slide, you show various different materials. So what are actually the selection criteria, I mean, to be a good materials for quantum dots? And for the lead sulfide, is the lead leaching like the issue in this field as it is for the bulk case? So the second one is, so for application in the device, ideally we want a continuous grains. So in the transport usually is on the highest oriented one. But for the quantum dot, how is the charge transport? Is it hopping or is it, how is the charge transport in the quantum dot case? Thank you very much.
Okay. Yeah, thank you very much. So, okay, for the first question first, why lead sulfide? The easy answer, history. Okay. So, yeah, lead sulfide exploration has been done starting from 2004, right? So the first colloidal quantum dot in nice form start being established in 2004, and then yeah, we keep improving until this point. So the thing is that the more researchers do into this field, so then the quality of the material, or at least the chemistry part of the material, is getting much better done. So the good thing of this lead sulfide or lead chalcogenide is it is highly symmetric system. So if you see the facets of the maybe the oleic of the lead sulfide, you can see that they have well-defined truncated cuboctahedral structure like this, right? So it means that when you try to make the assembly, as long as the quality of your quantum dot is good, then you can do much more precise control of the surface. So on the other hand, for example, even though like cadmium selenide is also have long history, cadmium selenide, zinc sulfide, they are tetrahedral. So then you need some set of rule. So we need someone to work with that. So that's one thing. So to do the physics, let's say, or the difficult applications, then it's better to focus on the more established compound, something like this. So if you want to aim for thermoelectric, lasers, solar cells, then you need to pass this all steps, physical knowledge steps. So then basically you can try to challenge this part. On the other hand, for many of other compounds, maybe it's just only still until this one. Okay, for catalysis, maybe it's already ready. But for electronics, not yet. For some other compound, for example, like this, before it's still on the level of cooking, not doing chemistry yet. So then that's the reason why it needs some effort to go this towards up onto the layers. But at least for these two compounds, since I established like in-house system from synthesis, device to application, so we hope that we can accelerate this timeline, let's say, at least for the compound that I start touching them. Okay, and then for the second questions related with the charge carrier transport, yes, the thing is that I focus mostly on planar device, something like this, right? So then the charge carrier transport will go in plane of the device itself, right? So that's the reason like source, drain, and then this is the films or something like this. Because it's at least until this point, this is the technique that we have established. So we can realize this nice superlattice as a quasi two-dimensional structures. So then we can have large domain. So that's the reason we go to Spring 8 to do the validations, because we want to ensure that at least for the entire device that we have, single domain is possible, or at least relatively large grain size is possible. right? But your question is valid because most of the device like solar cell or maybe the photo detector for the high speed photo detector will be on the sandwich type structure. So then the charge carrier transport should be this part. Yes, that's still the biggest challenge. So now I put like 2 students to try to translate how to create or to start to stack this super lattice into 3-dimensional with hopefully that they will be also ordered structure in 3-dimensional. But to tell you the truth, now we still stuck with 3 monolayer. That's the problem. After that, then everything messy again. So the field is still wide open, but if you really want to revolutionize the applications, either waiting from some other people, then why don't you just do it? You try to build the material system, do the device itself. Okay.
Okay, maybe one question from Zoom or in this room. Any question? Okay, maybe one last question from me. Okay, I want to know how to control the size of the quantum dot because this I think size dependent band gap, right? So this is will affect the performance of the electronic device that we create.
So yeah, to determine the size of the quantum dot itself, yeah, basically the necessity is how to control each step of this process, right? I mean, the reaction itself, reaction time itself, the precise temperature of the reactions, and then when to stop the reactions. In the case of lead sulfide, yeah, in the end, in order to achieve this level of tunability, so we work with company. So we collaborate with Quantum Solutions. It was from Saudi Arabia and United Kingdom. So we optimize the recipe first, then they can really realize the precise diameter and also precise orientation and precise quality. In lead sulfide, it is more well understood nowadays, and there are already industrial standards on that. But for other compounds, yeah, that's still a challenge. So hand dependent is still really problematic.
Okay, thank you for the comment. So I think this is the last question from us. So I will give some short summary that Professor Bisri already talked about the how utilize the quantum dot for the so many application in the electronic devices, such as a photo detector, solar cell, or the other. But still have some challenge that we will do a lot of work that we can do some research and collaboration with Professor Bisri in the future. Okay, thank you very much for your time, Professor Bisri, and behalf of the ICRAMET 2024, we have some token of appreciation. Please.
Thank you, Dr. Eri Dwi Kurniawan. But Professor Satria, don't go off the stage yet because we have another token of appreciations, and I would like to welcome Professor Nasrul Armi to come to the stage and to giving out another token of appreciation to Professor Zulkarnain. Thank you, Associate Professor Satria Zulkarnain Bisri. And before the morning break, I would like to give out some announcement. The first one, we will have breakout rooms for the parallel sessions, and for the on-site audiences, we have the main room as the parallel session 1, and we have the Kinanti 2 room located at the end of the corridor to the right of the door. That is for breakout room 2 or parallel session 2, and for parallel session 3 will be conducted fully from the Zoom platform. And second, also I would like to invite all of you to visit our exhibition booth from our esteemed patrons that located at the left from the corridor. So please, you can, we also provide some refreshment, so you can have some kind of snacks or coffee or tea, and also come to the booth before starting the parallel sessions. Also, another announcement, we found a hotel room key card in the restroom. So for whoever feel like they're missing their key card hotel room, please go to the registration desk. Okay, so please have the refreshment outside and enjoy the morning break for around 15 minutes. Thank you.
Link technology. This technology allows synchronization between the two VNA test ports using optical cables. No matter how much the user moves the cables, there's no phase deviation, while system dynamic range is fully preserved no matter the distance between test ports. Now you can confidently test long cable runs from aircraft's nose to tail and wingtip to wingtip, from ship's antennas to underdeck control rooms and antennas on outdoor test ranges, or in large anechoic chambers, all to full performance with a compact and easy-to-use solution. Inritsu, providing excellence in MM wave measurements, covering the distance with our patented phase link technology. integrated into the Shockline ME7869A modular vector network analyzer. Inritsu, advancing beyond.
Our product is called XDEC, which consists of hardware and software that we created in-house. We integrate our device with the semiconductor chip industry to help them reduce their cost for testing and get more reliable and also high yield of their product. The current problem in the semiconductor industry testing for the chip is because the current equipment is bulky, expensive, and also not integrated. Our solution provides technology that's 20 times smaller, 3 times cheaper, all integrated with easy-to-use software. Our device analyzing the reliability of the chip. This reduces the amount of defective chips and also puts out high yield in the manufacturing. It is important for the semiconductor chip manufacturers. So we have shipped our product to over 15 countries. Now also being used to different applications such as the AI, quantum, and also in data centers. NASA used for the space, US Army for defense, and the NVIDIA for the AI. For those companies, they use our equipment to be integrated with their chips to make it function properly in different applications. One of the best functions of our product is provide the voltage and current. Our equipment helps guide light so it can work properly into different applications.
Oh, nggak apa-apa.
Recording in progress.
Okay, let's start our session today. Good afternoon, everyone, and welcome to this parallel session of the International Conference on Recent Advances in Material, Energy, and Technology, ICRAMET 2025. My name is Johannes Gali Adioga, and it's truly a pleasure to serve you as a moderator for this session. I hope everyone is doing well and ready for a series of inspiring and insightful presentations to this afternoon. And today we have 5 presenters in these sessions. And before that, I want to make sure that every presenter in this session is already here. For the first presenter, there is Mr. Saptaparni Ghosh, are you there in the Zoom online room meeting? Mr. Saptaparni Ghosh, already? No? Okay, and then Mr. Mustafa Ghanim, can you raise hand or check sound for answer my greetings?
Yes, good afternoon.
Okay, thank you.
Thank you.
Thank you. And then in the third presenter, we have Mr. Rizky Ramadhani. Are you there? Mr. Rizky Ramadhani from Universitas Negeri Surabaya. Are you there? Not yet? Okay. And then for the fourth presenter, we have Mr. Ayman N. Muhi from University of Technology, Iraq.
Yes, good morning, everyone.
Good
I'm here.
morning,
Thank you for
Mr.
hosting us.
Ayman. And the last presenter, we have Mr. Bambang Setia Nugroho from Telkom University. Are you already in this room? Mr. Bambang Setia? Not yet. Okay, so in this room, we just only two presenter. So for the first presenter,
Today I will present.
Okay, Mr. Rizky Ramdhani, already here? Can you open your camera, please? Okay. In this session, we have around 9 to 11 minutes to present your presentations. And after that, it will be followed by a short question and answer and discussion. So the total time that you have to present is 15 minutes. And I can kindly remind you, all the presenter, to manage your time carefully. And if needed, I will provide a gentle reminder when we are close to the time limit. And before we start, maybe we have photo sessions before. And I hope all the participants and the presenters can open your camera for the documentation.
An innovation agency, and I will be serving as your moderator today. Okay, in this session there are 5 presenters. Okay, the first presenter is Abimata Arashid from National Research and Innovation Agency, and the second presenter is Sadam Arashid from Telkom University, and the third presenter is Eka Stianingsi from National Research and Innovation Agency, and the fourth presenter is Mr. Iman Firmansyah from National Research and Innovation Agency, and then the last is Mr. Yudi Julius Maulana from National Research and Innovation Agency. Okay, first of all, I would like to confirm whether all presenters have joined this room. Okay. Okay, in this parallels in these rooms, there are 3 presenters will be online and 2 presenters will be offline. Okay, for the offline presenter, I will call Mr. Sadam Arashid already in this room. Mr. Sadam already, and then Mr. Iman Firmansyah already in this room. Okay, okay, for online presenter, please turn on your video. For online presenter, to please turn on video. We will do the screen capture for documentations. Okay, our team already capture the online presenter. Okay. Okay. Before we beginning the sessions, I will announce some information. Each presentation will be allocated 15 minutes in total, including the Q&A sessions. Approximately 10 minutes for presentation and 5 minutes for question and answer. Okay, for online presenters, please turn on their video during their presentations. Okay, for those participants who like to ask a question, please use the raise hand feature on Zoom if you are joining us online. For a participant in this room, you may simply raise your hands. Our team will assist you with the microphone. Okay, now let's move on to our session. Please join me in welcoming Mr. Abimata Arashid, who will present his study on performance assessments of LoRa propagation model based on seaport field measurements, and will be presented online. Okay.
Of BRIN. Today I will present our study with field performance assessment of LoRa propagation models based on seaport field measurements. This research is focused on evaluating the accuracy of LoRa propagation models through real measurements conducted at Tanjung Mas Port at Semarang. As we know, the Internet of Things continue to grow rapidly. Many IoT applications require reliable long-range communication under low power constraint. Long-range radio, or LoRa, as a lower power wide area network technology, is widely adopted because it combines long distance and low energy use. However, existing propagation models such as Okumura-Hata and free space path loss, or FSPL, have not been truly validated in complex maritime or seaport environment. So because of that gap, motivated our study. Our study had three main objectives. The first, to evaluate LoRa performance through the real-world measurement at seaport condition. The second, to compare three well-known propagation models, Okumura-Hata, FSPL, and long-distance models. And finally, we want to identify which model best represents signal behavior in such an environment. Previous research that related to our study mainly evaluated LoRa performance in urban or rural scenario. Only few studies investigated maritime conditions that we know where humidity, obstacles, and surface reflection may influence the signal behavior. Other researchers have explored multi-gateway system and adaptive algorithm to enhance reliability, but model validation in ports remain limited. Our experiment was conducted at Tanjung Mas Port Semarang. We use a single LoRa node transmitting to a gateway placed on about 30 meters distance at the lighthouse, which is lighthouse William 3. Per device operated in the 920 and 22 megahertz band, managed through an open source chip stack, LoRa 1 server. And then the node radically transmitted data packets contains timestamp, coordinate, and pilot information. We perform two measurement scenario, one for continuous receive signal strength, or RSSI measurement, and another for periodic packet delivery test. As shown in the presentation, the spreading factor was set to 12 for maximum range, and the transmit power was around 22 dBm. We log RSSI and signal to noise ratio, or SNR, and packet delivery rate for every transmission. We compare the three models, which is Okumura-Hata, FSPL, and long distance. Which each model has distinct assumption. For Okumura-Hata, fits urban setting, and for SSPL, assume a clear line offset, and long distance can adapt empirically to site-specific condition. We tune each model parameter to fit the measured data. Here we can see in the picture the comparison between measured RSSI and the predicted value from each model. The long distance model achieved the best agreement with an RMSE about 4 dBA, and for SSPL performed very well but tended to overestimate signal strength at short range. And for Okumura-Hata, however, saw a large error above 10 dB, meaning it is less suitable for the seaport environments. During the 2-month deployment, most SNR readings range from -5 to 0 dB, which is indicating moderate noise levels. Despite this, the system maintained at a very high package delivery ratio, around 99.28%. Interestingly, even with variation in temperature and rainfall, the link performance remains stable, showing that LoRa robustness in the dynamic seaport environment. Our findings suggest that the long-distance model, once calibrated, can provide the most realistic prediction of flora propagation at the seaport. For SSPL, can still be used when quick estimation is needed, but the calibration is crucial for accurate network planning. This insight hopefully can help future engineers to optimize gateway placement and improve IoT reliability in maritime areas. In conclusion, our field measurements show that long-distance model best represents LoRa signal propagation in a seaport environment. LoRa itself demonstrates excellent reliability with over 99% successful package delivery. So for future work, we plan to expand testing in different terrain and explore adaptive or machine learning based models to enhance the prediction accuracy. Finally, we would like to express our gratitude to BRIN's IoT Research Host Program for funding this study and for the Tanjung Mas Navigation District Office for their operational support. Thank you for your attention. That's end of my presentation.
Thank you very much, Mr. Abimata, for interesting topic. Now we move to question and answer sessions. There is any questions? Okay, I will check in a message. Is there any questions from Zoom? Okay, Mr. Abimata, I will ask you questions. We know that in seaports there is much obstacle like containers, cranes, and each other. So, in the tree model, what is the best performance from tree propagation model during the obstacle? Okay.
Okay, thank you for the question. Our finding at the research, it showed that long distance model has more accurate for the real data depend between other model like FSPL or Akumurahata. It showed that the noise error is only 4 dB. Actually, the FSPL is around that error too, but there is for the best to our environment is long distance models. Sorry, can you hear my voice?
Okay, thank you for the answer. Okay, is there any questions from the pro?
I would like to ask question, please.
No question from Zoom? No.
Can I ask question?
Oh. Okay, there is any question from Zoom, please. the question. Okay, you can turn on your video and your audio.
Yeah, I would like to ask the presenter about the empirical model used in his experiments. Could you elaborate it more? And then how did you calibrate that empirical model so that uh, fits with your measurement data? Because uh, yeah, I'm not so sure about the empirical model used in your experiments, because if you properly calibrated it with your measurement data, is kind of obvious that model will produce the best results compared to the other models, because the other models were not calibrated with your measurement data. Okay, that's all my question. Thank you, Mr. Moderator.
Okay, please, you can answer the question, Mr. Abimata.
Okay, thank you for the question. May I share a screen? Wait a second. Let's see. It's my tablet. Sorry. I need to find my picture.
Okay, you can share yours. Okay.
Wait a second. I'm still searching the tablet. Okay. Can you see my share screen? So, in our journal, we state that the equation for the three models we adjust to so the data can fit the real data, and the parameter that we use is for the Okumura data. Can you see this picture? The equation for A we set to minus 36.83, and for FSBL we tune to minus 4.96, and for the log distance parameter we fit for the L is 97.30, and for the N is minus 1.71. This is answer the question from Mr. Ananda.
Okay, thank you for your answer. I think your answer is okay. And then there is one question. This last question from the Zoom. Okay, in the chats, I will read the question. How does a weather affect LoRa performance based on your finding? Yeah, how about the weather?
Okay. For the weather effect, surprisingly, during our measurement, there is rainfall condition, and there is very hot condition, but the performance from the LoRa itself is so robust with 99% data package we achieve. So there is no effect from the weather during our measurement.
Okay, thank you for your answer, Mr. Abimata. Okay, please give applause to Mr. Abimata for interesting topic and interesting presentations. Okay, thank you, Mr. Abimata. Okay, now we move to the second presenter, Mr. Mr. Sadam will be present offline. Okay, you can welcome to the stage. Okay. How about the slides of Mr. Sadam? You can just pointer. Okay, please, you can start your presenter.
Good morning, everyone. My name is Sada Makasit. I am master student at Telkom University. Today, I am honored to present our work title is okay. Alright. Yang awal lagi. Di Zoom kan bisa di Zoom, maksudnya untuk button Zoom size. Nah, nice. Alright. Okay, I'm repeat again. My name is Sada Masid. I'm master student at Telkom University. Today, I'm honored to present our work title is a methodological comparison of test configuration for quantifying cabling in use PMD in FTTS network. In the study case carried out in collaboration with industry, fiber to the home, and Telkom Indonesia, and academic Telkom University partner for providing on practical guidelines for PMD FTTS network. I have the 5 outline. First, introduction, research material, methodology, followed by result and decision, and then the last conclusion. This is background is PMD rise from fiber asymmetric causing differential group delay degrading 400 to 800 G system. And I have the problem why I create my paper. This problem no standardized guideline on selecting PMD test configuration from multiple options. And this object is systematically compared and comparison to identify optimal measurement protocol. And then my approach is multi-vendor validation using ITUT G652 for the fiber specimen. And the next slide, my dataset, our fiber sample, both bare and cabling. We source from all directed self-reporting cable commonly used in FTTS infrastructure. And my dataset used 2 different vendor. Next, and configuration in my 2 dataset, all tests were conducted in a controlled laboratory environment. And my configuration, I have 3 core configuration. And first configuration, I have 2 configuration, 3 wavelength, and I'm used to 1 wavelength in 1310, and then 1550, and the last wavelength I use PMD 1625 nanometer. And the next core configuration is central configuration, and you can setting span and resolution. And the last configuration is signal and noise. You can setting sampling and number. Setting setup use 65 to 256. PMD measurement were performed using the fiber optic CD500 system under controlled laboratory condition. And the next, my methodologies have to 4 main phase. First, data acquisition, and you can to shared to three group data is signal to noise ratio, tree wavelength, and center. And the next phase, data preprocessing with Dixon key test. If you don't have no outlier, you can don't clean dataset. If you have outlier detect, you can must be to cleaning your dataset. And the next for main phase, to phase, statistical analysis with G-score, F-test, and T-test. And I use G-score, use effort is slash performed by quantifying its division for the predefined assigned value. And you can must value G-score. My hypothesis is you can next to measurement calculate with p-test and t-test. And the last phase, interpretation and recommendation why you choose to 10 configuration. The next, this is insight to my methodology. I have to 300 sample and 20 sample fiber in type G65 to 4D fiber and to vendor. And the right slide, I have to formula to measurement this G-score, t-test, and the distance outlier. And the next, this is my graphic. My graphic 2 comparative analysis of PMD in background versus cablet optical fiber. And you can see that in the 1020 50 550 and 1060 25 nanometer, you can interquartile range. And indicating wavelength defined cabling inductive finality, moderate resolution test, resolution 0.05, and signal to noise. You can number sampling 64 to 128, provide most robust differentiation. And this is my result to this course summary. And I am to use to my configuration in result acceptable, and I have to 4 acceptable to ESDM and assign value in wavelength 1310. And then this course screening guarantee only validated run G less than 2 were used for statistical comparison. And the next, this is a result in t-test, and I'm to compressing to cabling penalty and interfender. And the result is I used to 1550 nanometer and resolution 0.05 with signal to noise ratio sampling number 64 to 128 for robust detection on cabling induced PMD. And the last result in discussion, the key contribution for systematic comparison of 10 PMD configuration. And this avoid, you can don't use resolution 0.025 and signal to noise ratio sampling number 256. And the last reporting always include full test comparison for traceability. And the last slide, the conclusion, primary conclusion, and resolution 0.05 picosecond, and then signal to noise sampling number 64 to 128 optimal for cabling penalty detection. Practical recommendation include 0.016 to 0.035 picosecond kilometer penalty in for 100G to 800G PMD budget. And my limitation, independent sample not pair, single cable construction, and the single investment, future work, part design, and I used to fiber testing type G.657 and cross instrument validation by study, and then the last machine learning prediction. All right, thank you. Do you have any question?
Okay. Thank you for the interesting presentation. Okay, is there any questions from the floor? Okay, you can use the microphone in the middle of the room.
Okay. So thank you for the presentation. I would like to ask about so what type of fiber that you test in the study for the first question, and for the second is what was your final recommendation for network designer? That's it. Thank you.
Okay, Sadam, you can answer the questions.
Thank you for your question. Final recommendation in the you can see on the slide. I'm recommendation to use configuration 0.016 to 0.013.5 picosecond kilometer. Use penalty in 500G to 800G PMD budget, and I use type in only fiber G.652.D. And do you have any question? Okay, nice. Thank you.
Okay, thank you for your answer. Okay, I will check the Zoom. Is there any question from Zoom? Okay. Okay, I think there is no question from Zoom. Is there any question from this room before? Okay, maybe one question is. Oh, no. Okay, I have one question. In your limitations, is a single cable construction. Or what happens if we use multi-cable constructions? Okay.
Why this is my limitation single cable construction, because in the labor time we don't have to multiple cable construction, because in the my lab in telecom test house in the scene in the case study I have two single I have two one only type fiber in is G.652.D.
Okay. Thank you for your answer. Okay, maybe this of your sessions, and now please give applause to Mr. Sadam for nice presentations. Thank you very much for your presentation. Okay, now we move to the third presenter. This will be present online. From Miss Eka Stianingsi with the title Performance Evaluation of Common Filter Based Imputations for Water Quality Sensor Data. Okay, please welcome Miss Eka Stianingsi.
Good day, everyone. My name is Eka, and it's an honor to present at ICRAMET 2025. Today, I will present our research entitled Performance Evaluation of Common Filter Based Imputation for Water Quality Data Sensor. The importance of continuous water quality monitoring is to maintain the healthy aquatic ecosystem. By measuring the temperature, pH, and dissolved oxygen, the sensor data can guide the aquaculture management, the pollution tracking, and also environmental decision making. Through the wireless transmission and mobile sensing technologies, such as LoRa and remotely operated boat, it enables reliable data collection even in challenging area, and it's supporting timely conservation action. This is the overall architecture of our mobile platform sensor system that consists of the remote control mini boat that equipped with a temperature, pH, and DO sensor for collecting data on site. Then the sensor readings will be sent to the landing station through the LoRa communication module, and then the data will move forward to the centralized database and network server. This configuration enables long-range communication, efficient power usage, and also continues the environmental monitoring for aquatic areas. Sensor data is often suffers a missing value due to the environmental stress, sensor drift, and also the communication failures, which can significantly affect the data reliability. For the solution, there is many imputation method, such as traditional imputation method. These like mean substitution and interpolation. They are simple but insufficient to capture the temporal dynamic inherent in time series sensor data. While the machine learning based approach offer promising solution for inputting missing value, they typically require large data set and substantial computational resource. In contrast, model-based technique such as the Kalman filter and Kalman smoother, it provide the efficient recursive estimation method that's suited for IoT application, and this technique effectively integrated to prior system knowledge with real-time observation to estimate missing data more accurately and maintain the continuity and reliability of sensor measurement. KF also has been applied in soil moisture and air temperature, but in water quality monitoring it's still limited. This research is aimed to compare the Kalman filter and Kalman smoother for inputting missing water quality data under different missing rates. The study also propose a retrospective estimation approach using the Kalman smoother to enhance accuracy. Then the performance is evaluated through MAP and RSMA.
Recording in progress.
And the findings are expected to provide practical insight for mobile water quality monitoring system. Methodology. The methodology begins with synthetic data generation, where water quality dataset are simulated using temperature, pH, and dissolved oxygen parameter within the realistic range over 5 days. Next, the inject missing value are introduced using the MCAR mechanism at 10% and 20% to emulate the real data loss. The offline imputation stage is applies both the Kalman filter and Kalman smoother to fill the missing data. Then the performance evaluation is conducted using MAPE and RMSA to quantitatively assess imputation accuracy. And the reconstructed data set are then analyzed through visual data comparison to assess the continuity and the smoothness of the inputted result across parameter. Finally, overall, this structured process is ensure that both visual and statistical validation of the proposed technique. In this research, we're also using the state space model and the implementation using Python to ensure the scalable, reproducible imputation for complex NOC sensor in data analysis. For the result, the comparison between 10% and 20% missing data reveals a clear pattern of continuity loss, with 10% missing data in daily temperature trends remain largely intact and showing only minor fragmentation. However, at 20% missing data gaps introduce significant disruption, breaking temperature continuity. This similar pattern is also happen in pH and DO. So this result emphasize the importance of robust implementation method to restore data continuity and maintain the integrity of key environmental dynamic. This is the temperature sensor is presented like similar pattern is observed for pH and DO sensor. The two figure above is represent of synthetic data generate with the missing value 10% and 20%, and the figures below is the result of the imputation, where the KF is represented in the blue circle and the inputted KS in the green diamond. By tuning the process and measurement noise covariance QNR in range 0.01 and 0.5, which we get from the multiple trial run using synthetic dataset, the KF and KS imputation work closely to ground truth data, just like the pictures shown us. Both method is produce closely aligned inputted points and indicating consistent estimation performance even as the proportion of missing data increases. The small differences between KF and KS imputation reflected in the similar MAPE and RMSE value, demonstrating high reconstruction accuracy and stability. This is the recap of previous figures, which lower MAPE and RMSE across all sensor and missing data rates. Our comparative analysis reveals that KS consistently outperform KF in both MAPE and RMSE across all sensor. Then a retrospective smoothing in KS enables more accurate signal reconstruction than KF approach. Furthermore, is the increasing missing data from 10% to 20% result in only marginal error increases, demonstrating the strong robustness in a pH sensor. So the lowest error due to its simpler temporal pattern compared to more challenging signals like DO. The KS offline processing and higher computational demand may restrict the real-time deployment because it's requiring accuracy and efficiency trade-offs. Overall, KS is offer superior accuracy and robustness, but practical constraint must guide the deployment choices. When balancing accuracy with real-time capability, we must distinguish between the Kalman filter and the Kalman smoother. The Kalman filter, or the KF, is designed for immediate real-time processing. It operates sequentially and has lower computational requirement, making it ideal for immediate monitoring and rapid response system. In contrast, the Kalman smoother utilizes the full temporal context for superior accuracy, but requires offline processing and higher computational power. This makes the smoother less suitable for strict real-time application, emphasizing an inherent trade-off between the speed of KF and the enhanced precision of the KS. Okay. Now, in the conclusion, the Kalman smoother has proven to consistently outperform the Kalman filter in inputting missing water quality sensor data, and it generating smoother and significantly more accurate signal reconstruction across all parameters. moving forward, our future works will focus on validating this KS approach on mobile sensing platform in a real operational environment. That aim is to examine its robustness and optimize the computational performance under real-world condition. This is our work under the prototype program unit for research and innovation outcome on the underwater detector system array. And I think thank you for your attention, and Assalamualaikum warahmatullahi wabarakatuh.
The time of the Kalman filter processing. Okay, maybe you can answer the question.
Sorry, sir, I didn't hear your voice before, just the last sentence of your voice. Can you repeat your question?
Okay, please speak a lot loudly, Mr. Iman.
So I'm interested in computational time, especially when you conduct your experiment using microcontroller. Is that okay? Okay, thank you.
I
So,
still
once again,
didn't,
okay.
please.
So
Yeah, interesting.
you mentioned about the Kalman filter. So
Okay.
I was wondering how fast the execution time.
Oh, how fast the execution time? Okay, thank you for your question, Mister. For the we didn't have the how fast the time of the execution time, but we focus on this is the Kalman filter, and Kalman motor is apa ya, is can achieve the imputation of our problem. Maybe for the detail, I will contact you, or you can send me your email for the real measurement time of our execution and imputation with common filter. Is that okay for you, sir?
Okay, maybe it's okay for the answer. Okay, maybe the last questions. Is there any question from this room? Okay, I will check in the Zoom. There is no question. Okay, last question from me. In your study, you use two model of the Kalman filter. Use of the Kalman filter and Kalman smoother. How does the sensor noise influence the performance of the Kalman for the image for the data construction?
Okay. For the sensor noise, we applied the QNR tuning for reflect the sensor noise. We use in 0.01 to 0.5 to get the best value of our measurement, to get the imputation in line with our ground truth data that we generate with synthetic data.
Okay, thank you for the answer. Okay, time is up. Please give applause for this presenter, Ms. Eka. Okay, thank you, Ms. Eka. Okay, we next to the port presenter will be present offline. Mr. Imam, please welcome to the stage. Maju, Pak. Okay, you can start the present.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Iman. In today's presentation, I would like to present our study. The title is Design and Implementation of an FPGA-based data acquisition system using with Node-RED visualization. So basically, our research focused on how to implement multi-channel real-time data acquisition, and then finally how to visualize our result real-time. So, but before that, I would like to introduce what FPGA is. So, for those of you who are not familiar with FPGA looks like a CPU or semiconductor that can be programmed because, and then it has some advantages such as high parallelism, low latency, and fast, of course. And then Node-RED is it's look like a visual flow-based programming. Okay. The Zoom oh yeah. So our presentation cover main topic. So the first is objective of our research, and then second is system architecture. The third is hardware implementation, and it is followed by experimental research. And finally, I'm going to show you our conclusion. So our objective of this research is basically how to develop real-time multi-channel data acquisition, especially using FPGA. And then we can not only we can capture data simultaneously, but we can show it real time through network. So we use how to say RS-4085 as data connection to send between FPGA to the server, and then finally we employ the Node-RED visual programming to visualize our data real-timely. Okay, so this is our system architecture. So basically, as we can see that the first is analog input, and then we use a 16-bit 8-channel ADC, AD7606, which is captured by FPGA, and then the data will be sent serially through RS485 to ensure the data robustness and noise immunity during data transmission. And then finally in the server, we use a Linux-based server and then installed with the Node-RED. So the Node-RED will responsible for visualizing data real-timely and also for storing data into a database, for example. Okay, this is only introduction of block diagram. So basically we use ADC and then we interpret it with FPGA. So in this experiment, we use low-cost FPGA, Cyclone 4. We can say this is the cheapest FPGA family from Intel. And then, okay, the main part of our research is inside this FPGA. So basically we have ADC controller, UART controller, which will be connected to RS485 for data robustness and noise immunity. And then our data calibrator, which will be presented in more detail in the next slide. This is our hardware design. So usually when we develop FPGA, we need to program it using the HDL. Unlike CPU programming model, so when we develop or program FPGA, the final result is a circuit. So this is how our design looks like. So this is the main block of our circuit. But if you want to go in more detail, we can click inside this block and we can find, let's say, complicated circuit or transistor logic circuit. But this is our main block diagram for simplicity. Basically, we have ADC controller for capturing data from ADC, and then voltage calibration. Basically to calibrate data because the data is in digital, so we need to convert into decimal. As a result, we can easily send our data to the server. So after calibrating the voltage, finally the data will be sent to the UART controller. So we need to convert from decimal into string so that it can be transmitted easily through the server through the RS485. After developing our design, finally this is how our circuits looks like. So this table show us how large of our circuit, our design fit into FPGA. From this table, we can see that our design consume logic element for about 53%, and then almost 1K of register, and we can see only 1% of memory bit, and then no VLL or fast loop. And then in this design, we use only 50 megahertz of clock. So from this table, it demonstrates that even for low-cost FPGA, we can develop the multi-channel 16-bit data acquisition that can send to the server in real time. So in this research, we don't have to buy the expensive or high-end FPGA. So this is how our experimental setup looks like. So basically, as I said earlier, we use a low-cost FPGA, Cyclone 4 FPGA from Intel, connected to ADC. This is a channel 16-bit resolution. And then to emulate the sensor data as input signal, we use a dummy input. Let's say in this picture, we use analog signal from potentiometer. The digitized data will be sent to the server. This is a Linux server. How to say, this is not a high performance server, but we can use a low cost server where the Node-RED is installed inside this server. So basically the data is captured by ADC digitized by FPGA and sent to the server. And then from the client, we can connect and access data remotely and real time. Okay, this slide show how to send data from FPGA to the server. So first we have to design the data format. Because we use 8-channel ADC, as we can see, this is the data format. AD1 means the data from ADC channel 1. So this data has been converted by FPGA through the decimal or string so that the server can read easily. Because in FPGA, they are working on logic or digital, but from the server, they require the decimal or string for easy parsing. And then after the FPGA send the data, this part is the, how to say, the main program in the server base. So as I mentioned earlier, that we use a Node-RED. So Node-RED is basically a visual flow-based programming developed by IBM that make us a programmer easily because we don't have to write by using complicated coding, but we use how to say, we call it node. So there are so many nodes. Inside the node is JavaScript. So by using node, we can easily connect it from hardware to algorithm and then finally to the visualization. So this is the node for receiving data from FPGA, and then the next node is how to say, the parsing data to parse the data and then convert to decimal, and finally the node for displaying real-timely. Okay, so this is how the server works by using Node-RED. Okay, this is the final slide. So after parsing the data, finally we get the data that can be displayed easily. So this is how our final result looks like. So as you can see, we use a web browser. So the data that has been captured by FPGA can be monitored real-timely by using browser. So anytime, anywhere, and anyone can access our FPGA remotely. So this is in real time, not real-time visualization. Okay, this is the end of my presentation. So basically, to sum up our research, so we have successfully developed the real-time multi-channel data acquisition using low-cost FPGA, particularly Cyclone 4, sorry, by using 16 8-channel ADC that can be monitored and stored real-timely. So basically, our purpose is how to develop FPGA for IoT application, because currently the IoT is a promising area. That's why I'm interested in how to use FPGA instead of CPU or microcontroller, because as we know, FPGA provide some benefit. Okay, that's all from me. Thank you.
Okay, thank you very much for your nice topic, Mr. Iman. Okay, is there any question? Okay, please use the microphone in the middle of the room.
Check. Thank you for the opportunity. And my question is, you are using Cyclone 4 FPGA, right? And you say that
Yes.
the reason that you use this device is because it's cheap from the Intel vendor. Now, actually, is there any other reason why you use this device other than the price itself? Or maybe you have also experience with the device with the same level, I mean the Cyclone 4 FPGA, but from the other vendor, like that. Thank you.
Oh, okay. Thank you for the questions. Okay, Mr. Man, you can answer the questions.
Okay, thank you very much. That was a nice question. So basically, there are so many reasons why I choose, let's say, Cyclone for FPGA. So first, in terms of the price, yeah, this kind of FPGA is the lowest level of FPGA. The reason why I choose this kind of FPGA because so basically when we develop a project based on FPGA, we need to know uh, how much the circuit will be required for our purpose. Because in this IoT, we don't need like DSP block for high performance computation and then no PLL or let's say okay and any other specific circuit. That's why I choose this kind of FPGA because as you can see that this project only consume let's say 10 kilobit of logic and so on. That's why we use this FPGA because if you use let's say static 5 or static 10 that was to how to say uh, you throw a lot of money because those kind of FPGA price is let's say more than 10,000 US dollar. That's why I use this cheap FPGA. And then as another alternative, you can use like Spartan 6. So there is a comparable person from Xilinx. So basically you can use another type of FPGA. Okay, thank you.
Okay, thank you for the answer. Okay, is there any questions from this room? Okay, I will check in the Zoom. Okay, there is a two questions from Zoom. Okay, the first question is wondering, did you measure also the latency interfaces between the FPGA and your Linux machine? And the second question is what kind of process that is offloaded up to FPGA?
Okay, thank you very much for the question. It seemed that the question little bit tricky. So in this experiment, uh, I didn't show you the result about the latency because uh, as we know that we use only 115,200 BPS. The bitrate for transmitting data from FPGA to the server. So you can calculate from those bitrate. But actually, we can increase the speed. The problem is it is limited by the UART controller, UART controller. So as you can see from the conclusion, our data is limited by this bitrate.
Okay, the second question is what kind of processes that is uploaded to FPGA?
Basically, I couldn't catch up your question, but basically, process in I don't know how to answer, but well, anyway,
maybe you can explain about the process of the data on FPGA.
Yeah, but usually, basically, when we develop FPGA, first all program is so when we program FPGA, in contrast to CPU, when we develop CPU program, we don't care about the hardware itself, but in FPGA, we need to imagine how the circuit will be generated. That is the difference between programming FPGA and CPU. So the process that need to be uploaded is a circuit into FPGA. I hope our explanation can answer your question.
Okay, thank you for the answer. Maybe the last question is from me. One question. Maybe you can explain briefly about what is the new thread visualization. Maybe not all know about the thread visualization.
Okay, no thread.
No thread per. visualization?
Node-RED is a visual flow-based programming developed by IBM that's make programmers much more easy to program the code. So because in our we can imagine in our project, even though for small project, we have to, I mean, from the server side, we need to capture, to read data from FPGA, and then we need to store it. We need to put our data into storage, into database, for example, and then we need not only store keeping data into database, but we need also to display in real time. There are so many jobs. That's why by using Node-RED, our task can be simplified by Node-RED. That's why the IBM proposed this new kind of program. So Node-RED basically is a programming, but it's much more simpler than standard program.
Okay, thank you for the answer. Maybe time is up. If you have any question, you can ask directly to Mr. Iman. Okay, nice presentation, Mr. Iman. Thank you very much. Okay, please give applause to Mr. Iman. Okay, now we move to the last presenter. Mr. Yudi Julius Maulana will be present online with the title is okay, with the title Designs and Development of Military Personnel Monitoring System using LoRa module with SOS functionality. Okay, please welcome Mr. Yudi Julius Maulana. Please start.
Is a collaboration between the University, your university,
Yeah.
the National Research and Innovation. Today, I will be presenting our work title, Design and Development of Military Personnel Monitoring System using LoRa module with SOS functionality. National security depends on how effective and safe the soldiers are in the field. However, there are major challenges. Soldiers often have difficulty determining their exact coordinate. There is a lack of real-time monitoring of both their physical condition and security. Therefore, there is an urgent need for technological advancement on the battlefield. To solve these issues, we developed a LoRa-based monitoring system. The main goal of this project is to create a system for tracking the location and health condition of soldiers in real time. The key features include real-time GPS tracking, health monitoring, SOS emergency button, and graphical interface. Here, we show the system architecture. The system consists of a transmitter, a process, and receiver. On the transmit side, the soldier were a compact unit equipped with several sensors. GPS for location, MAX 30102 for heart rate, and SPO2, and temperature sensor. The unit also include an OLED display, a battery, and a SOS button for emergency. The data are processed by an Arduino microcontroller and transmitter through a 915 MHz LoRa module. The transmit data are received at the base station through another LoRa module. When an SOS signal is detected, LED and buzzer indicator are active to provide a warning. Finally, the monitoring software display real-time map, location, health information, and SOS status of all soldiers. This slide presents the sensor accuracy result of the wearable monitoring system. They ensure reliable health monitoring. The sensor were validated against standard medical device. The comparison result shown in the graph on the lower. The heart rate sensor, a rate error of 0.03%. In the blood oxygen, SpO2 sensor, a rate error of 0.020%. And the temperature sensor, a rate error of 0.9%. The result demonstrates that the sensor used in the system are reliable for real-time monitoring application. Communication range and reliability are critical. We test LoRa communication delay from 100 to 500 meters. The results show predictable delay increases 0.12 seconds at 100 meters, 5.23 seconds at 500 meters. Importantly, the SOS signal remain reliable even in non-line of sight condition up to 110 meters, meaning the system works even behind building entry. This slide presents the prototype implementation of the system, including both the hardware and the graphical user interface. The hardware prototype, shown at the top right, consists of a OLED display, MAX 30102 sensor, SOS button, power and battery indicator, and a LoRa antenna. The lower figure illustrates the graphical use interface for the base station. The interface display its soldier identification, real-time location on a map, and corresponding health data. It also provides immediate visual alert when a SOS signal is triggered, and so additional parameters such as signal strength and battery level. Overall, this prototype demonstrates the complete integration of the hardware and software component, enabling efficient real-time personal monitoring and rapid emergency response in fleet environment. This slide outlines the current limitation of the system and the direction for future improvement. First, the term of security. The current prototype uses a basic LoRa communication link with encryption. As future work, we plan to implement the LoRa protocol with AES 128 encryption. Second, for testing, the initial evaluation was performed on a limited scale and under control condition. Future work, we focus on conducting larger scale field tests involving more participants. Lastly, regarding optimize, feature refinement of LoRa parameter and power management strength. Overall, this feature development aim to strengthen the system security and performance for real world personal monitoring application. In conclusion, we successfully designed a development LoRa-based monitoring system for military personnel. It integrates GPS tracking, health monitoring, and a reliable SOS feature. Functionally well in both line offset and non-line offset condition. The system accurate, low cost, and efficient, showing great potential to enhance soldier safety on the battlefield. That concludes my presentation. Thank you very much for attention. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much, Mr. Yudi, for nice presentation. Is there any questions? Okay, please using the microphone.
Thank you.
Please speak loudly.
Okay. Pak Yudi, I would like to ask you one question about your system. Why did you choose LoRa other than maybe Wi-Fi or cellular? That's my question. Thank you.
Okay, thank you for the question. Okay, Mr. Yudi, you can answer the question about why did you choose LoRa instead of another network?
Thank you very much your question. We chose LoRa because it's after long-range communication and low power consumption. It is also cost-effective compared to cellular system. Only it.
Okay, thank you. Thank you for the answer. Okay, is there any questions? Okay, I will check in the Zoom. There's any question? Okay, there is no question from the Zoom and from in these rooms. So maybe our time is up. And please give applause to Mr. Yudi Yulis Maulana for the interesting topic. Okay. Okay, our time is up. Thank you very much to all the speakers for your excellent presentation and to all participants for your attention and active participations in ICRAMET 2025. I will now conclude this session and return to the floor to the MC. Okay. Thank you very much.
Thank you, Mr. Fajri
Assalamualaikum
Darwis.
warahmatullahi wabarakatuh.
Thank you also to the presenters and all of the participants for finishing the parallel session 1. And now we've come to the lunch break. After this, we will continue the parallel session 4 and 5
Recording
in
stopped.
this room and the Kinanti 2 room at 1 p.m. But now first we'll have the lunch. But the lunch is not situated in this corridor, so we need to go to the hotel kitchen resto. So hopefully our organizer can try to guide you to the restaurant. And please come back at 1 p.m. Thank you.
Tips are not easy tasks. The traditional measurement solution uses a two-port benchtop vector network analyzer, a VNA, where the user must attach two very long test port cables. The problem with this solution is that long cables introduce signal loss, reducing dynamic range. To overcome this challenge, a high-end VNA is required, and components such as low-noise amplifiers are introduced to improve dynamic range. As the frequency of interest goes higher, however, small movements in the test port cables have an adverse effect on signal phase. Introducing the solution to long-distance S-parameter measurement problems, the Inritsu Shockline ME7869A. This modular two-port distributed VNA can make vector-corrected S-parameter measurements over distances as long as 100 meters. Complicated test setups and lossy cables are eliminated, since the instruments are powered by Inritsu's patented phase-link technology. This technology allows synchronization between the two VNA test ports using optical cables. No matter how much the user moves the cables, there's no phase deviation, while system dynamic range is fully preserved no matter the distance between test ports. Now you can confidently test long cable runs from aircraft's nose to tail and wingtip to wingtip, from ship's antennas to underdeck control rooms and antennas on outdoor test ranges, or in large anechoic chambers, all to full performance with a compact and easy-to-use solution. Inritsu, providing excellence in MM-wave measurements, covering the distance with our patented phase-link technology, integrated into the Shockline ME7869A modular vector network analyzer. Inritsu, advancing beyond.
Our product is called XDEC, which consists of hardware and software that we created in-house. We integrate our device with the semiconductor chip industry to help them reduce their cost for testing and get more reliable and also high yield of their product. The current problem in the semiconductor industry testing for the chip is because the current equipment is bulky, expensive, and also not integrated. Our solution provides technology that's 20 times smaller, 3 times cheaper, all integrated with easy-to-use software. Our device analyzing the reliability of the chip. This reduces the amount of defective chips and also puts out high yield in the manufacturing. It is important for the semiconductor chip manufacturers. So we have shipped our product to over 15 countries. Now also being used to different applications such as the AI, quantum, and also in data centers. NASA used for the space, US Army for defense, and the NVIDIA for the AI. For those companies, they use our equipment to be integrated with this chip to make it function properly in different applications. One of the best functions of our product is provide the voltage and current. Our equipment helps so it can work properly into different applications. We are inspired to create more innovative devices so we can help people to have a better life around the world. This motivates our team every day.
Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and biodiversity. We and Indonesia are the necessary combination to realize the grand visions of the future. Like an orchestra, BRIN harmonizes research, development, assessment, application, and also synergies, invention, and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language, and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, Research Organization for Governance, Economy, and Community Welfare. BRIN catalyzing research and innovation to develop an advanced scientific ecosystem in Indonesia with 2 main targets. BRIN realizes the tremendous potential of the nation's youth in the field of science and technology. Thus, various research and innovation policies are being formulated to develop and cultivate human resources with high competence and aptitude in science and technology. Creating many excellent programs is a form of BRIN's commitment to researchers, innovators, and the general population from various disciplines across the nation. The research and innovation ecosystem quality improvement in Indonesia is also realized through the collaboration of various ministries, institutions, domestic industries, and regional governments, to name a few, by forming the Regional Research and Innovation Agency, or RIDA. Moreover, cooperation with various foreign research institutions continue to be developed through active participation as member of various organizations and international forums. BRIN organizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of various research and innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and revitalizing 4 areas of science and technology, or KST. An integrated area consisting of research laboratory facilities, testing laboratories, and industrial facilities for both startups and SMEs, tenant office rooms, co-working space, meeting rooms, gallery rooms, and other supporting facilities. BRIN is here to manifest the future of a golden Indonesia 2045 by consolidating science and technology resources and creating a resource ecosystem and research-based economical foundation. Transforming Indonesia as a global reference in the development and application of science and technology, practices, and the good of humankind. Nature is the source of inspiration. Knowledge is the foundation, and to be put in praxis for the sake of the nation.
Over 100 years ago, the discovery of radio waves marked the start of a new era. At that time, our founders Lothar Rode and Hermann Schwarz were still at school. They were immediately fascinated by this new technology and driven by a curiosity about the unprecedented possibilities it offered. Pioneering scientific spirit and entrepreneurial courage have always been the foundation for the success of Rode and Schwarz. Making ideas real and striving for excellence. The spirit and mindset of our founders live on today and continue to evolve from one generation to the next. Every day, thousands of employees worldwide benefit from the knowledge that is accumulated in our company over decades. At Rode and Schwarz, they learn from each other, showing respect for that which came before them. We're part of this world and pass on our knowledge by providing the best possible solutions and systems. We've never made a secret of our innovation culture. At Roda and Schwartz, excellent development performance and entrepreneurial behavior go hand in hand. We make a difference. Driven by our distinctive passion for technology, we create the innovations that are highly relevant for a safer and connected world. Our customers and partners know they can always rely on us to deliver the highest quality. We are strongly positioned and look forward to a successful future. Our mission is clear: make ideas real. Yesterday, today, and tomorrow.
Making accurate antenna measurements in large chambers and outdoor antenna test ranges, or making long-distance measurements such as testing long cable runs on aircrafts or ships are not easy tasks. The traditional measurement solution uses a two-port benchtop vector network analyzer, a VNA, where the user must attach two very long test port cables. The problem with this solution is that long cables introduce signal loss, reducing dynamic range. To overcome this challenge, a high-end VNA is required, and components such as low-noise amplifiers are introduced to improve dynamic range. As the frequency of interest goes higher, however, small movements in the test port cables have an adverse effect on signal phase. Introducing the solution to long-distance S-parameter measurement problems, the Inritsu Shockline ME7869A. This modular two-port distributed VNA can make vector-corrected S-parameter measurements over distances as long as 100 meters. Complicated test setups and lossy cables are eliminated, since the instruments are powered by Inritsu's patented phase-link technology. This technology allows synchronization between the two VNA test ports using optical cables. No matter how much the user moves the cables, there's no phase deviation, while system dynamic range is fully preserved no matter the distance between test ports. Now you can confidently test long cable runs from aircraft's nose to tail and wingtip to wingtip, from ship's antennas to underdeck control rooms and antennas on outdoor test ranges or in large anechoic chambers, all to full performance with a compact and easy-to-use solution. Inritsu, providing excellence in wave measurements, covering the distance with our patented phase-link technology, integrated into the Shockline ME7869A modular vector network analyzer. Inritsu, advancing beyond.
Our product is called XDEC, which consists of hardware and software that we created in-house. We integrate our device with the semiconductor chip industry to help them reduce their cost for testing and get more reliable and also high yield of their product. The current problem in the semiconductor industry testing for the chip is because the current equipment is bulky, expensive, and also not integrated. Our solution provides technology that's 20 times smaller, 3 times cheaper, all integrated with easy-to-use software. Our device analyzing the reliability of the chip. This reduces the amount of defective chips and also puts out high yield in the manufacturing. It is important for the semiconductor chip manufacturers. So we have shipped our product to over 15 countries. Now also being used to different applications such as the AI, quantum, and also in data centers. NASA used for the space, the US Army for defense, and the NVIDIA for the AI. For those companies, they use our equipment to be integrated with their chips to make it function properly in different applications. One of the best functions of our product is provide the voltage and current. Our equipment helps guide light so it can work properly into different applications. We are inspired to create more innovative devices so we can help people to have a better life around the world. This motivates our team every day.
Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and biodiversity. We and Indonesia are the necessary combination to realize the grand visions of the future. Like an orchestra, BRIN harmonizes research, development, assessment, application, and also synergies, invention, and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language, and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, Research Organization for Governance, Economy, and Community Welfare. BRIN catalyzing research and innovation to develop an advanced scientific ecosystem in Indonesia with 2 main targets. recognizes the tremendous potential of the nation's youth in the field of science and technology. Thus, various research and innovation policies are being formulated to develop and cultivate human resources with high competence and aptitude in science and technology. Creating many excellent programs is a form of BRIN's commitment to researchers, innovators, and the general population from various disciplines across the nation. The research and innovation ecosystem quality improvement in Indonesia is also realized through the collaboration of various ministries, institutions, domestic industries, and regional governments, to name a few, by forming the Regional Research and Innovation Agency, or RIDA. Moreover, cooperation with various foreign research institutions continue to be developed through active participation as member of various organizations and international forums. BRIN organizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of various research and innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and revitalizing 4 areas of science and technology, or KST. An integrated area consisting of research laboratory facilities, testing laboratories, and industrial facilities for both startups and SMEs. Tenant office rooms, co-working space, meeting rooms, gallery rooms, and other supporting facilities. BRIN is here to manifest the future of a golden Indonesia 2045 by consolidating science and technology resources and creating a resource ecosystem and research-based economical foundation. Transforming Indonesia as a global reference in the development and application of science and technology practices and the good of humankind. Nature is the source of inspiration. Knowledge is the foundation, and to be put in praxis for the sake of the nation.
Over 100 years ago, the discovery of radio waves marked the start of a new era. At that time, our founders Lothar Rode and Hermann Schwarz were still at school. They were immediately fascinated by this new technology and driven by a curiosity about the unprecedented possibilities it offered. A pioneering scientific spirit and entrepreneurial courage have always been the foundation for the success of Rode and Schwarz. Making ideas real and striving for excellence. The spirit and mindset of our founders live on today and continue to evolve from one generation to the next. Every day, thousands of employees worldwide benefit from the knowledge that is accumulated in our company over decades. At Rode and Schwarz, they learn from each other, showing respect for that which came before them. We're part of this world and pass on our knowledge by providing the best possible solutions and systems. We've never made a secret of our innovation culture. At Rode and Schwarz, excellent development performance and entrepreneurial behavior go hand in hand. We make a difference. Driven by our distinctive passion for technology, we create the innovations that are highly relevant for a safer and connected world. Our customers and partners know they can always rely on us to deliver the highest quality. We are strongly positioned and look forward to a successful future. Our mission is clear: make ideas real. Yesterday, today, and tomorrow. Over 100 years ago, the discovery of radio waves marked the start of a new era. At that time, our founders Lothar Rode and Hermann Schwarz were still at school. They were immediately fascinated by this new technology and driven by a curiosity about the unprecedented possibilities it offered. A pioneering scientific spirit and entrepreneurial courage have always been the foundation.
Making accurate antenna measurements in large chambers and outdoor antenna test ranges, or making long-distance measurements such as testing long cable runs on aircrafts or ships are not easy tasks. The traditional measurement solution uses a two-port benchtop vector network analyzer, a VNA, where the user must attach two very long test port cables. The problem with this solution is that long cables introduce signal loss, reducing dynamic range. To overcome this challenge, a high-end VNA is required, and components such as low-noise amplifiers are introduced to improve dynamic range. As the frequency of interest goes higher, however, small movements in the test port cables have an adverse effect on signal phase. Introducing the solution to long-distance S-parameter measurement problems, the Inritsu Shockline ME7869A. This modular two-port distributed VNA can make vector-corrected S-parameter measurements over distances as long as 100 meters. Complicated test setups and lossy cables are eliminated, since the instruments are powered by Inritsu's patented phase-link technology. This technology allows synchronization between the two VNA test ports using optical cables. No matter how much the user moves the cables, there's no phase deviation, while system dynamic range is fully preserved no matter the distance between test ports. Now you can confidently test long cable runs from aircraft's nose to tail and wingtip to wingtip, from ship's antennas to underdeck control rooms and antennas on outdoor test ranges, or in large anechoic chambers, all to full performance with a compact and easy-to-use solution. Inritsu, providing excellence in wave measurements, covering the distance with our patented phase-link technology, integrated into the Shockline ME7869A modular vector network analyzer. Inritsu, advancing beyond.
Our product is called XDEC, which consists of hardware and software that we created in-house. We integrate our device with the semiconductor chip industry to help them reduce their cost for testing and get more reliable and also high yield of their product. The current problem in the semiconductor industry testing for the chip is because the current equipment is bulky, expensive, and also not integrated. Our solution provides technology that's 20 times smaller, 3 times cheaper, all integrated with easy-to-use software. Our device analyzing the reliability of the chip. This reduces the amount of defective chips and also puts out high yield in the manufacturing. It is important for the semiconductor chip manufacturers. So we have shipped our product to over 15 countries. Now also being used to different applications such as the AI, quantum, and also in data centers. NASA used for the space, US Army for defense, and the NVIDIA for the AI. For those companies, they use our equipment to be integrated with their chips to make it function properly in different applications. One of the best functions of our product is provide the voltage control. Our equipment helps guide light so it can work properly into different applications. We are inspired to create more innovative devices so we can help people to have a better life around the world. This motivates our team every day.
Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and biodiversity. We and Indonesia are the necessary combination to realize the grand visions of the future. Like an orchestra, BRIN harmonizes research, development, assessment, application, and also synergies, invention, and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language, and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, Research Organization for Governance, Economy, and Community Welfare. BRIN catalyzing research and innovation to develop an advanced scientific ecosystem in Indonesia with 2 main targets. BRIN realizes the tremendous potential of the nation's youth in the field of science and technology. Thus, various research and innovation policies are being formulated to develop and cultivate human resources with high competence and aptitude in science and technology. Creating many excellent programs is a form of BRIN's commitment to researchers, innovators, and the general population from various disciplines across the nation. The research and innovation ecosystem quality improvement in Indonesia is also realized through the collaboration of various ministries, institutions, domestic industries, and regional governments, to name a few, by forming the Regional Research and Innovation Agency, or RIDA. Moreover, cooperation with various foreign research institutions continue to be developed through active participation as member of various organizations and international forums. optimizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of various research and innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and revitalizing 4 areas of science and technology, or KST. An integrated area consisting of research laboratory facilities, testing laboratories, and industrial facilities for both startups and SMEs, tenant office rooms, co-working space, meeting rooms, gallery rooms, and other supporting facilities. BRIN is here to manifest the future of a golden Indonesia 2045 by consolidating science and technology resources and creating a resource ecosystem and research-based economical foundation. Transforming Indonesia as a global reference in the development and application of science and technology, practices, and the good of humankind. Nature is the source of inspiration. Knowledge is the foundation, and to be put in praxis for the sake of the nation.
Over 100 years ago, the discovery of radio waves marked the start of a new era. At that time, our founders Lothar Rode and Hermann Schwarz were still at school. They were immediately fascinated by this new technology and driven by a curiosity about the unprecedented possibilities it offered. Pioneering scientific spirit and entrepreneurial courage have always been the foundation for the success of Rode and Schwarz. Making ideas real and striving for excellence. The spirit and mindset of our founders live on today and continue to evolve from one generation to the next. Every day, thousands of employees worldwide benefit from the knowledge that is accumulated in our company over decades. At Rode and Schwarz, they learn from each other, showing respect for that which came before them. We're part of this world and pass on our knowledge by providing the best possible solutions and systems. We've never made a secret of our innovation culture. At Rode and Schwarz, excellent development performance and entrepreneurial behavior go hand in hand. We make a difference. Driven by our distinctive passion for technology, we create the innovations that are highly relevant for a safer and connected world. Our customers and partners know they can always rely on us to deliver the highest quality. We are strongly positioned and look forward to a successful future. Our mission is clear. Make ideas real. Yesterday, today, and tomorrow.
Making accurate antenna measurements in large chambers and outdoor antenna test ranges, or making long-distance measurements such as testing long cable runs on aircrafts or ships are not easy tasks. The traditional measurement solution uses a two-port benchtop vector network analyzer, a VNA, where the user system dynamic range is fully preserved, no matter the distance between test ports. Now you can confidently test long cable runs from aircraft's nose to tail and wingtip to wingtip, from ship's antennas to underdeck control room, and antennas on outdoor test ranges, or a large anechoic chamber, all to full performance with a compact and easy-to-use solution. Invensi, providing excellence in in-and-length measurements, covering the distance with our patented phase range technology, integrated into the Shotline NE7869A modular vector network analyzer. Invensi, advancing beyond.
integrated with devices to make it function properly in different applications. One of the best functions of our product is provide the voltage and current. Our equipment helps guide light so it can work properly into different applications. We are inspired to create more innovative devices so we can help people to have a better life around the world. This motivates our team every day.
Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and biodiversity. We and Indonesia are the necessary combination to realize the grand visions of the future. Like an orchestra, BRIN harmonizes research, development, assessment, application, and also synergies, invention, and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language, and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, Research Organization for Governance, Economy, and Community Welfare. BRIN catalyzing research and innovation to develop an advanced scientific ecosystem in Indonesia with 2 main targets. BRIN realizes the tremendous potential of the nation's youth in the field of science and technology. Thus, various research and innovation policies are being formulated to develop and cultivate human resources with high competence and aptitude in science and technology. Creating many excellent programs is a form of BRIN's commitment to researchers, innovators, and the general population from various disciplines across the nation. The research and innovation ecosystem quality improvement in Indonesia is also realized through the collaboration of various ministries, institutions, domestic industries, and regional governments, to name a few, by forming the Regional Research and Innovation Agency, or RIDA. Moreover, cooperation with various foreign research institutions continue to be developed through active participation as member of various organizations and international forums. BRIN organizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of various research and innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and revitalizing 4 areas of science and technology, or KST. An integrated area consisting of research laboratory facilities, testing laboratories, and industrial facilities for both startups and SMEs, tenant office rooms, co-working space, meeting rooms, gallery rooms, and other supporting facilities. BRIN is here to manifest the future of a golden Indonesia 2045 by consolidating science and technology resources and creating a resource ecosystem and research-based economical foundation. Transforming Indonesia as a global reference in the development and application of science and technology practices and the good of humankind. Nature is the source of inspiration. Knowledge is the foundation, and to be put in praxis for the sake of the nation.
Over 100 years ago, the discovery of radio waves marked the start of a new era. At that time, our founders Lothar Rode and Hermann Schwarz were still at school. They were immediately fascinated by this new technology and driven by a curiosity about the unprecedented possibilities it offered. A pioneering scientific spirit and entrepreneurial courage have always been the foundation for the success of Rode and Schwarz. Making ideas real and striving for excellence. The spirit and mindset of our founders live on today and continue to evolve from one generation to the next. Every day, Thousands of employees worldwide benefit from the knowledge that is accumulated in our company over decades. At Roda and Schwarz, they learn from each other, showing respect for that which came before them. We're part of this world and pass on our knowledge by providing the best possible solutions and systems. We've never made a secret of our innovation culture. At Roda and Schwarz, excellent development performance and entrepreneurial behavior go hand in hand. We make a difference. Driven by our distinctive passion for technology, we create the innovations that are highly relevant for a safer and connected world. Our customers and partners know they can always rely on us to deliver the highest quality. We are strongly positioned and look forward to a successful future. Our mission is clear: make ideas real. Yesterday, today, and tomorrow.
Making accurate antenna measurements in large chambers and outdoor antenna test ranges, or making long-distance measurements such as testing long cable runs on aircrafts or ships are not easy tasks. The traditional measurement solution uses a two-port benchtop vector network analyzer, a VNA, where the user must attach two very long test port cables. The problem with this solution is that long cables introduce signal loss, reducing dynamic range. To overcome this challenge, a high-end VNA is required, and components such as low-noise amplifiers are introduced to improve dynamic range. As the frequency of interest goes higher, however, small movements in the test port cables have an adverse effect on signal phase. Introducing the solution to long-distance S-parameter measurement problems, the Inritsu Shockline ME7869A. This modular two-port distributed VNA can make vector-corrected S-parameter measurements over distances as long as 100 meters. Complicated test setups and lossy cables are eliminated, since the instruments are powered by Inritsu's patented PhaseLink technology. This technology allows synchronization between the two VNA test ports using optical cables. No matter how much the user moves the cables, there's no phase deviation, while system dynamic range is fully preserved no matter the distance between test ports. Now you can confidently test long cable runs from aircraft's nose to tail and wingtip to wingtip, from ship's antennas to underdeck control rooms and antennas on outdoor test ranges, or in large anechoic chambers, all to full performance with a compact and easy-to-use solution. Inritsu, providing excellence in MM-wave measurements, covering the distance with our patented PhaseLink technology, integrated into the Shockline ME7869A modular vector network analyzer. Inritsu, advancing beyond.
Our product is called XDEC, which consists of hardware and software that we created in-house. We integrate our device with the semiconductor chip industry to help them reduce their cost for testing and get more reliable and also high yield of their product. The current problem in the semiconductor industry testing for the chip is because the current equipment is bulky, expensive, and also not integrated. Our solution provides technology that's 20 times smaller, 3 times cheaper, all integrated with easy-to-use software. Our device analyzing the reliability of the chip. This reduces the amount of defective chips and also puts out high yield in the manufacturing. It is important for the semiconductor chip manufacturers. So we have shipped our product to over 15 countries. Now also being used to different applications such as the AI, quantum, and also in data centers. NASA used for the space, US Army for defense, and the NVIDIA for the AI. For those companies, they use our equipment to be integrated with their chips to make it function properly in different applications. One of the best functions of our product is provide the voltage and current. Our equipment helps guide light so it can work properly into different applications. We are inspired to create more innovative devices so we can help people to have a better life around the world. This motivates our team every day.
Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. And to culture, biodiversity. We and Indonesia are the necessary combination to realize the grand visions of the future. Like an orchestra, BRIN harmonizes research, development, assessment, application, and also synergies, invention, and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language, and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, Research Organization for Governance.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Welcome to the session of ICRAMET 2025. I'm Budiman Putra Asma Roman from National Research and Innovation Agency, will serving as a moderator in this session. Okay, before we begin, I would like to make sure that all of our presenters are present. Maybe I can call your name one by one, and simply you can say yes or present, whether you present. Mr. Toha from first paper, are you present now? No? Okay. And second presenter, Marsan Nishwah Shamsul, are you present now? Okay, thank you. And the third presenter, Mr. Tutu Bahtiar Palkutu in online, are you present now?
Yes, I'm here.
Okay, thank you very much. And Mr. Zerandi from online presenter, are you present now?
Yes, I'm here now.
Okay, thank you very much. So we are glad to have everyone with us. So this session will feature 4 exciting presentation covering wireless and wired communication. And each presenter will have 9 until 11 minutes for giving the presentation, following by short question and answer session. So the total of about 15 minutes. And I can remind you that keep an eye the time so that we can maintain the schedule. Now let's begin our first presentation. I would like to invite the first presenter is not present now, so I would like to invite the Miss Marsan Nishwah Shamsul from Telkom University to present the paper with titled Evaluation of the Impact of Fiber Cabling and Fitting Techniques on Chromatic Dispersion Characteristics in FTTH Installation. So please come to give the presentation, Ms. Marsania.
Recording in progress.
Yes. Okay, so good afternoon, everyone. My name is Marshani Sosamsul from Telkom University, and in this opportunity, I would like to present our research with the title Evaluation of the Impact of Fiber Cabling and Feeding Techniques on Chromatic Dispersion Characteristic in Fiber to the Home Installation. Before we start, this is the outline for today's presentation. I would start with introduction, follow with research material, methodology, and result and discussion, and ending it with conclusion. As we know, in optical communication system, the transmitted signal travel into different wavelength, and as a result, the spectrum disturbed due to what we call here is the optical fiber chromatic dispersion, and it can explain well as the first figure, and then the second figure explain how the chromatic delay curve that help us understanding how the chromatic dispersion is actually varies in wavelength. And despite the optical characteristic, mechanical also has important role. Like for example, in the right figures shows how stress, elongation, fiber length, and etc. Mechanical type of properties also impact the optical characteristic. And so for these insights, the goal for our research is to provide a direct comparative evaluation of bare and cable fibers using multiple data feeding approaches to better understanding how cabling is effect to this characteristic. So to conduct this research, this is the material that we use. All fiber samples, both bare and cable, were sourced from ITOT G65 to the fibers that commonly install in fiber to the home infrastructure, and it divided into bare fiber that tested directly without cabling and cable fiber, which directly taken from all the electric self-supporting or IDSS cables. And the right figure shows the structure of cable that we use. And also to mention that all the cable, both bare and cable, is single mode fibers. And next is to make sure there's no environmental factors. All tests were conducted in controlled laboratory environment with an average temperature, humidity, and supply voltage that we controlled. And these are the tools that we use to conduct the research: PE fiber optics, CD500, chromatic dispersion test sets, and each core was tested individually across 4 distinct data feeds, and we use differentiate 4-term Selmayr equation, 4-term polynomial fit, 5-term Selmayr equation, and linear fit. And the formulation and definition for chromatic dispersion and related parameters used in the study were derived for ITOTG 6501 standard. And for methodology, first we're going to prepare our data. And what we do first is to divide it into independent variables, which are feeding method and cabling process, and then dependent variables, which lambda 0 and dispersion slope. And after that, we're going to clean our data sets by removing outliers and missing values. And after that, we conduct the normality and homogeneity test. But because it's failed, we use non-parametric approach instead. And the goal here why we use this methodology is simply evaluate whether cabling process and data feeding method that significantly affect the chromatic dispersion. And the approach that we use here is non-parametric two-way analysis, or Ray hair test and post hoc dance test. And all the methodology that conduct here is conduct in Python. And finally, we arrive in results. And let's start with the effect of data feeding and cabling process on lambda 0. And this first figure shows the results for of the non-parametric approach. And as we can see here, that cabling process has the main significant effect to lambda 0, while the data feed does not have a main effect to it. And as we can see here, the statistic of lambda 0 by fiber type, there are 4 to 5 nanometer shift between bare and cable. And this observation supports prior findings that I talked in introduction. The cable fiber often experience stress-induced perturbation, such as microbending or mechanical strain, which can slightly alter the effective refractive index and shift the 0 dispersion. And next is the effect of data feeding and cabling process on slope dispersion, 0 dispersion slope, and it's quite contrast compared to the last one, because in here the data feed has main effect to 0 dispersion slope, while the cabling process does not have the main effect to it. So and then what we can conclude from the result is the linear feed, regardless the compared to the other data feeding, always gives the lowest slope rank, both the main rank and also the interaction plot, and they always consistently the lowest, while in contrast the higher order models such as the 5-term Selmayr produce larger and more consistent slope values. And to discuss, this is the core findings from our research. So first is the cabling process. It significantly affects the lambda zero, and it shows by the mechanical stress shifts, zero dispersion wavelength, 4 to 5 nanometer shift, and for data feeding, it also affects the dispersion slope, and it shows by the modeling choices that can influence the accuracy of chromatic dispersion characterization. And for practical implication, dispersion shift can affect the signal integrity in fiber to the home, and even minor lambda zero changes impact wavelength allocation and dispersion maps. And this results emphasize the need for careful mechanical handling during cabling and also accurate dispersion modeling. And from this research, I more recommend the Silmer. And for the limitation, the small sample size, it then limits the parametric testing and the unique group sizes that leads to increases measurement noise. And for future work, we hope that the future work use pair samples, same fiber before and after cabling, and to also improve the statistical power to stronger causal inference. And to conclude, the cabling process and data feeding method both significantly influence fiber chromatic dispersion characteristic. And but bare versus cable fiber shows 4 to 5 nanometer lambda zero shift that indicates mechanical stress influence. And for model effect, linear fit underestimate chromatic dispersion slope. So Silmer models provide more physical accuracy. And for practical relevance, important for fiber to the home design, wavelength allocation, and dispersion map accuracy. I would like to express my gratitude for Telecom Test House to provide us facilities to conduct this research, and also for my mentors and co-authors for their valuable guidance. Thank you very much for your attention, and I'd like to answer question from you all. Thank you.
Okay, thank you very much for the good presentation. Okay, is there any question from the floor? No? Okay, and from the Zoom? No, there is no question.
I have.
Okay.
Okay. Thank you very much.
From the Zoom. Yes,
From Zoom,
please.
yes. Who is going to be asking? It's me or somebody else?
Yes, Mr. Tirandi.
Okay, thank you
Please.
very much for the opportunity. I have just one short question. So, what kind of knowledge that we can learn from this work in terms of in practice? I mean, I'm not familiar with fiber, but you know, I don't know whether we use bare fiber cable for FTTH installations rather than the cable one. So I would like to know what's the knowledge that we can learn from this experiments. Thank you.
Okay.
Okay, please.
Okay. Thank you for the question. So from actually this research is a background by the needs of knowing which data feeding actually really represent the chromatic dispersion, and why this is important, especially for fiber to the home installations. As I also shows before that, 4 to 5 nanometer in shift in lambda zero from bare to cable is quite impactful if we want to network planning, and also it can disturb the network, especially if the fiber optic is close to the point. So yeah, for that, this research actually contribute to yeah, whether the data feed have a strong and also can accurately display the chromatic dispersion, and also to actually know that there's a mechanical properties effect influence if we conduct the chromatic dispersion test. So yeah.
Do we use bare fiber optic cable for FTTH installation in practice? Do we use bare cable?
Okay, so in practice, we don't use the bare. Actually, and I'm talking about when we conduct this in the road. We use cabling fibers. So yeah, we compare this in our research to yeah, to know how many shift do it occurs compared to bear. So yeah.
Okay, thank you.
Okay, thank you for the answer. Thank you, Mr. Zerani, for the question. Is there any other question? No? Apa? Zoom. Oh, chat Zoom. Okay. Okay, there is one question from Mr. Muhammad Iqbal. Quick question. From your experiment, do the cable performance are still in the acceptable level? So there is a trade-off if we are using blanket for the cable. So the practicality if we still use blanket for the cable, is this still used? Can be used? Oh, bukan itu.
Okay. I assume this blanket refers to the jacket in fibers, like, or
I think the question is from your result, the effect of the blanket for the fiber optic is affected to the dispersion of the fiber optic. And your conclusion is it still acceptable if we use the blanketed fiber optic?
okay. Okay, so from standard, especially because we also conduct this research in Telecom Test House and follow their standard, yes, it is still acceptable, even with the 4 to 5, the nanometer shift, the earlier. So
Is acceptable. I think there's no more answer. Maybe I want to ask one answer. So you analyze the effect of the fitting and what is meaning?
cabling.
Fiber cabling.
Yes.
Yes. What is your suggestion to the telecommunication industry when we want to choose the best, the good fiber optic? Consider your result.
Okay, so my recommendation, especially for network applications, first is the data feeding. I'm more likely to recommend the Selmayr model. And why is that? Because it more gives the best in both the chromatic dispersion characters that we analyze. And then for cabling, type of cabling, bare and cable, we, because in practical it conduct in cable jacket, cable fibers that use jacket, we recommend to more more aware when conduct the chromatic dispersion test because in this research it does have influence to it.
So you mean the telecommunication industry should consider the effect of the cabling and the fitting?
Yes.
Yeah. Okay. Uh, okay. I think there is no more question and time is up. Okay. So I close this session. Okay. Please give applause for the presenter. Okay. Okay. Next, we move on to the second presenter. Maybe the first presenter is present now, Mr. Toha, on in Zoom. No. No. Still no. Okay. So we move to the third presenter, Mr. Toto from National Research and Innovation Agency Indonesia. Mr. Toto?
Yeah, I'm here.
Okay. So please. Okay. Research for NTP or network traffic prediction has emerged recently because the need to manage the network intelligently and autonomously. This need driven by the rapid growth of network research and the limited resource. NTP empowering INM or intelligent network management because it's enabling resource allocation and traffic optimization. With just these two features, the workload of network operators has lowered, resulting in increased network efficiency. So what is INM? INM has attracted the interest of many researchers over the years. However, there was no agreed definition among them, although we can draw conclusions based on the researchers. INM is a network that utilizes machine learning or artificial intelligence to analyze and manage their nodes. We can highlight some previous researchers, such as this Milan research. They use open network traffic dataset to test their proposed method, which is combining Butterworth filter, convolutional network, and long short-term memory, or LSTM. We believe that their method need to be implemented in other network traffic dataset because there will be unique pattern in each dataset. Next, this research is comparing linear regression, recurrent neural network, and LSTM in a simulated 5G cellular network environment. They use synthetic traffic dataset. Even though it's enough to accommodate the research, the pattern difference in network traffic was not addressed. Lastly, simulate intelligent software-defined network. This research able to integrate machine learning or AI in a network. Since it focused on improving QoS or quality of service in a network, the error evaluation of the algorithm was untouched. In this research, we introduced cable-based tsunameter, or CBT, as new source of network traffic dataset, or NTD, and then compare it with another popular NTDs. CBT is a network traffic dataset that extracted from CBT system that has been deployed. Informer is new algorithm that based on transformer. This algorithm is rarely used in NTP case. Since LSTM is widely used in NTP cases, Informer will compare against LSTM for the performance reference. Methodology. The datasets available through several websites were extracted and then pre-processed. We form all datasets in equal standard to make a fair comparison. We predict 1 time step ahead using 96 time steps or 1 day's worth of traffic. Then we implement these two algorithms
Lastly, we evaluate their performance over their respective datasets. As we can see here, our dataset represents unique behavior. Apilene shows a steady increase in low and peak traffic and have some anomalies. Jian have ups and down with no anomalies, while CBT has no increase in low traffic, and it is unclear whether it's anomaly or peak data. However, if we draw this track line based on average of all high traffic, we can see that there are many anomalies in CBT datasets. We use Pandas library to pre-process the dataset, all of the traffic converted into gigabytes, and each time step represent 15 minutes interval. Then we normalize this dataset using standard normalization. After we pre-process the datasets, we implement LSTM and Informer. LSTM is based on recurrent neural network or RNN. LSTM using gets function instead of backpropagation scheme. That is why LSTM overcomes the limitation of RNN, where RNN has difficulty learning the long-term dependencies of its data. Informer based on transformer, which designed for time series problem. Informer replace self-attention function that used in transformer with the probe sparse self-attention, which only focus on the most important input data. We evaluate those algorithms in all datasets using 4 evaluation metrics: mean square error, root mean square error, mean absolute error, and R-square. The mean square error are more punishing when error are dominated by outliers. And mean absolute error is less sensitive to outliers, or in this case is anomalies, and equally punishes errors whether caused by outliers or not. The R-square is illustrating how fit the result of the algorithm to the variance of the true data. All of this we using scikit-learn library. Result and discussion section contain 2 subsections, which are error tables and graph comparison. As we can see in this error table, even though Informer show a slightly better performance, the difference of all evaluation metric between LSTM and Informer are too small when using Abilene and CBT dataset. While using GN dataset, the results show more significant difference, while LSTM shows more inferior results. And if we can verify in this graph comparison, this graph comparison display the comparison between predicted and true traffic of each dataset. In Abilene dataset has too few anomalies to disrupt both algorithms. That is why both algorithm performance run well in these datasets. While in CPT, both algorithm experiencing difficulty to predict this dataset because there's no clear anomalies and high traffic in this dataset. But if we draw these red lines, red line is represent the average high value traffic of CPT, and this is the predicted high traffic value of both algorithm, showing that they can only predict 50% of the true traffic. Lastly, in GN dataset, LSTM has less accuracy compared to Informer. Even though it has less accuracy, LSTM still able to recognize the traffic patterns. It is resulting graph could follow the GN's trend. And LSTM tends to overestimate the true value of GN traffic. With all that, we can conclude that Informer can be implemented to achieve the NNM concept. It has superior performance compared to LSTM. However, in Apilene and CPT, the difference is really small. It raises a question: it is worth it or not to implement Informer, because the computational cost of Informer is really high compared to LSTM. The CPT dataset can be used in NTP research if the researchers want to predict network traffic with more volatile behavior. Some metrics such as number of peaks, downward and upward slopes may be the indicators of anti-disk behavior. Understanding this anti-disk behavior could help future research in network traffic prediction. I think that is all. Thank you.
Okay, thank you very much for the good presentation. I think it is very interesting. From the floor, is there any question? From the Zoom, is there any question? Nope. Okay, if there is no question from the floor or the Zoom, may I ask one question? Mr. Toto, in your study, you try to predict the network by using deep learning. What the real application when we can predict the network in reality? Maybe you can give us the understanding regarding the importance of this prediction. Thank you. Please.
Okay, thank you, Mr. Moderator. So if we can predict the traffic network, we can allocate the resource earlier. We can plan how many bandwidth, how many wattage that we should allocate to this network. And if we see the previous research about the intelligent software-defined network, I think it's also possible that they can intelligently analyze the whole network. And traffic prediction is just one feature that make intelligent and autonomous network possible. And I like to add some providers that already going to research about it. It's Indosat and Telkom. In some news, I've seen them using AI to efficiently manage their network. So I think that's really what you call it, really good research in the future. Oh, thank you.
Okay, thank you for the answer. I think it is clear about the application of the prediction of the network. Is there any other question? No? From Zoom? Nope. Okay. I want to ask one more question regarding prediction of the network, especially about your study. So your study use Informer and RNN, if I don't mistake. Informer is the different version of the transformer, and as I know, the Informer has the big model size, and the comparison with the LSTM, which is the bigger, Informer or LSTM? Maybe we can get the advantages of your model from the complexity or the size model.
Okay, I will try answer the question. So yeah, LSTM is using far more resource than, Informer actually using far more resource than LSTM. And it's actually one of our future research. Maybe one day we have an agenda to do that research. So yeah, for comparison, LSTM, when we implement LSTM, is actually only spend 15 minutes or 20 minutes. But if we use informer, it took hours. The fastest one that we experience is actually 1.5 hours. So it's really big comparison. And if we see the error rate between LSTM and informer on some data sets, in this research we use Apilene and CPT, I don't think it's worth the trouble to implement informer. However, if we want to use in something else, some other data set, we need to verify that the difference between error between LSTM and informer, it's worth the trouble or not. So yeah, I think that's my answer.
Okay, thank you very much for your answer. I think it is clear about your model. Maybe the performance is slightly different, but the model size is smaller, far smaller than the informer. That's why the performance is slightly lower than the informer. Okay. Thank you for the good presentation and good answer from the Mr. Tutu. Next, we move on to the fourth presenter, or maybe the first presenter is present. Okay. Mr. Toha, can you say yes or present now? Mr. Toha?
Yes, I already sent recorded video to the link.
Okay. So thank you your presence, and please start the video of the presentation.
Microwave Electronics and Telecommunication, ICRAMET 2025. My name is Tohadi Nugraha. I'm from Department of Electrical Engineering, Universitas Muhammadiyah, Yogyakarta. This is the outline of my presentation. First is motivation and background, then objective, then system model and problem formulation, and proposed different machine learning, performance evaluation, and the last is conclusion and future work. In the motivation and background, in the increasing of vehicular communication in cellular network, it also we have increasing of connected vehicle. The challenge is if the vehicle is in mobility, so it can make a dynamic channel condition. So it make interference between vehicles, and also if we have same spectrum with the devices or mobile phone, it make interference. So we need to manage interference between vehicle to vehicle and also with vehicle to devices. And we need the decentralized allocation to manage interference and also to manage resource in network. And in the key technology, we have device-to-device communication. It means that direct communication between two devices, and also we have vehicle-to-vehicle communication, means that communication between two or more vehicle in the network. And we also consider radio resource management. In here, we allocate the channel or a frequency, and also we use a resource block for the frequency allocation. And we use range transfer learning with the deep range transfer learning for a resource allocation. And the objective is to design deep range transfer learning approach that integrates V2V, D2D, and conventional communication. And we propose a resource allocation scheme for V2V communication by applying deep transfer learning to improve some capacity in cellular network, and also we have to satisfy the QoS requirements of the CUE links. And this is the system model of our work. We have SINR, signal to interference noise ratio of V2V link, and we calculate it, and we also calculate D2D link, and also we calculate CUE links. So it means that the power divided by the interference. So if we have SINR of each links, and then we can calculate capacity of each link. For example, here calculate the calculation of V2V link. We calculate based on Shannon capacity. We consider resource block and also SINR. So we can calculate sentence based on the resource and also based on the SCNR. And then this is the problem formulation of our work. We have to maximize some capacity of CUE, D2D, and V2V links, and also we need to guarantee QoS for CUE communication. And here N means the resource block, and C means the cellular, and D means D2D, and V means vehicle communication. Capital C means the capacity of cellular, and capacity of D2D, and capacity of V2V. And the capacity of cellular here, we have to guarantee more than minimum capacity of the cellular link. And for the proposed deep reinforcement learning, we have some key here. We have agent, action, state, and rewards. In here, we have action, agent as V2V links, and the V2V links here, we interact with the environment by selecting the action to maximize the rewards. And for the states, means that the state is the interference, and the reward is to optimize the interference with the environment. Then the action is the resource block allocations. So we need to maximize the capacity in the rewards. This is the goal, is to determine the optimal policy that maximizes rewards. In here, the rewards is the maximum capacity, and there are some step here as we see from the figure. So we need to maximize it, and with the state here from the agent, initial state here is interference, and also channel condition, and also resource block allocation. So for after that, the agent or V2V link receive the reward. Rewards mean that we have to maximize the capacity from the environment. So based on the environment, we need to maximize the reward based on, because we use deep reinforcement learning, we need to consider key value here. The key value means that we use the deep neural network to make a decision in resource allocation. The objective here is to minimize the interference of the CUE, DUE, and R2 with the V2V link based on the condition. So the reward function is here is to maximize the capacity of all of the communication links, CUE, DUD, and V2V link. And then this is the scenario of our simulation, and we, after we get the result, so we compare with the centralized Hungarian for the resource allocation and random selection scheme. And here we have 300 meter multiply 300 meter for the area, and resource block based on the bandwidth is 20 megahertz, and for the resource block is 100 resource blocks. And we use scenario with loss and non-loss scenario. In some capacity, depending of the number of V2V pairs, so here we need to guarantee capacity of CUE is 5 megabit per second. So based on this result, so after we increase the number of V2V pairs, so our proposed deep reinforcement learning can close to the centralized Hungarian, and also higher than random selection. And then depending of the number of D2D pairs, after we get more interference from D2D pairs, then the some capacity of the network still increasing with the number of D2D pairs, because of the add more users in the network, so we can increase the capacity of the network. So based on the result of our proposed deep reinforcement learning can get still close to the centralized Hungarian, and higher than random selection. Here we can see that our proposed deep reinforcement learning can get rewards close with the epochs in 1000, and after get the rewards, so we can close to the proposed deep reinforcement learning with 20 V2V pair in the network. And this is the conclusion of our work. We have proposed a decentralized display sponsored learning scheme for vehicular communication. And here we also single means that not multi-agent. We use only vehicle as agent to make spectrum distribution or resource block allocation. And based on the results, so our proposed deep brain functioning can get higher performance than random selection and can get close to centralized Hungarian with the requirement of the QS. And for the future work, we will consider multi-agent deep performance learning in complex environment, and we will use joint power and channel allocation, and for that we can improve capacity and reduce latency of the network. That's all of my presentation. Thank you for your attention.
Okay, thank you very much for your presentation. I think it is very interesting. And is there any question from the floor? Nope. Okay, from the Zoom, is there any question?
Uh, I have a questions regarding
Okay,
this.
please.
Okay, thank you very much. This presentation is interesting. I have a questions regarding do we need like what is the prerequisites for this system to be working properly? I mean, we have cellular infrastructure there, we have vehicle to vehicle and device to device. Apparent to me that if we have cellular infrastructure, then why do we have to have V2V? That's the first thing. And the second one is if cellular infrastructure doesn't exist, means that the system cannot work because it needs some, powerful infrastructure to compute this artificial neural network approach, right? Can you give us some explanation regarding this matter? Thank you.
Thank you very much for your question. At the first, if we in this scenario, we still use cellular communication, because we start from the device to device communication. The benefit of the device to device communication is means that we can improve spectral efficiency, so we don't need base station in the network. So for this phase, so we still need cellular network for for seeing the environment of the network. So it means we need the channel gain or the GSI or channel condition in the network. But in the future, in the decentralized communication, so we don't need base station in the network. Just we need sensing, and also you can integrate with the sensing. Also, we integrate the the technology of device to device to communicate between the vehicles. So in the future, I think we don't need infrastructure like base station in the network. So we just need device between us to communicate each other, and also we can extend it by using mesh network. So it can, it can sorry, it can reduce the load of the base station.
So you think that the computations for resource management, like radio resource, can be distributed over devices or vehicles in the field? Because to compute this, it really needs a heavy computational power, right? Resource. So do you think it's possible or feasible to do that in a distributed manner if we don't need base stations?
But in currently our hardware in devices maybe still not support this one. But in the future, I think with this technology, so we can improve the technology of hardware, so we can compute this technology. Like we can use as cloud computing or like mobile edge computing, so we can use as the central communication can be distributed in the system. But yeah, maybe in current condition our hardware doesn't support for this technology, but in the future I think the current hardware can support it. I hope
So the cellular must exist for this system right now.
Yeah, right now I think it's still not supported because of the hardware limitation, but in the future I hope it can be useful for the communication, for the V2V communication.
Thank you.
You are welcome.
Okay, thank you, Mr. Zerandi, for the question. And is there any question from the floor? Okay, Mr. Galih.
Thank you for the opportunity, Pak Budi, and also Pak Toto. I would like to asking a question to you. This is regarding the fact that deep reinforcement learning need more computing resource than, let's say, just reinforcement learning. But why you choose deep reinforcement learning over reinforcement learning? And also, have you compare the performance, I mean, the result that from the optimization based on DRL and RL? In several cases, right, there are trade-off. It depends what parameter that we want to optimize. When we want to optimize the throughput, there will be trade-off for the latency, let's say, and packet delivery ratio. And so have you considered this as well in your research? Thank you.
Okay, Mr. Toha.
Okay. Okay, thank you for the question. So, for this time, I just directly calculate the professional learning, and we don't consider reinforcement learning, because in reinforcement learning, based on some reference, so we need to move to the deep reinforcement learning because of we need some iteration on neural network for consider like interference, so for like channel condition and something like that. So there are some parameters that we consider in the network. And for the latency, because in this research we just focus on the problem is just to maximize the capacity. So in this condition, like this part, so we don't consider latency. But in the future, because reinforcement learning means that we can learn based on the environment. So I think latency is also important for the future, because now the condition for the network, like machine learning, for the future is AI is focused on the reinforcement learning, because of we learn every time with based on the environment, day by day or the time by time. So it means it's like it cannot be, yeah, we still need the environment, but yeah, in the future we can use a latency for the calculation for the learning. Okay, I
Thank
think
you,
that's
Mr. Toha, for the answer. I think it is the answer is clear. Okay. Okay. Thank you, Mr. Toha, for the good presentation and good discussion. So next
Thank
we
you.
move on to fourth presenters, Mr. Zirandi from National Research and Innovation Agency, Indonesia. Okay. So let's start.
In multi-hop LoRa network. So why? Because LoRaWAN has limited range and topology. So for some applications, typical range provided by LoRa may not be sufficient. Although LoRaWAN specification standard has issued the document for relay capability, it still emphasis on linked layers. So its implementation or more complex topology will be more challenging. And the last one, LoRa has low transmission rate, so its time on air for small size of message will be high. However, still suitable for delay tolerant network whereby its traffic is not intense. So this picture shows our general architecture of the network where our approach will be implemented into. So we have two network segments here. The first is multi-hop capable LoRa network and the LoRaWAN network segment in the lower part. So we will focus on the upper part, the multi-hop capable LoRa network, and the direction of traffic flow from the sensor will be toward LoRaWAN network through the nodes called as LoRa gateway node. What are the objectives? So we would like to enhance capability of LoRa-based network to have multi-hop capability so that it's gonna be useful when no LOS present due to obstacles. And of course, we would like to extend coverage of LoRaWAN service. To do so, we need to couple that with routing protocols so that it can operate in more complex topology. What are the challenges? Network latency may become excessively high, and for certain applications, it might not be acceptable. So we need to aware of that. The medium access conditions likely become more intense and making the latency even worse. Our routing protocol is based on broadcast fashion, so we don't have routing table maintained. And remember that the copies of the same message will spread within the network, so it mimics the epidemic routing. If we are not controlling it, it will flood the network. However, it has some advantages. It provides us redundancy to cope with unreliable link. And then the message from the sensor network flows toward the LoRa gateway node. So we make use this such that it provides us opportunity to confine the area of message spread. So we call that spatially confined. And each node has a metric that implies its distance or radius from LoRa gateway. It could be expressed in raw value, quantized, or the least number of hops. So our spatial confined broadcast basically rely on the information carried on the message. It consists of frame ID, list of relay nodes V, and the message distance. Its node has predefined parameters such as node ID, distance or radius of node I from the gateway, called as d sub I, and backward step small d. So message distance basically the node's distance in which the message is being processed for forwarding, and its value will be updated prior to relaying. In simple words, we can explain that our scheme that the message will not be qualified to forward if the receiving node distance is greater than the message distance plus backward steps. So this figure and animations illustrate how our special confined broadcast works. So we assume that node 3 becomes the sensor node and node 6 will be the gateway node. So it starts sending the transmission. In the process, 1 is not qualified to forward the message. 2, 4, and 5 receive the message because they are qualified. And then we assume that 4 is next to forward the message, received by 7, 2, 3, and 5. However, 7 is not qualified. 2 is actually not qualified, but it's already qualified from the previous message, so it's still qualified to forward the message from 3. And then 2 relay the message that has come from node 3. However, the neighbor nodes that received that message rejects that because it's already in the cache. And then finally, node 5. So what kind of improvement we make in our work in this opportunity? So last work used pure aloha for channel access, which means has a high probability of medium access contention. So we use local slot aloha with the synchronous time within sender's ready coverage, and we develop sender web forwarding, which the objective will be to reduce the number of forwarding node by examining the former origin of the message through the list of relay node V in the message. So this scheme relies on the relay node list V in a message, learn from that, and then determine the two parameters B and B bar, and then decide whether it's gonna be relay that message or not. So we're not getting into detail these slides. So this animations illustrates how our sender aware forwarding works in a local slot area, assuming that node VI now sending its message, forwarding the message to J, L, and K. At that moment, J, K, and L received the message from I simultaneously. They started the beginning of time slots synchronously. At this moment, J, K, and L is eligible to forward that. However, our sender aware forwarding will prevent that at following case. For example, J forward that message to K and L, and then followed by node L, broadcast the message and received by J and K as well. At this moment, node K receives the message from J and L and learns from the message that that message is coming from node VI where the node K is also receiving. So at this point, it will compute what is its probability to send. In this case, we have a function called that rho, a function of B, and it should be decreasing as the B increase. And handshaking mechanism is straightforward. It basically traces back the not released in V in a message, so it's not going to be broadcast anymore. And this is our experiment parameters. We use 8 devices. For Aurora V3 boards and LilyGo beam, they are ESP332 based development board, and we develop firmware using multi-thread paradigm and LoRa parameters. We use spreading factor 8 and code rate 4/5. The message length will be 100 bytes with 30 bytes overhead. By using 1.1 factor, we have time on air about 366 milliseconds. It's going to be one-time slot durations for our slot Aloha. For routing parameters, so we have backward step 1, function is 0.5 to the power of B, and the time slot will be U times time on air, where U is somewhere between 1 to K, where K will be randomly picked using uniformly distributed, and the K will consider the network degree. So these are two network topology that we use for experiments. The net 1 has 3.75 network degree, and net 2 has 475 network degree. So we pick K equals to 9 for uplink and 4 for a downlink. So the testing is conducted indoor. The link among devices is firmware emulated. The result, so we measure the packet delivery rate under varying sensor sending interval. So basically, delivery rate perform above 90%. However, net 1 performs slightly better than net 2, which has higher network degree. The result for delivery rate is getting more stable at 10 seconds. So we think that this is because of higher channel contention in net 2, especially in indoor setting. So then we measure the latency in terms of round trip time. So as we can see here, although the 5 sending interval has the lowest latency, but the PDR is bad. So we don't consider a 5-second interval. The result shows that net 1 has higher average number of hops, and while net 2 about 3 hops, means it results in net 2 has better latency than net 1. And round trip time is getting more stable at 10 seconds. Our analytic calculations reveals that the total latency in average is about 8.2 seconds. And then we try to measure our packet delivery rate under varying failure rate of nodes. So sending interval will be fixed in 20 seconds, every 20 seconds. Failure is firmware emulated. It's uniform distribution. Generally, the delivery rate decrease occurs worse for uplink and downlink for both network. However, net 2 is more resilient to link failure than net 1. At 25% link failure, net 2 still retain about 85% packet delivery rate. So, and then we measure its latency in case of failure. Still in round trip time for successful uplink and downlink, RTT for both network don't change substantially up to 25% failure rate. However, in practice, I don't think that the network failure will exceed 10%. So the conclusion is our development of multi-hop capability in LoRa-based network should be coupled with proper routing algorithm to exploit its advantage. The performance of our spatially confined broadcast routing can achieve a expected level of reliability and latency for non-time critical application practice. And then we think that our local slot Aloha and sender-aware forwarding can alleviate the channel contention problem, but it's still not effective because still inherently random access, so we need to find another mechanism. And the last one is to obtain more comprehensive and valid result. Further tests with various scenarios should be helped, particularly with different channel access mechanism and time slot durations. So in this opportunity, I would like to express our appreciation and acknowledgement to Rumah Program Badan Riset, Inovasi Terintegrasi IoT, Research Organization of Electronics and Informatics, National Agency for Research and Innovations. Thank you very much, and questions are welcome.
Okay, thank you very much, Mr. Mr. Zerandi for the good presentation. I think it is very interesting. From the floor, is there any question? Nope. And from Zoom, is there any question? Nope. Also, so
Actually, I have a question, if I may.
oh, yes, please, Mr. Toto.
So it's really interesting research, and honestly, I'm not really familiar with the research, but correct me if I'm wrong. So your what you call it, routing algorithm need need to calculate the distance between the node, right? And you calculate it by using time difference, if I'm not mistaken. So does time synchronization is very important here, or maybe we don't need time synchronization because it's a really small node, really small number of node. And second question is, how much payload that your system can accommodate? I think that's all.
Okay. Okay, thank you very much for the question. So the first question about the time synchronizations. So if you are asking about the synchronizations for our time slot in our local slot Aloha, so there's no like explicit mechanism to synchronize the time, because whenever a node receives the message from the sender, so every neighboring node will receive the same message at the same time. So we can safely assume that all nodes receiving that nodes within the sender's coverage will be synchronized as well. So they start the timing synchronously. That's the first question. If you ask about the time synchronization for our measurement, that's going to be the different challenge, right? If it's like one way latency, means that from the sender to the receiver would like to synchronize the time. Yes, that's difficult because we need to synchronize that. However, we make a little bit, I don't want to say that a trick, but we can make some, we call that approach by measuring the round trip time. Okay. So of course, basically, when you do the uplink where the broadcast portion is done, is taking slower than the feedback or the handshaking mechanism. But if we do care about the round trip time, all you care is how long that your packet will be acknowledged. You don't care about how long does it take from origin to the destination and back to the and back to the sender again. So you just care about how long does it take in overall. As a matter of fact, sometimes the applications just need need to know how long the packet will be acknowledged. They don't care about how long the packet will take from the sender to the destinations. That's the second. I think you have the second questions.
You mentioned that in your presentation that you use 100 bytes payload.
Okay. So the LoRa actually has limitations. What the maximum length of packet for spreading factor chosen for that configuration. So 100 bytes here is example. I don't remember how the maximum length of the packet to be accommodated by the LoRa transmission system. However, if you take the packet too long, means that you have time on air will be large, right? Means that you will need a longer time slot. Means that your latency will be take longer as well. I think that I can answer the question. So you have to be aware in this context.
Okay, thank you.
Okay, thank you very much for Mr. Toto for the question and Mr. Zerandi for the answer. From the Zoom, Muhammad Iqbal raised the hand. Maybe is there any question? Muhammad Iqbal? Yes, please.
Okay. Actually, I have two questions for Mr. Serandi. The first one is, do you mind if I mean, how the Aloha and state-aware forwarding algorithms work? How do you mind to explain that first? And then second, what kind of do you say that state-aware forwarding I mean, it doesn't solve your problems. So, do you mind to like explaining how control, what kind of control mechanisms that the state forwarding do if they know there's congestions in your LoRa network? So, like, they know if there's any congestions, what do they do? And what do they do if they didn't know about the congestions or the conditions of your LoRa network? So I think that's my two questions. The first question is like how the state forwarding algorithm works and what kind of controls that they do if they know if there's any congestions in your LoRa network. So I
Okay.
think that's all.
First of all, I would like to clarify it's not state aware, it's sender aware. So it's different. So it means that actually the LoRa nodes doesn't know what the congestion is in terms of at link layer level. So I think in the in the future, if we would like to develop or establish a mechanism to infer the congestion is, it should be looked at a higher level. So for example, because I built the handshaking mechanism, so means that if the sensor sending the message in doesn't get the acknowledgement from the let's say application at the destination, means that it can infer, okay, there's something wrong with this because we don't get, I don't get the acknowledgement. Then it can do like retransmission, something like that. Because this kind of system, broadcast patients, is suitable for low intensity network. Remember, low intensity network. So such mechanism is possible and feasible. Because not everyone will transmit in the same, in the same time in the very large size of packets. So we expect that from that the contention will be low, and then if there's a contention, it still can have chance to do the retransmissions. So it means that there's no mechanism for any nodes in the network to infer whether there's a congestion or not in the link-to-link level. So we have to do that on the end-to-end layer. So is it answering your questions?
Oh, yeah. Thanks. Yeah, thanks for your answers, Mr. Sandy.
Yeah, so because LoRa is basically used for delay tolerant network, and the size of the packet is practically small. So it means that if you have applications with hundreds of kilobytes of messages, and then it needs to be transmitted in the under like 10 milliseconds, then LoRa is not your choice. It's something like that. Okay.
Okay, thank you, Mr. Zerandi, for the answer, and Mr. Muhammad Iqbal for the question. I think it is very interesting discussion. Okay, that concludes our session. So on behalf of the organizing committee, I would like to thank all of the presenters for their excellent talks and all participants for your attention and question. Thanks you once again, and please enjoy the rest of the conference.
Thank you, Dr. Budiman, for having brought the parallel session 4. And since we have still some time left for the next sessions, and also we still have another parallel sessions still running in the Kenanti room 2. So I'd like to ask you to wait for the next patron talk, and we will wait for the other on-site audience to coming over to this room. Thank you.
Over 100 years ago, the discovery of radio waves marked the start of a new era. At that time, our founders Lothar Rode and Hermann Schwarz were still at school. They were immediately fascinated by this new technology and driven by a curiosity about the unprecedented possibilities it offered. A pioneering scientific spirit and entrepreneurial courage have always been the foundation for the success of Rode and Schwarz. Making ideas real and striving for excellence. The spirit and mindset of our founders live on today and continue to evolve from one generation to the next. Every day, thousands of employees worldwide benefit from the knowledge that is accumulated in our company over decades. At Rode and Schwarz, they learn from each other, showing respect for that which came before them. We're part of this world and pass on our knowledge by providing the best possible solutions and systems. We've never made a secret of our innovation culture. At Rode and Schwarz, excellent development performance and entrepreneurial behavior go hand in hand. We make a difference. Driven by our distinctive passion for technology, we create the innovations that are highly relevant for a safer and connected world. Our customers and partners know they can always rely on us to deliver the highest quality. We are strongly positioned and look forward to a successful future. Our mission is clear: make ideas real. Yesterday, today, and tomorrow.
engineering from Mie University, Japan, and his area of specialization are reconfigurable antennas, microwave millimeter, wave, and terahertz devices, radio frequency engineering, and nonlinear photonics. Let us welcome Mr. Taufan Pega and Dr. Ken Paramayuda.
Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. So, welcome to this pattern session of the ICRAMET conference. And my name is Ken Paramayuda. I'm from Research Center for Telecommunications. And today, I'm pleased to serve you as a moderator for this pattern session. And this session is proudly sponsored by the Rohde and Schwarz, a global leader in test and measurement solutions. And in this session, we are honored to have
the requirement for the project or etc. You can send email to me. Thank you. So today I would like to share with you our new product ZNB 3000. This is our new fan A, and if you check in the website, you can see the ZNB 3000 is our new mid lineup, because we have the low lineup, and also we have the mid-range VNA, and
Recording
also
in
we have
progress.
the high-end VNA. Next, please. Oh, sorry. Oh, yeah. Sorry. Bisa ya? Coba. Sorry. Okay. This is if you can see just now you see the video. You can see we this year we are celebrating 75 years of our VNA solution, because we start VNA a journey start from 1950. We start from the very basic VNA with the analog system, and continue develop our VNA until today. Please check from the picture. You can see we have a long commitment, long journey for VNA solution, and until this year, until today, we are proudly to present our new ZNB 3000. This is the product lineup. Yeah, we start from 1915 until today, and we still continue to develop the latest product to fulfill your expectation regarding the antenna testing or maybe regarding the radar testing and etc. So this is our 75 years for this year, and as you can see also from the picture, maybe you already know the Roda and Fast product because we not only have the VNA, but also we have a lot of test and measurement in our division. For example, we have a spectrum analyzer, we have also the signal generator, and also we have the VNA like this one, and also we have oscilloscope and many more. So because we have a lot of TM division, and but today I only focusing in the VNA first because I think VNA is relevant to your research, yeah, because we talk about ICRAMET, we talk about the radar and antenna and microwave solution. You can see from the picture we have a lot of product lineup, yeah, for the VNA itself. We start from the very low product lineup. We have the solution with the portable VNA, and also we start from the very low frequency range. For example, we can support until 3 or 4 gigs, yeah, for the economy for the portable one, and also we have the mid range solution, and also you will check more for the with ZNB 3000 for the mid range solution. And also we have the high-end solution with the name ZNA, VNA ZNA, and we can support your research until terahertz because now we have the solution for terahertz, not only 100, 200, 300, but we have solution until 1,100 gigs, or we can name it as a terahertz. So terahertz, basically we are using the basic unit for example VNA itself, but also we can extend the frequency range using the mixer, or we using the multiplier. So if you want to check more detail, we have the solution regarding the mixer to achieve your frequency target. Okay. And this is for example for the converter, yeah, converter. For example, if you have a resource or you have a plan to test maybe antenna system, or maybe you have something to test and you need to fulfill the frequency range until maybe 500 gigs, 300 gigs, or maybe 1,000 gigs, we can support you because we have the solution using our, for example, VNA solution, and including with the accessories, we can name it as accessories. We can achieve your frequency target. Okay, now what is the challenge for the VNA application? Because now the challenge need more increase more throughput rate. We need more faster. We need more faster using VNA solution. And also, if we talk about the throughput or the testing time, we can improve our we can reduce our test costs because we can more efficient, more precise to using our test solution. And also, if we talk about the efficiency, we can talk about the value for money because using our ZNB 3000, because ZNB itself is a mid-range VNA, but you can get more application using the mid-range solution. Okay, this is the overview of the VNA ZNB 3000. We have the improvement, yeah, we can say improvement to for example speed, yeah, to increase the testing time, and also with the new hardware configuration we can achieve the high stability, and of course we can improve our RF performance testing. And the good news is using the ZNB 3000, we can have a flexible upgrade concept. For example, if you buy the ZNB 3000 with the frequency range, for example, 20 gigs, yeah, and then in the future you want to upgrade to 26.5, so you don't need to send the ZNB to factory. So you can do in the local office. So this is the one of the new solution for the ZNB 3000, because usually if you want to upgrade the VNA, you need to send to the factory, and then you need to pay the shipping cost, you need to pay the more money. But now with the new function, you only this upgrade can be done in the local office in Rodeswas, Jakarta. So this is one of the new solution. And also the new solution for the ZNB 3000 is we have excellent dynamic range. Now we have up to 150 dB. So 150 dB, this one is to achieve your low noise testing. And because usually in the market, the VNA itself only achieve 120, 130, but now we can get more lower until 150 dB. So this is also one of the new solution for ZNB. And also ZNB itself have the extremely extreme high measurement speed. So this speed regarding the high throughput rate, because now the ZNB can achieve until 11.8 millisecond per trace. Sorry, per point, because in the ZNB we can achieve until 100 and 1,600 points for one single measurement, and we can achieve the speed more faster compared with the previous model. So this is also one of the key point from the ZNB 3000. Okay, let me continue. This is the overview for the frequency range. Please check from the picture. You can see we have a lot of model, a lot of choice for your ZNB. We start from the very low frequency. We start from 9 kilohertz until 4.5 gigs, and now with the ZNB you can get until 54 gigs in the one single box. So this is interesting because usually to achieve frequency more than 50, you need more expensive VNA. You need the high-end VNA. But now using the mid-range, you can achieve until 54 gigs. So you can have a value for money for this VNA solution. And this is the four pillars regarding the new solution with the ZNB 3000. Why I talk about the new improvement speed, new high speed, everything? So because we have a new hardware solution. For example, we have a new synthesizer module inside the ZNB 3000 to improve the testing time. This is also the new solution we install in the ZNB 3000, and also we have more dynamic range to improve your testing, your test, because with the high dynamic range you can check more lower your testing. And also, if you can check from the picture in the picture, you can see the port. Now we are using the new technology for the test port, using the port 2PCB technology. Because usually if we talk about the maintenance, we talk about the repair, usually we got the report from customer. Usually the port is broken. Maybe sometime user try to input the cables, and then not match, yeah, not well matched, and then the connector is broken. And this is a very bad news, because we need to send to repair, send to calibration to factory, and we need to change all the module in the RF input. But now with the ZNB 3000, we have solution. If you have a port broken, you only need to change the port itself. So you no need to change in the one single RF input module. So this is also to reduce your maintenance costs. And this is the summary for three pillars we have in the ZMB 3000. We call it as a 3S. So one is a speed, because we have a new hardware solution inside the ZNB to improve the measurement speed. And also we have the stability. The stability itself, we can say we have more. We have more new hardware with the more stability, because we can check one by one from the speed. The speed disease itself, we can improve with the using the new synthesizer module to achieve the test speed, and also using the new hardware for inside the ZNB, we can improve the stability, because if we check for example, if we check for the stability, sometimes if you using your VNA in the laboratorium, there is some how to say, there is some temperature different. Let's say from lab A to lab B and lab C, you have a different condition in the every single lab. And if we talk about the temperature, this is a very critical, because sometimes your VNA is not accurate, not accurate if you try to measure something in your lab, but if you have a not good temperature, and this is also one parameter you need to check. But now with the ZMB 3000, we have more stability, because we have a new hardware inside, and we can achieve, for example, we can achieve for 20 hours continue testing, we can achieve very high stability. If you can check from the picture, there is no big difference between every single marker here compared to every single trace here. So this is can we can say with this new model we can improve the stability more better. Okay. And the last one, scalability. In the beginning, I say ZMB have flexibility, because if you buy the frequency range from 20 and then you need to upgrade to 26, so you don't need to send to the factory. So this is also a good point from the ZNB to reduce your maintenance costs. Okay. Okay, next for the user interface itself, we have a big screen, big screen, 12.1 touch screens dimension, and with this big screen, you are easy to check the parameter more better, because you can improve your vision, you can improve your display, because you not only one display, but you also can share the display. For example, you can share for 1, 2, 3, 4, 5. So you can using in the one single display, but you can measure 5 parameter in the same time, because we have a big screen and also we have the touch screen So this is more interactive. You can try your test measurement in the ZNB 3000. And if you check from the behind also we have a customized module in the behind. For example, we have a new solution regarding the hard disk, because usually hard disk is installed in the inside of the VNA, yeah. And this is problem if you need to repair the hard disk, or maybe you have a top secret research, and you want to secure the test result, you need to remove your hard disk. Because if let's say if your VNA is missing, but you can still protect your hard disk, because with this solution, this is a removable hard disk, so you can you can open your hard disk in the emergency situation to protect your resource. Let's say you have a fire in the building, yeah. So and then you can secure your data inside in the hard disk, you just remove the portable hard disk in here. This is also a new solution with in the ZNB 3000. Okay, let me continue. For regarding the operating system, also we are using the new Windows 11, and this is also together with the memory 16 gigabyte memory to achieve your high performance. Because if you have a small memory inside the VNA, maybe you can feel lagging, or maybe some delay in the processing. But with this new feature, you can achieve best performance using our VNA. And also we have solution for the license, because basically if I offer to my customer, basically I just offer the basic unit, because some of the application is not free. You need to buy one by one. For example, maybe you need the option number A, option B, option C is not free, and you need to buy permanently. But now we have solution with the flexible license. Maybe you only buy 3 months, 6 months, following your research purpose. So you can saving your money, because you only need maybe temporary 6 months, or maybe only 1 year. Compare if you buy permanent for every time. So this is also the new solution with the flexible license. So you can buy only if you need in your research. So this is also more economy if you buy compared to permanent license. Okay, and also let me continue. So also this is also a new feature. Because basically all of our instrument, we have the comment, it's the open source. Yeah, you can check in the manual book, or maybe you can check in the website. We are using the open source with the Skippy comment. Yeah, so Skippy comment, this is very helpful if you want to make your own software to controlling the VNA. Also you can just modify your programming. Yeah, for example, you are using the Python and C++, and you can try to make a simple comment to controlling the VNA. And also in the VNA also in itself, they have the recorder, because every time you using the VNA, and then every single test application is already recorded in the hard disk. So after you are finished, you can download it in the USB, and then you can try to play in your software. This is also a new solution with the VNA. And this is the hardware feature of new option. Maybe I not talk all. Yeah, maybe only I will take a sample. For maybe number one, we can say for we can talk about the power range. Now with the ZNB 3000, we can improve the power. Yeah. Usually we can only support until 10 dBm, 13 dBm, but we can improve the power output until 12 and more. So this is also one optional. And regarding the dynamic range, also we can achieve the 150 dB to achieve your very low signal level to see the low noise or the phase noise in the very low signal. And also ZNB 3000 also using the precision frequency reference. We call it an OXO. OXO is a hardware optional. So after you choose this hardware, we can install in your ZNB and make sure your ZNB is more accurate. Because if you talk about the accuracy with the edging, all the instrument is have the edging, because usually we need to do a calibration for every 1 year. And with the new TIS solution, we can extend the edging more better. So this is also a new solution with the ZNB 3000. And regarding the test application, we have a time domain solution for like this one, and we can see the correlation between the impedance in the timeline. This is also new function, and also we can extend the time domain solution to achieve the eye diagram. So this is also for example, for the eye diagram, we can do in the ZNB 3000. And also the distance fault measurement also can in the ZNB 3000. And this is also the solution, because now in the ZNB 3000, we can generate two signal as intermodulation. For example, we have 4 port VNA. Port number 1 is a reference signal. Port number 2 is the second signal to combine together with the port number 1, and then we can send the signal to the DUT. So we can have two signal combined together and then send to the DUT, and then we can check the output with the port number 3. So this is also a new solution for the intermodulation testing. Okay, let me continue. Also, we have improved with the resolution. Now we can achieve 1 millihertz for resolution. So we can improve the frequency range. Is a more better, yeah, because we can increase the solution every 1 millihertz. And also, let me continue for the application. This one, yeah, this one also we can support, yeah, because basically the ZNB only support 4 port, but we can extend the port until 86 port with the multi port. We are using the extension port like this one. And then we can combine together to achieve more bigger for the output. For example, we can achieve until 43 and until 86 the test port. And for the calibration also, we have a solution with the automatic calibration. We can using the classical manual calibration also. And this is the example, the sample test for calibration. And this one also, if we are using the multi-port VNA, and we can use these accessories to calibrate all the port like this one. So for example, we have maybe, for example, 12 port, and we need this multi-port calibration to handle all the calibration process in here. And this is the sample. Okay, let me continue first. Okay, and this is the data set for the calibration unit. We can support start from 4 gigs until 67 gigs. And also, if we talk about the more higher frequency, we have also a solution with the waveguide solution. So this is also a solution to achieve more higher frequency. For example, 100 gigs, 200 gigs, and also we can support until terahertz, 1000 gigs. This is the example for the converter, and this converter also we need to calibrate, because we have also the calibration kit to calibrate the waveguide. And also this is solution to testing the material dielectric testing. We have a partner from SPEAC from Swiss, and also we have partner from Swiss 212 to test your material characteristic. Yeah, for example, you can test for the permeability and permeativity parameter using our VNA, and also using our third party solution like this one. And this is the cable solution. You can also add your cable from us. And also we have the accessories, for example, torque wrench, and we also have a small one and the big one. Okay, this is the last the last slide from me. Maybe I will let you know if you have a question. Please let me know. Thank you. Thank you.
Thank you very much for the excellent presentation about the new VNA from the Rohde and Schwarz. So we are opening a question from the audience. If you have question, please raise your hand. Also, we are opening question from the Zoom online. If you have question. So Rohde and Schwarz have a door prize. It says so. If you have question, please raise your hand. Yeah. Please.
I think we have in the booth. If you also interested with the VNA, you can check in our booth, and also we have the brochure and catalog also. I will share with you. Thank you.
The next one, do you have question? So if no, maybe I will ask a question regarding the stability of the vector network analyzer of your product. So yeah, from my experience, I think we have to, based on my experience, when I measure something, the temperature or the environment of the measurement more or less affecting the performance of the measurement tools. So we are usually after start up the measurement tools, we are usually warm up the measurement tools like about 30 minutes or something. How about this new VNA? Do it needs warm up before we do a real measurement, or it can be start from after we turn on the measurement tools and then we can start the measurement? Thank you.
Thank you for your question. So basically we have the procedure to achieve the high accuracy, because also still the same. ZNB3000 also need the warming up time to achieve your best performance. But if I can say is depends with the test target. If you want only a test daily test, I mean you can try to make some priority. Priority if you just checking only daily testing, not to care about the accuracy, and not to care about the 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 best one. You can try, because the difference is not so big. Maybe the difference maybe only 0.000 something. So I think still you can still after you switch on the VNA, you can use it. But yeah, depends your target. If you just do simple testing is also can, but if you want to get more accuracy, more better performance, I think my recommendation still you need warming up time at least 15 minutes to achieve your best performance. And regarding the temperature is we have the recommendation to keep your laboratory between 21 until 26. This is the best one, because if you follow from the calibration report, yeah, because after you buy the instrument and after you send to calibration, you will get the report from the factory, and you can see in the factory report always say 21 until 26 degree. So my recommendation, you need to keep your lab between 21 and 26, because sometimes for the high end products, high end product have a sensitivity with the temperature. Yeah, if you using if you try to use in your lab with the 27 degree, and then you move your instrument to the next lab with the different temperature, the result may be not the same. So you need to consider the temperature is in the one condition for the temperature. This is the recommendation from the factory, I think. I hope I can answer. Thank you.
Thank you very much for the insightful answer. So we are opening another question, please.
Yeah, thank you for the presentation. This is Marin. I'm from Research Center for Electronics. I have two quick questions. The first one, can this device connected to the internet so we can control in the remote space? That is the first one. And then the second one, considering the calibrations, some company, in the case when the device has some problems, the calibration or the service fixing the device, it takes a lot of time. Takes 2 months sometimes, because they need to bring this device in the broad countries. So how about this device? Is it possible less than 1 month, maybe 2 weeks, 3 weeks? Because we have, running the experiment continuously. I think that's all. Thank you.
Thank you, Pak, for your question. I try to answering your question one by one. Start from number one question. Yeah, we talk about the remote. Yeah, the remote or how to control the instrument using the internet solution. So I can say yes, you can do it because our instrument basically you can make a remote connection using the LAN cable, and then you only need to open via a browser. So if you have browser in your laptop, you can input the IP address, and then you just input, and then you just push the enter button, and then you can see the home display. But you need also to input the password, because you can check the password in the manual book. This is one condition. The second one, sometimes also our instrument you know the remote desktop connection in the Windows. You can so my solution, you can try using the browser application, or maybe you can also using the remote desktop connection in from the Windows also. You can try. And also you need to input your IP address, because you need to configure your IP address first, and then you can access from your laptop. And if your laptop have internet connection, and and also my recommendation, you need to install for example, you can install the team viewer. Yeah, you can install your third party software, for example team viewer, or maybe something else, and then you can control from here to different city also can, as long as you have the same team viewer software, and you have the internet connection is possible. Because I also many time use this solution. For example, I can control my device from Germany, or I can control my device from Singapore, also can. So this is number one. Number two, regarding the repair, yeah, repair, and also for the calibration also. But unfortunately, until now, we don't have, we don't have the solution for the calibration, and also for the repair. But in my office, we have the workshop, and we have also the service engineer. So this is also maybe, if I can say, this is the big difference between Roda and Source compared to the competitor, because we are from Germany and we are official office. We are not agency, we are not distributor. So that's why we have after sales support also. So not only selling, yeah, not only selling, but also we can support for the after sales support, for the program, training program, certification, and we can support. And regarding the repair, we can support until level 1 and level 2 we can support, as long as no need the calibration. For example, only small issue, yeah, maybe for the hard disk replacement, display replacement, the keypad replacement, we can repair in the Jakarta. But if we need to repair the RF module, so this is not possible, because RF module, after we replace the module, we need to send to the calibration. So until now, we forward the calibration or the repair to Singapore and to Germany. So for the repair time, the best delivery time is a 1 month, because for repair itself is not too long, maybe only 1 week, but maybe we cannot controlling the shipment, because usually in the shipment there is some long queue and maybe something else, so we cannot control. But I can say until now we still forward to Singapore, to Germany, but only for the special case, Pak. But for the small issue we can handle in the Jakarta. Okay, thank you, Pak, for your question, Pak. Thank you.
Thank you very much for the answer. So that concludes our presentation for today. So as a token of appreciation, we would like to present. Oh, okay. Okay, so here is the QR code for feedback. So if you have a feedback for Roda Experts, please scan this QR code and send your feedback to Roda Experts. Okay, and we are very thankful for the presentation, and we would like to present a token of appreciation for Mr. Taufan Pega. Please accept this token of appreciation. So on behalf, you have. Oh gitu. Okay, okay. Yeah. So on behalf of ICRAMET committee, we would like to say thank you once again, and please enjoy next session.
Mayuda for having moderated these patron sessions. And now we also have another token of appreciations, and I would like to invite Professor Yusuf Nurwijayanto, PhD, to come forward to handing out the token of appreciation. Thank you once again to Mr. Taufan Pega, and also thank you to Rohden Sports Indonesia for the support for ICRAMET 2025. And now we are going to have the afternoon break for 20 minutes. And I would like to remind you again to don't forget to visit our exhibition booth to the left of the corridor, so you won't miss out to the good equipments that may you need for your research as well. And we also have the refreshment at the corridor. So please enjoy them. So you can bring them to the exhibition booth while looking at what they have in store. And also, I would like to remind to you to fill in the attendance form if you haven't yet. So you only need to fill it once in a day, and you can find it on the wall. Maybe you can see to your right or to your left. And so, yeah, please enjoy the afternoon break.
Our product is called XDEC, which consists of hardware and software that we created in-house. We integrate our device with the semiconductor chip industry to help them reduce their cost for testing and get more reliable and also high yield of their product. The current problem in the semiconductor industry testing for the chip is because the current equipment is bulky, expensive, and also not integrated. Our solution provides technology that's 20 times smaller, 3 times cheaper, all integrated with easy-to-use software. Our device analyzing the reliability of the chip. This reduces the amount of defective chips and also puts out high yield in the manufacturing. It is important for the semiconductor chip manufacturing. So we have shipped our product to over 15 countries. Now also being used to different applications such as the AI, quantum, and also in data centers. NASA used for the space, the Army for defense, and the NVIDIA for the AI. For those companies, they use our equipment to be integrated with their chips to make it function properly in different applications. One of the best functions of our product is provide the voltage and current. Our equipment helps guide light so it can work properly into different applications. We are inspired to create more innovative devices so we can help people to have a better life around the world. This motivates our team every day.
Over 100 years ago, the discovery of radio waves marked the start of a new era. At that time, our founders Lothar Rode and Hermann Schwarz were still at school. They were immediately fascinated by this new technology and driven by a curiosity about the unprecedented possibilities it offered. Pioneering scientific spirit and entrepreneurial courage have always been the foundation for the success of Rode and Schwarz. Making ideas real and striving for excellence. The spirit and mindset of our founders live on today and continue to evolve from one generation to the next. Every day, thousands of employees worldwide benefit from the knowledge that is accumulated in our company over decades. At Rode and Schwarz, they learn from each other, showing respect for that which came before them. We're part of this world and pass on our knowledge by providing the best possible solutions and systems. We've never made a secret of our innovation culture. At Rode and Schwarz, excellent development performance and entrepreneurial behavior go hand in hand. We make a difference. Driven by our distinctive passion for technology, we create the innovations that are highly relevant for a safer and connected world. Our customers and partners know they can always rely on us to deliver the highest quality. We are strongly positioned and look forward to a successful future. Our mission is clear: make ideas real. Yesterday, today, and tomorrow.
Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Making accurate antenna measurements in large chambers and outdoor antenna test ranges, or making long-distance measurements such as testing long cable runs on aircrafts or ships, are not easy tasks. The traditional measurement solution uses a two-port benchtop vector network analyzer, a VNA, where the user must attach two very long test port cables. The problem with this solution is that long cables introduce signal loss, reducing dynamic range. To overcome this challenge, a high-end VNA is required, and components such as low-noise amplifiers are introduced to improve dynamic range. As the frequency of interest goes higher, however, small movements in the test port cables have an adverse effect on signal phase. Introducing the solution to long-distance S-parameter measurement problems, the Inritsu Shockline ME7869A. This modular two-port distributed VNA can make vector-corrected S-parameter measurements over distances as long as 100 meters. Complicated test setups and lossy cables are eliminated, since the instruments are powered by Inritsu's patented phase-link technology. This technology allows synchronization between the two VNA test ports using optical cables. No matter how much the user moves the cables, there's no phase deviation, while system dynamic range is fully preserved no matter the distance between test ports. Now you can confidently test long cable runs from aircraft's nose to tail and wingtip to wingtip, from ship's antennas to underdeck control rooms and antennas on outdoor test ranges, or in large anechoic chambers, all to full performance with a compact and easy-to-use solution. Inritsu, providing excellence in MM-wave measurements, covering the distance with our patented phase-link technology, integrated into the Shockline ME7869A modular vector network analyzer. Inritsu, advancing beyond.
Our product is called XDEC, which consists of hardware and software that we created in-house. We integrate our device with the semiconductor chip industry to help them reduce their cost for testing and get more reliable and also high yield of their product. The current problem in the semiconductor industry testing for the chip is because the current equipment is bulky, expensive, and also not integrated. Our solution provides technology that's 20 times smaller, 3 times cheaper, all integrated with easy-to-use software. Our device analyzing the reliability of the chip. This reduces the amount of defective chips and also puts out high yield in the manufacturing. It is important for the semiconductor chip manufacturing. So we have shipped our product to over 15 countries. Now also being used to different applications such as the AI, quantum, and also in data centers. NASA used for the space, the Army for defense, and the NVIDIA for the AI. For those companies, they use our equipment to be integrated with their chips to make it function properly in different applications. One of the best functions of our product is provide the voltage and current. Our equipment helps guide light so it can work properly into different applications. We are inspired to create more innovative devices so we can help people to have a better life around the world. This motivates our team every day.
Over 100 years ago, the discovery of radio waves marked the start of a new era. At that time, our founders Lothar Rode and Hermann Schwarz were still at school. They were immediately fascinated by this new technology and driven by a curiosity about the unprecedented possibilities it offered. Pioneering scientific spirit and entrepreneurial courage have always been the foundation for the success of Rode and Schwarz. Making ideas real and striving for excellence. The spirit and mindset of our founders live on today and continue to evolve from one generation to the next. Every day, thousands of employees worldwide benefit from the knowledge that is accumulated in our company over decades. At Rode and Schwarz, they learn from each other, showing respect for that which came before them. We're part of this world and pass on our knowledge by providing the best possible solutions and systems. We've never made a secret of our innovation culture. At Rode and Schwarz, excellent development performance and entrepreneurial behavior go hand in hand. We make a difference. Driven by our distinctive passion for technology, we create the innovations that are highly relevant for a safer and connected world. Our customers and partners know they can always rely on us to deliver the highest quality. We are strongly positioned and look forward to a successful future. Our mission is clear: make ideas real. Yesterday, today, and tomorrow.
Making accurate antenna measurements in large chambers and outdoor antenna test ranges, or making long-distance measurements such as testing long cable runs on aircrafts or ships are not easy tasks. The traditional measurement solution uses a two-port benchtop vector network analyzer, a VNA, where the user must attach two very long test port cables. The problem with this solution is that long cables introduce signal loss, reducing dynamic range. To overcome this challenge, a high-end VNA is required, and components such as low-noise amplifiers are introduced to improve dynamic range. As the frequency of interest goes higher, however, small movements in the test port cables have an adverse effect on signal phase. Introducing the solution to long-distance S-parameter measurement problems, the Inritsu Shockline ME7869A. This modular two-port distributed VNA can make vector-corrected S-parameter measurements over distances as long as 100 meters. Complicated test setups and lossy cables are eliminated, since the instruments are powered by Inritsu's patented phase-link technology. This technology allows synchronization between the two VNA test ports using optical cables. No matter how much the user moves the cables, there's no phase deviation, while system dynamic range is fully preserved no matter the distance between test ports. Now you can confidently test long cable runs from aircraft's nose to tail and wingtip to wingtip, from ship's antennas to underdeck control rooms and antennas on outdoor test ranges, or in large anechoic chambers, all to full performance with a compact and easy-to-use solution. Inritsu, providing excellence in wave measurements, covering the distance with our patented phase-link technology, integrated into the Shockline ME7869A modular vector network analyzer. Inritsu, advancing beyond.
Our product is called XDEC, which consists of hardware and software that we created in-house. We integrate our device with the semiconductor chip industry to help them reduce their cost for testing and get more reliable and also high yield of their product. The current problem in the semiconductor industry testing for the chip is because the current equipment is bulky, expensive, and also not integrated. Our solution provides technology that's 20 times smaller, 3 times cheaper, all integrated with easy-to-use software. Our device analyzing the reliability of the chip. This reduces the amount of defective chips and also puts out high yield in the manufacturing. It is important for the semiconductor chip manufacturers. So we have shipped our product to over 15 countries. Now also being used to different applications such as the AI, quantum, and also in data centers. NASA used for the space, the Army for defense, and the NVIDIA for the AI. For those companies, they use our equipment to be integrated with their chips to make it function properly in different applications. One of the best functions of our product is provide the voltage control. Our equipment helps guide light so it can work properly into different applications. We are inspired to create more innovative devices so we can help people to have a better life around the world. This motivates our team every day.
Over 100 years ago, the discovery of radio waves marked the start of a new era. At that time, our founders Lothar Rode and Hermann Schwarz were still at school. They were immediately fascinated by this new technology and driven by a curiosity about the unprecedented possibilities it offered. Pioneering scientific spirit and entrepreneurial courage have always been the foundation for the success of Rode and Schwarz. Making ideas real and striving for excellence. The spirit and mindset of our founders live on today and continue to evolve from one generation to the next. Every day, thousands of employees worldwide benefit from the knowledge that is accumulated in our company over decades. At Rode and Schwarz, they learn from each other, showing respect for that which came before them. We're part of this world and pass on our knowledge by providing the best possible solutions and systems. We've never made a secret of our innovation culture. At Rode and Schwarz, excellent development performance and entrepreneurial behavior go hand in hand. We make a difference. Driven by our distinctive passion for technology, we create the innovations that are highly relevant for a safer and connected world. Our customers and partners know they can always rely on us to deliver the highest quality. We are strongly positioned and look forward to a successful future. Our mission is clear: make ideas real. Yesterday, today, and tomorrow.
Is the specialist in vehicular ad hoc networks, or VANET, and intelligent transportation systems (ITS) with emphasis on software-defined networking, SDN integration for vehicular communications. His work addresses critical challenges including low latency, high throughput, reliability, dense VANET environments, security, and scalability in IEEE 802.11 and CV2X standards. And now, please welcome Mr. Adi Bramantyo and also Mr. Gali Nugraha Nurkafit.
Thank you, Dita. And hello, everyone, and good afternoon for all of you in this room and also in the Zoom meeting room. And thank you for attending this session. So this is Industrial Talk. And in this session, we have a practitioner that have long experience in the field of internet engineering, computer networking, data center, wireless communication, security, and now he is a country manager of Arista Network US. So please welcome Mr. Adi Bramantio.
Thank you, everyone. Good evening, and thank you for having me in this session.
Yes, thank you, Pak Adi. And I know Pak Adi since we was in ITB about 23 years ago, isn't it? Yes,
Long time.
2002. It's a long time ago. And yes, before Arista, you have experience in Palo Alto network, isn't it?
Yes.
Palo Alto and previously also Juniper network, Wandel, Ericsson, Nokia Siemens network, Packet System Indonesia, Jalawave, and of course AI3. Yes, this is the first of his career as the system administrator in ITB. So it more than 20 years, I believe. So long experience with this field. So Mr. Adi Bramantio received his bachelor degree and also master degree from the electrical engineering ITB. Now it's a part of Stay ITB. And also looking at the experience, most of your experience is in the multinational network tech company, isn't it? So today, Pak Adi Bramantio, Mr. Adi Bramantio will present about the AI infrastructure, artificial intelligence infrastructure. Is that correct?
Yes.
So most of you must be know and also have an experience using AI or at least LLM services like ChatGPT or something like that. But I believe there are not many of you who have experience with the back-end system of the AI services. So in this session, we will talking about that. The AI infrastructure, the system that support the AI service all the world. As you know, there are million people who use these services. This cannot be just supported by something not planned well with the capacity, with the high capacity and many features related to how to enhance the reliability of the system. So here it is. We will have about 35 minutes for the presentation. So the stage is yours, Pak Adi. Thank you.
Thank you, Pak Gali. Such interesting remarks. Okay. The in this session, I will talk about AI, but it's more on the infrastructure of the AI. Like Pak Gali mentioned, yeah, most of us has been using AI technologies, but what can what we know about the infrastructure behind the application itself, because it's a different things that the normal data center will do. And we also I also talk about what would be in the metrics of measuring the performance of the AI infrastructure, and what are the technologies behind driving the AI adoption uh, technology as well. As you know, AI is extremely resource intensive uh, servers. It can runs like machine learning on the sort of uh, smaller training, or it can be like a deep learning applications, and all of them requires high amount of data to be consumed. And of course, it requires the powerful server. We cannot use just a home server for the AI applications. However, for the applications that you run on top of AI applications, of course, that requires high amount of consumable resources like power, and then uh, uh, high bandwidth, and also in terms of the memory, it also require very big memory. And behind of that applications, there is a network interconnecting between the what we call it accelerators, or most of people knows as a GPU, graphical processor units. And when it ties together between all the accelerators, or GPU, or someone else mentioned it about TPU, yeah. It requires or it needs, or it behaves as fast as its slowest piece. So because all that accelerators, it needs to be talk to each other as in a full mesh fashion. So when there is a slowest link on the system, it will become the uh, standard performance of the system. This is the example of NVIDIA brand, yeah, NVIDIA brand. There is what they call it DGX or HGX. It's not a common server, but in terms of the component, it's similar to the normal server. However, as you can see, there is some what they call a GPU, or in the general words, it's called accelerators. In this case, there is eight GPU. There are 8 GPUs, and the GPUs talking to each other. So one system, it can be up to 8 GPUs, and there is also CPU as a brain of this system. And sometimes the GPU talk to CPU through the PCIe Express. So this is the mechanism of the AI applications for this example in NVIDIA. And not just NVIDIA, this is another latest development of NVIDIA. Maybe you've heard about GP200, GP300. In Indonesia, there are some international or coming from China, yeah, most of the cases. They implemented GPU cluster in Indonesia, and currently the system that they are using for the latest one is a GP200 on the middle rack. Yeah, there is a GP200. This GP200, it contains GPU. One GPU needs to be connected to 400 gig Ethernet or IB interfaces. Or in the right side on the middle picture, there is a GP300. This is 800 gig per GPU devices. And not just NVIDIA actually, but maybe you've heard more on NVIDIA about AI. But not just NVIDIA, there are also some other players in the industry for the accelerators or GPU. There is AMD. They have the MI250 for the example of the accelerators. It's also similar to what we've seen previously in NVIDIA. They have their own framework, yeah, their own framework to talk to each other of these GPU or accelerators. And of course, the other one is the Intel one. Intel, this is the latest of the Intel technology. It's also using their own GPU to be used for LLM or SLM. Yeah, and basically those accelerators, if if our applications only needs to run, or is only we want to run a small set of application, we can just use one single system or one single platform like in this picture. But if we need to run more bigger data sets, then we will need network to interconnect between the GPUs. So in terms of the stack, yeah, in terms of the stack, there are 5 stack of AI. Usually, what we've seen as a user is already the result of some AI training or AI inference. But behind of that, there are some workloads model like LLMs or SLM or DLRM that like for example the llama maybe around 3 petabyte of data required or trained, and some other mechanism from Google or from Oracle. They have their own LLM model. And the second layer is the software or framework for the software. It can be like APIs or some open source like PyTorch, TensorFlow from Google, or NVIDIA have their own NCCL and some other open source mechanism. So this is the software framework. And to run those framework, we need the accelerators. That's called GPU or TPU, depending where you get the accelerators from. And this GPU or CPU, it can be on-prem, meaning that you have the equipment in front of you or nearby your locations, and you can put your data sets there into the storage, and then run the inference or run the training on top of that data sets. Or it can be a cloud. Cloud meaning here is that some cloud provider, they build their own AI cluster. They build their own AI cluster so that user can use the data without owning the equipment. So there are those 2 types of implementations in AI. And of course, you will need also the storage to for your applications to be able to consume the AI data. And the last but not least, is the network to glue everything together between the GPUs or accelerators and also the storage. And networks is required when you want to connect more than 8 GPUs. Because usually, if less than 8 GPUs, then you don't need network interconnection. This is some example of machine learning and deep learning, but which basically for the machine learning, it's more simpler. Some input, you need to define the classification first to be able for your system to uh, analyze or to predict what would be the that input that you are asking. For example, there is a banana, orange, and apple. Then in the classification model, you need uh, to train or to put some classification that this is a banana, this is a orange, and this is an apple. Compared to deep learning, when deep learning, you don't need necessarily provide classification model, but you make your system able to see a lot of pictures about uh, banana, about orange, and about apple. Then the system will come out with the result of this is a banana, this is a apple, and this is a uh, orange. So this is the some of the uh, mechanism to that most of the people use for the AI. And some AI application like machine learning, deep learning, they have uh, different characteristic uh, compared to the standard data that processed by a data center. Like for example, we are opening a web page, or we are using our phone to open mobile applications such as internet banking. So the AI data center works differently, because like in the normal data center, uh, is the process is uh, it depends on what you are asking. Like for example, you are asking for you are querying your balance. You are querying your balance, then it will just show your balance. But in terms of the AI applications, there are a lot of process behind. Like for example, the banking industry use AI to be able to approve the credit limit rating of certain people. For example, some of the applications in the financial sector, we can apply for a certain credit, and behind of that applications, actually, there is an AI engine who runs all the background check of you, running your BI checking, running your previous credit, if any, running your historical transactions, running your everything that related to your transactions. But it's run in the behind, and then suddenly or finally you will get approved or reject based on your credit applications. So that the difference between AI workloads, where there is an input, it's all fully mass processed by all the GPUs. So all the GPUs is talk to each other. That's why because it's asking full mesh, the network of the AI needs to be carefully designed, yeah, compared to the standard processing in the data center. And in the AI network, like some of the characteristic, first is that the traffic flows. So flows means transactions in the AI data center. There is a time synchronization, meaning that when you run the inference or you run the training, it will put some timestamp. And if there is some failure on the network or failure on the job, it needs to know that checkpoint when it failed, so that it needs to rerun again. So, and it will make the result of inferencing or training becomes longer. That's why for the AI data center, uh, everything needs to be handled so that we want to reduce the failure of equipment. Yeah. And in the AI data center, the traffic flows is very big. Usually, it's only like one or two flows per NIC. NIC is the interface that uh, 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 in input and output of the server of the applications. Yeah, it's usually only around two flows, but it's consume a lot of bandwidth. We will see how much bandwidth later on. and and the traffic is very bursty, meaning that it will try to consume uh, all available resources in the network. And so like for example, when we are talking about utilization, normally in any kind of network, we can see some sort of sinusoidal uh, application, right? So that sometimes it's very high, sometimes very low, something like that. But in the AI, it will be directly more than 90% of the load of or utilization, because AI will try to pump all the traffic and use available any available resources. That means the slowest member of the GPU will determines the performance of one cluster. So that's the characteristic of AI workloads. And in terms of the connectivity, when we are talking about AI, it's very different with the normal connectivity that we have in the network in general. Like for example, we are connecting to the Wi-Fi. Usually we are talking about several megabit per second, or maybe if you are using Wi-Fi 6 or Wi-Fi 6E or Wi-Fi 7, it can go up to 1.5 Gbps. But when we are talking about AI, the minimum throughput for each GPU or accelerators is 200 gig per second per interface. So we are talking very high speed throughput from the AI data center. And now with the advance of GB300, it goes up to 800 gig, 800 Gbps for one accelerators. And fortunately, it's also the technology of the serializations is now able to cope with that high bandwidth. And there are two standards, 50 gig PAM4 and 100 gig PAM4. So if 50 gig PAM4 for 400 gig, it means lanes, 8 lanes. And for 100 gig PAM4, it means there is 4 lanes for 400 gig interface. And for the AI, because of uh, very consume how to say is very big in terms of the capex or to procure the device. Some service provider, they are using pre-terminated fiber or pre-terminated UTP cables, so that it will be much cheaper or more efficient and still able to reach 400 gig or 800 gig per single interfaces. This is some picture, yeah, to show the cluster of AI looks like. So in the middle, there is a server AI that we've seen in the previous slide. It can be NVIDIA based, or it can be AMD based, or it can be Intel based. And XPU is the accelerators. So it's usually maximum one server can be 8. And one XPU, it depend on the type. For example, if it's 100, it's 400 gig. GB200 is also 400 gig connections. And all those XPUs, it needs to be interconnected in the switch. On the lower end, there is a back end leaf. This is for the interconnection between the accelerators. And also, we need to program our AI LLM through the front end leaf now on the upper level. So that's called a front end network that interconnect between the back end, which is GPU communications, to the external network. This is a simplified version of the cluster of AI. And what would be like previously, Pak Gali also mentioned about ChatGPT. Yeah. Arista also powered ChatGPT, and in some of the largest deployment that we help our customers, especially what we call hyperscalers, there are some of the network design to be able to interconnect all the GPUs. Like for example, 4K here in the first picture on the in the upper level, it means there is a 4,000 GPU. So in 4,000 CPU, we need two tiers of the radix. So the first tier is to interconnect between the second tier in the middle tier, and the middle tier is a switch that connect directly to the AI system or accelerators. And with this kind of setup, it can cruise up to 4,000 GPU. And if we want to grow more and interconnect more GPUs in the cluster, we can go up to 16K, 16,000 GPU, 32K, 32,000 GPU. All the network will shows like a radix in the three tier, like in the lower picture. And recently, one of our customer, they just finished deploying the 100,000 GPU cluster, one on one. It means there is a fabric interconnect between this cluster, and this is some of the number just to show you how big is the AI infrastructure. In terms of the host links, means cable connecting to the GPUs or accelerators with 100,000 GPU, it needs 98,304 cables. And the number of interconnection, like in the previous picture, in the purple side, there are around 100,000 purple links to connect 100,000 GPU, when the total is around 222,000. This requires 445 optical transceiver. So transceivers here is some network interface card that you can see in the normal PC, right? But it interconnect between the accelerators or GPU to the switches. And with this setup with 100,000 clusters, GPU cluster, it requires 1,000 switches, big switches, which is modular switches. And on the same customer, we also do two different design. The first design is using the modular. The second design is a mix between some pizza box switch. It means the dedicated switch, one rack unit, and then with modular switches. Like in the previous picture, there is a GP200, very big, like a refrigerator. So with this kind of design, the number of optics is much lower for 100,000 GPU. It means here there is a optimal implementation to use a combined modular and fixed switches to be able to implement 100,000 GPU cluster. And when we talk about AI, of course, we talk about power. Yeah. Why? Because, and this is one of the reason why a lot of Chinese company comes to Indonesia and ran AI infrastructure in Indonesia, because we still have in Indonesia, we still have power. Our PLN, they can provide power to run the AI infrastructure, because it requires very big power. Like for example, this is some GPU model like B200, H100. It can cost up to 1.2 kilowatt, the consume power of GPU. That means if we are talking about standard rack, usually standard rack for the IT, it can cost like 9 kilowatt power for one rack, 42 unit. But for AI, one rack can cost minimum is 30 kilowatt one rack, up to 100 kilowatt one rack. That's why power is one of the very concerning things in AI infrastructure. The second one is the another technology to uh, uh, to tackle this issue is the liquid cooling. But we will not talk about liquid cooling in this session. So when we are talking about the uh, data center build out, usually we are talking about in US, it's a 10 megawatt DC. But for the GPU only, for the AI, 15,000 CPU is 18 megawatt. And like the previous example, 100,000 CPU is 150 megawatt. That's the requirement for the power. Yeah. So it's very big amount of power is required, yeah, to run the AI. And this is a Google chart from Google, yeah, during the OCP or Open Compute Platform event this year, about the fluctuation of the AI, fluctuation of power in one of their data center, yeah. On the left side is non-AI workloads, purple. In the non-AI workloads, like the standard uh, traffic from the Google data center, it's the peak is only around 1.5 megawatt. But when we talk about AI, it goes 10 times. It can goes up to 15 megawatt peak throughput. It's only millisecond. So that's a very enormous resource required in AI training and inferencing. Yeah. Why or what is actually in those applications that priority flow control, ECN. It's all the technologies in the Ethernet and the memory management unit. And okay, I'll quickly run through some of the advance of data center optical modules. So when we are talking about AI, traffic is very big, very big. We talk about 400 gig, we talk about 800 gig, and the predictions of the analysis shows that in 2026, yeah, 100 gig will be peak, and then it will be replaced by 1.6 terabit Ethernet. And in 2029, it's going to be 3.2 terabit for one interfaces. And of course, the silicon also improve the technology from 5 nanometer to 3 nanometer and to 2 nanometer with enormous bandwidth. Like for example, now we have 151.2 silicon. One silicon can goes bandwidth up to 51.2 terabit per second, and it will be improved to double. So it's every years the bandwidth is double, and the chip is smaller in terms of the processing. And in terms of the power of optics or a transceiver, it from this example we can see that in the AI, optics consume a lot of power, and with the advancement of the technology, now we don't need to put the DSP inside the transceiver. Previously, we need to do the to put the DSP to do the corrections, to do the FEC, to do the corrections of the optical path, so that the end point can process the signal correctly. But now, with the advance of the technology, we don't need DSP, because the DSP can be run into the switch chip itself. And this actually reduce the amount of the power requires for running the AI data center. Like for example, using the DSP optics, thermal heat in this picture, it shows that there is some peak, yeah, during the power, and and but using the no DSP optics, it's really improve the thermal profile of the transceiver. And of course, it reduce the consumable power. Like for example, with the DSPs in 25 degrees, it needs 1700 watt for the DSP, but for non-DSP, it's only need 1000 watt. So the power saving is almost 40% by removing the DSP from the optics. And it means it can goes up to, for the US data center, $2,000 savings for using non-DSP transceiver. And this is some of the 100 gig roadmap. So meaning when we interconnect between the accelerators, we can use single mode fiber or multi-mode fiber, depending on the length that we are going to handle. And for the futures, currently people are working on 1.6 terabit per second specifications for one single interface. And some of the technology, some of the options is removing DSP on the one directions, or eliminating the DSP at all, so that it will consume less power. And there is some other that trying to do the CPO or co-package optic, meaning that between the vendor who creates the optics and the vendor who creates the chip, they create everything all together by themselves. So single sourcing. But it seems the industry doesn't really take this approach currently, yeah, because it's very, very difficult. And okay, final slide. We will share later on, but if you want to understand more about the AI, in Arista we help OpenAI, we help AMD, we help Meta, Facebook to build the AI infrastructure, and we can talk more on this on the next event. Thank you.
Okay, thank you very much, Pak Adi, and give applause to Pak Adi. Very insightful presentation. Also for me, who, yes, one of my research is about the infrastructure, but still, I look this AI infrastructure as something that really different that I know before. It's really resource exhausted like that, exhausting, and it should be a different approach than the previous data center design. So we are going to the next session, the question and answer session. So I will give a chance for two audience in here, in this room, and also in the Zoom meeting to asking question to Pak Adi Bramantio. So please, yes, gentlemen over there, Pak Iman, please.
Okay, thank you very much. My name is Iman. So you mentioned that, as we know that GPU offer impressive performance for AI, but however, according to your presentation, GPU consume more energy, or GPU are known to be power hungry. So my question is, according to your experience, is there any another solution as alternative accelerator, focusing on how to reduce, I mean, the latest technology to reduce the power consumption? And then for the second one is, I'm interested in GPU to GPU communication. How to manage GPU data synchronization when performing AI tasks? Okay, thank you very much.
Okay. Yeah, Pak Iman, thank you. That's a great question. So there are two questions. Yeah, the first one is the technology to reduce the uh, power consumption for the accelerators, right, Pak? Yeah. So far, what we've seen in the industry, the reduction of or the technology to try to reduce the power consumption is not on the accelerator itself. So why? Because for the accelerator is the brain of the AI. So they want to consume all the available resource they can, meaning they want to consume the capacity of the network that interconnect between the GPU. They want to consume the bus PCI Express that interconnect between GPU to CPU, and even like between the GPU, they want to bypass the kernel to be able to increase the performance. So we don't see any major development to reduce the power from the GPU technology itself. But what we've seen is more on the power reductions in overall AI data center footprint. For example, what we've seen is in the switch itself to interconnect between the GPU. So that's one of the technologies that our advancement that people are now working on to reduce the power of interconnect between GPU. The second one is on that transceiver, removing the DSP from the from the optics or from the transceiver. That's also reducing the footprint of the power itself. But in terms of the GPU, no, because they really want to consume all available resources for the accelerators. Yeah. And for the second question, to optimize the GPU to GPU communications, it's really depend on the switch software framework that you are using. Like for example, NVIDIA, it has their own NCCL using CUDA, and by default, as far as I know, it's using the uh, uh, all reduce mechanism, meaning it will try to spread all the uh, job workloads to any available GPU. So they have their own mechanism, and some of the open source software framework also have their own uh, uh, model or approach. So and it has different. I mean, it depends on what you are looking and what task that you want to perform. But it's a plus minus lah between each of the framework. Yeah. But mostly if you are using NVIDIA, then NCCL is the framework that people is usually use. But there is also PyTorch and some other mechanism for the GPU to GPU communications. Yeah. Hope that answer your questions, Pak.
Okay, Pak Imam, how is it? Okay, it's good. Okay, thank you for the question and answer from Pak Adios also. And is there any other? Yes, please.
Thank you, Pak. Thank you, Pak Di, for your presentation. This is Marlin from Research Center for Electronics. As a part of your Arista company, because we are mostly students, university students and researcher in the government, can we ask your advice or suggestions? What kind of aspect that we need to improve, we need to learn, we need to improve our understanding in order to give more contribution in this AI industries? I think, yeah, from the Indonesian environment. Yeah, thank you.
Thank you, Pak. That's a very good question. So what I've learned, yeah, so far with the as a working for a U.S. company, yeah, I learned that all of the technologies that implemented, especially on the AI, actually it's all about making things simple. So if I would suggest the students to be able uh, to understand or maybe making more innovative solutions on the AI, especially in the AI networking, is come back again back to basics. All of this technology was already there since 20, 30 years ago. Like we call it dynamic load balancing, priority flow control. It's all on the textbook. But then how it is implemented, it's really trying to focus on the problem, not and trying to make it more simple. Why? Because when we design something, especially in the networking, yeah, as simple as possible, then we can scale. We can scale. Otherwise, it's very difficult if we already design something very complicated. We cannot scale. We want to increase the amount of the network that interconnect to our design. It will be very, very difficult. So I would suggest the students and everyone who wants to learn about AI is first is back to basic. All the technologies already there, but then people trying to improve everything with the advance of semiconductor, advance of processing, and then make trying to make things simple, make things simple. Because I haven't seen the technologies, yeah. Like for example, recently Arista come out with solution together with Facebook to create some sort of uh, how to say, we call it a distributed edge solution. That distributed edge solution is actually similar to technologies done in to 2020, sorry, early 20s, early 2000s, sorry, early 2000, where the line card is just like extended to be used by just standard fiber optic cables. So all the technologies that actually done couple years ago, it's just like reinvent again to be able to solve the existing or the current problem. And because of that, I think the technology is like we already have the solution for the issues that currently we face in the industry. But we just need to make sure that we have a strong basics, and then we our approach is keep it simple first. Yeah. So I think that's my suggestion, Pak. Yeah. Thank you.
Okay. Is that answer your question? Well, okay. Thank you, Pak Adi. And I'm sure there are still a lot of people here and also in the Zoom meeting who want to asking question to Pak Adi Bramantyo, including me actually, because I'm so curious about all of the technology that is shown by Pak Adi. Like Pak Adi said before, this is actually consists of the component that already exists since years ago. But we face the different situation here that need the different way to thinking. And of course, the capacity, the different capacity for running all of these things. So maybe if I talk too much, there will be not enough time for the next session. So we are going to finish this session. And once again, thank you for Pak Adi Brantio for coming to Bandung.
Thank you, Pak Gali.
And now we will give appreciation for Pak Adi Bramantyo.
Yeah. Okay, thank you, Mr. Adi Bramantyo from Arista Network. Please keep on the stage. Oh yeah, wait a bit. And also thank you to Mr. Gali Nugraha Nurkafi for the second keynote talk of ICRAMET 2025. But now I'd like to invite Dr. Budi Prawara, the chairman of the Research Organization for Electronics and Informatics from National Research and Innovation Agency or BRIN Indonesia, to give the token of appreciation to Mr. Adi Bramantyo. Thank you once again, Mr. Adi. Okay, now we have now reached the closing of the day one of ICRAMET 2025. As we conclude today's session, I would like to express sincere appreciation to all speakers, participants, organizers, and also our patrons for their valuable contributions. And we look forward to welcome you again tomorrow for the second day and the final day of ICRAMET 2025. Tomorrow we will have two keynote talks, one patron talk, 5 paper presentation session, as well as the closing ceremony. Please join us again tomorrow at 7:30 a.m. at UTC +7. Thank you. Okay, so I think we will have an announcement for the gala dinner tonight. So I would like to invite all of you for all the keynote